Welcome to Mr. Darkness. Tonight we're heading deep into the wilderness of Alaska, a place where the forests stretch for miles, the nights seem endless, and some stories are never written down. You're about to hear dark and unsettling stories from park rangers who witness things they still can't explain. So get comfortable, turn off the lights, put on your headphones, and let the sound of rain carry you into the Alaskan wilderness. No interruptions, no distractions, just rain, darkness, and stories from the wild. Thank you for listening. Now, let the night begin. When you work for the United States Geological Survey's Alaska Water Science Center, you learn early on that cold weather does strange things to electronic sensors. Batteries drop voltage without warning. Pressure transducers freeze solid inside their brass diaphragms, and condensation can freeze into tiny ice crystals that scramble digital telemetry circuits until the sun comes back up in May. That was the explanation I wanted to give. I wanted to log it as instrument failure, toss the damaged circuit housing into a green plastic disposal crate, and sign off on the seasonal audit. But my job was to make sure the streamflow data for the lost coastal stretches of the Gulf of Alaska remained accurate, and you cannot easily audit a line that has been gouged into solid metal by something operating inside a vacuum. My name is Samuel Vance. In the autumn of 2014, I was 34 years old, working as a hydrologic technician for the Bureau. My primary assignment that field season was to inspect, recalibrate, and retrieve seasonal data from 7 automated stream gauge stations dotted along the remote coastal shelf between Yakutat and Controller Bay, specifically the isolated delta plain surrounding Cape Yakataga. Cape Yakataga is not a place people visit unless they are paid to be there or have run out of places to hide. It sits on a narrow, tempestuous strip of black volcanic sand and gravel, wedged between the roaring, ice-choked waters of the Gulf of Alaska and the towering, glacier-draped wall of the Robinson Mountains. There are no roads into Yakataga. The nearest town with a grocery store is Yakutat, roughly 70 miles to the east across impassable tide flats, braided glacial rivers, and impenetrable thickets of Devil's Club and Sitka spruce. The only way in or out is by bush plane, landing on a rough, unpaved gravel strip that was originally scraped out of the tundra in the mid-20th century for emergency military landings and oil exploration crews that gave up decades ago. My field partner that season was Marcus Albright. Marcus was 52, a veteran hydrologist who had spent 25 years walking the river basins of the Alaskan interior. He was a tall, stoic man from Idaho who spoke only when necessary and treated data collection with the unyielding discipline of a church service. He didn't care for field theories or campfire speculation. If a pressure transducer gave an impossible reading, Marcus assumed the sensor was cheap, the cable was pinched, or a brown bear had chewed through the PVC conduit. We had been dropped at the Yakataga airstrip in mid-September by Arnie Lindquist, an air taxi pilot out of Yakutat who flew a battered, tundra-tired Cessna 206. Arnie dropped us off with 3 weeks of freeze-dried rations, 4 50-gallon drums of aviation fuel for our generator and snow machines, 2 ruggedized Panasonic Toughbooks, a pair of satellite phones, and 6 heavy aluminum cases packed with current meters, leveling transits, and replacement logger boards. He didn't turn off his engine while we unloaded. He just stood on the wing strut, watching the gray wall of ocean fog rolling in over the black sand beach a quarter-mile south. He told us the weather window was closing faster than usual that year. He said if the coastal gales started early, the sea fog would drop right down to the beach grass and pin us to the coast until November. He gave us a brief nod, pulled his door shut, and banked hard out over the surf, leaving us alone with the sound of the wind through the beach wildry and the endless heavy booming of the Pacific Ocean. Our base of operations was a weather-beaten, 16 by 20-foot plywood shelter built by the federal government during the Cold War. It had a rusted corrugated tin roof, a small oil-burning stove, 2 steel cots, and a wooden desk bolted to the floorboards. It smelled of creosote, dry rot, diesel fuel, and old wool. Outside, the landscape was a stark, brutal monochrome. Vast black gravel river bars, gray silt channels carrying ice-cold meltwater down from the Bering Glacier, and miles of giant driftwood trunks, bleached white like monster bones, tangled along the high tide line. Our first 3 days were spent doing routine maintenance on the lower stream gauge station, designated Station 15288,000, located 3 miles inland on the main branch of the Yakataga River. The setup consisted of a stilling well, a vertical 20-foot corrugated steel pipe sunk into the riverbank and connected to the river channel by 2 horizontal intake pipes, and a small fiberglass shelter box mounted on top. Inside the box sat the data logger, powered by a 12-volt deep-cycle battery connected to a small solar panel, and a mechanical float system that measured the water level as it rose and fell inside the well. It was on the afternoon of the 4th day, while pulling the winter data logs from Station 15288,000, that we found the first anomaly. The digital log file was stored on a solid-state memory card that had been recording stage height every 15 minutes since the previous October. I plugged the card into my laptop inside the shelter, running the standard USGS validation script to plot the water level curve against time. The line began normally enough. You could trace the autumn rains of the previous year as sharp, jagged peaks on the graph, followed by the steady, smooth decline of late November as the ground froze solid and the river's source glaciers locked up for the winter. Through December and January, the water level remained at a stable, flat base flow of approximately 1.4 feet. Then, on February 12th at 03:15 a.m., the line changed. It didn't drop to 0, which would indicate a frozen intake pipe or a dead sensor. It didn't spike, which would suggest a flash flood or ice jam. Instead, it began to draw a perfectly symmetrical, continuous sine wave. The water level inside the sealed, frozen stilling well began rising and falling by exactly 9 inches every 22 seconds. I stared at the screen, running my thumb across the glass. A 9-inch water level fluctuation inside a vertical steel pipe during the dead of an Alaskan winter is a physical impossibility. The river outside was frozen under 3 feet of solid blue ice. The water inside the stilling well should have been motionless, isolated from the wind, tide, and current. Yet for 96 consecutive days until the spring thaw in May, the sensor recorded that steady, unbroken pulse. I called Marcus over to look at the monitor. He leaned over my shoulder, smelling faintly of pipe tobacco and damp canvas, and squinted at the blue line tracing across the grid. He told me it was a mechanical harmonic. He reasoned that the float cable must have caught on an ice wedge inside the pipe, and the wind blowing across the top of the vent tube had set up a standing resonance. I reminded him that the vent tube was fitted with a baffled cap specifically designed to prevent wind draft, and that a stainless steel float tape doesn't oscillate with a perfect 22-second period for 3 months without stopping. Marcus didn't argue. He just picked up his toolkit, grabbed his heavy wool jacket, and said we were going back out to open the stilling well. The air had turned crisp and raw by the time we reached the riverbank. The sun was sitting low and pale over the gulf, casting long, bruised purple shadows across the black sand flats. The Yakataga River ran dark and fast, carrying slush ice that clinked like broken glass against the gravel bars. We reached the gauge box perched on its timber scaffolding over the riverbank. Marcus unlocked the heavy brass padlock securing the outer fiberglass housing. Everything inside looked pristine. The dry cell battery showed a solid 12.6 volts. The solar controller was functioning. The desiccant packs were dry and blue. Then I opened the top hatch of the corrugated steel stilling well and lowered a high-lumen halogen flashlight down into the dark, vertical pipe. The well was 20 feet deep and 2 feet wide. The interior walls were rusted steel, dripping with cold condensation. At the bottom, the water reflected the bright white circle of my beam. The float, a 6-inch hollow copper sphere suspended from a perforated stainless steel tape, was gone. It hadn't fallen into the water. The stainless steel tape had been neatly unthreaded from the counterweight pulley, coiled into a tight, perfect circle, and wedged securely into a structural seam 12 feet down the pipe, well above the highest recorded water line. I stared down into the dark well, the cold air rushing up against my face. To reach that seam 12 feet down a 2-foot wide steel pipe, someone would have had to reach straight down through the narrow housing hatch with an arm 6 feet long or lower a tool with extraordinary dexterity, unthread the counterweight, wind the steel tape, and wedge it tightly into the steel joint. Marcus looked over my shoulder, his flashlight beam joining mine in the dark hole. He didn't say anything for a long time. The only sound was the rushing of the glacial river beneath our boots and the distant rhythmic thump of the ocean surf pounding the outer beach. He reached down, took the flashlight from my hand and shined it down the sides of the pipe again. He pointed at the copper counterweight. It was resting at the bottom of the well, submerged in 18 inches of clear water. But it wasn't resting flat. It was jammed vertically into the silt, as if it had been driven into the mud with considerable force. Marcus turned off his light. He told me the winter ice must have expanded inside the pipe, pushed the float up, and snapped the tape assembly. He said the wind must have spun the pulley until the tape wrapped itself around the internal bracket. His voice was flat, matter of fact, but I noticed he didn't look me in the eye when he said it. We walked back to the cabin in silence. The twilight in coastal Alaska during late September dies slowly, fading into a murky, bruised gray that blurs the line between the ocean and the sky. By the time we reached the shelter, the fog had lifted off the surf line and was drifting inland, wrapping around the stunted Sitka spruces like shredded cotton. That night, the temperature dropped to 22 degrees Fahrenheit. The small oil stove in the corner of the cabin creaked and popping as it threw out a weak orange heat. While Marcus sat at the table logging our daily equipment checks in his paper field journal, I opened the second data box we had retrieved that afternoon, Data Logger 04B. This was the auxiliary digital unit from station 15288,000, a high-precision pressure transducer system that had been installed 2 years prior as part of a joint study with the University of Alaska Fairbanks. The transducer unit was a sealed cylinder of surgical-grade stainless steel, containing a micro-thin quartz crystal that measures changes in hydrostatic pressure. It sat directly in the riverbed, connected to the surface by a heavy, steel-armored cable. I unscrewed the pressure casing to access the internal backup flash strip, the small copper ribbon designed to record raw frequency data in the event of a mainboard failure. That was when I found the scratches. The internal copper strip was secured inside a hollow glass tube filled with dry nitrogen gas. The tube was sealed at both ends with thick, epoxy-potted brass caps. There was no way to open the tube without shattering the glass. Yet inside the sealed glass, the polished surface of the copper ribbon had been covered in tiny, meticulous gouges. Under my hand lens, they didn't look like accidental scratches. They were uniform, parallel lines, cut at precise intervals of less than a millimeter. I turned the ribbon under the light. The lines formed a continuous, spiraling pattern down the 2-inch length of the strip. It looked like a thread cut into a bolt, or the continuous groove on a vintage dictaphone cylinder. I set the lens down. My hands were completely cold, though the stove was only 4 feet away. I asked Marcus if he had ever seen a nitrogen-sealed optic tube suffer internal mechanical delamination. He didn't look up from his field book. He said no, adding that if a seal failed, moisture would get in and cloud the glass. I picked up the glass tube and held it up to the kerosene lantern on the desk. The glass was crystal clear. There was no moisture, no fogging, no oxidation on the copper. Just those microscopic, geometric cuts and the tiny dusting of bright brass filings lying in the bottom of the vacuum chamber. I set the tube down on the desk beside my laptop. I didn't tell Marcus what I was thinking. I didn't want to say it out loud, because saying it out loud would sound like the delirium of a man who had been out in the bush too long. But I knew that pattern. It matched the sine wave from the float logger graph, the same 22-second interval, carved physically into the metal inside an airtight glass housing. Outside, the wind picked up, shifting from the northern mountains to the ocean south. It brought with it the thick, heavy dampness of the Gulf, rattling the tin roof of our shelter and driving rain against the eastern window pane. At midnight, the radio on the desk crackled to life. We kept a VHF marine radio tuned to channel 16, the international distress frequency, as well as our field frequency for air traffic out of Yakutat. It was mostly static, a low, washing hiss that rose and fell with the atmospheric conditions over the water. I was lying on my cot, staring up at the bare rafters, when the static changed tone. It didn't break into a voice. It didn't open with a call sign. The continuous white noise simply collapsed into a sharp, dry, rhythmic clicking sound. Tick, click, clack, tick. It was a sound I had heard 1,000 times in hydrographic field offices. It was the distinct mechanical sound of a clockwork drive gear, the escapement mechanism of an old-fashioned spring-wound Stevens paper chart recorder. The USGS had stopped deploying mechanical clockwork chart recorders in Alaska in the late 1970s, replacing them entirely with electronic loggers and satellite telemetry. I sat up on my cot. The shelter was dark except for the dull red glow of the oil stove burner. Marcus was lying on his side across the room, his back to me, his breathing heavy and even. The clicking came through the small speaker of the VHF unit with incredible clarity. It was steady, unhurried, echoing slightly as if the mechanism were sitting inside a large, hollow metal space, like the interior of a steel stilling well. Tick, click, clack, tick. Then came a sound underneath the ticking. It was a faint, wet dragging noise, accompanied by the distinct sound of cold water splashing against metal. It sounded like someone standing waist-deep in a flooded pipe, slowly lifting a heavy iron weight and dropping it back into the mud. I got out of my cot, my bare feet cold against the wood floor, and stepped over to the desk. I reached out to adjust the squelch knob on the radio. As my fingers touched the plastic dial, the clicking stopped instantly. The speaker returned to the flat, meaningless hiss of atmospheric static. I stood there in the dark, listening to the rain hammering against the roof. I looked down at the desk. In the dim light of the stove, I saw the small glass optic tube I had set down earlier. It had rolled across the flat surface of the wooden desk. It was now resting against the edge of my laptop keyboard, locked against the frame. The desk was perfectly level. I had shimmed the legs myself with cedar shingles 3 days prior. I didn't go back to sleep that night. I sat at the desk, watching the small green power light on the radio flicker in the dark. waiting for the sun to bring back the gray light of the coastal morning. By dawn, the wind had driven the fog deep into the forest, leaving behind a low, leaden ceiling of clouds that hovered less than 300 feet above the beach. The air was wet and freezing, coating the tall beach wildry in a clear sheath of glaze ice. At 7 in the morning, I tried to call Arnie on the satellite phone to check the 3-day weather forecast. The phone searched for a signal for 4 minutes before returning a connection error. The dense cloud deck, combined with our location directly beneath the steep vertical rise of the Robinson Range, had cut us off from the orbital arc. Marcus woke up at 7:30. He made no mention of the radio or the storm. He fried salt pork and rehydrated eggs over the propane burner, ate in silence, and then spread our topographic maps across the table. Our schedule called for us to trek 5 miles east along the coastal plain to inspect Station 1528 8005, situated near the mouth of the Kaliak River. The Kaliak is a wide, treacherous glacial stream that drains the western edge of the Bering Glacier. It runs fast, milky gray with rock flour, and is prone to sudden violent surges when ice dams break upstream in the mountains. The trail to the Kaliak was non-existent. We walked along the crest of the black sand beach, wedged between the crashing Pacific breakers on our right and the dense, swampy wall of the spruce forest on our left. The walk was grueling. Every step sank 2 inches into the loose volcanic gravel. Huge piles of ocean debris littered the high water mark. Tangled commercial fishing nets, blue plastic floats, rusted Japanese glass buoys, and thousands of massive Sitka spruce logs that had been swept down coastal rivers during past gales and cast back onto the land by the ocean. As we walked, I noticed that Marcus was keeping his head down, scanning the wet sand just above the tide line. I asked him what he was looking for. He didn't stop walking. He said he was looking for bear tracks. He said the coastal brown bears were moving down toward the river mouths to feed on the last of the dying silver salmon before hibernation. But I knew what bear tracks looked like. A brown bear's track in wet volcanic sand is deep, wide, and unmistakable, showing 5 clear claw marks and a heavy heel pad. The marks Marcus was watching were different. Every 100 yards or so, near the line where the salt foam washed up over the gravel, there were broad, shallow depressions in the sand. They were 2 feet wide, smooth in the center, and slightly rounded at the edges, as if a long, soft, heavy object had been dragged out of the surf, pulled itself along the gravel for 20 or 30 feet, and then slid back into the churning gray water. They weren't sea lion tracks. A sea lion leaves jagged, torn flipper marks in the sand as it hitches its weight forward. These tracks were completely smooth, leaving no drag marks from limbs or tails, just a clean, heavy groove that pressed the black sand down so hard the ocean water couldn't wash the shape away immediately. Marcus didn't point them out, and I didn't ask him about them. We simply adjusted our pace, walking faster, keeping our eyes fixed on the gray horizon ahead. We reached the Kaliak River Station at 11 in the morning. The setup here was different from the Yakataga site. Because the Kaliak's banks are unstable gravel that shifts with every seasonal flood, the USGS had installed an overhead cableway, a heavy steel cable anchored to massive timber A-frames on either side of the 300-foot-wide river channel. A small open-air aluminum cable car hung from the main line, allowing hydrologists to roll themselves out over the roaring whitewater current to take discharge measurements with a suspended lead-sounding weight. The stream gauge housing sat at the base of the north A-frame, mounted on heavy wooden pilings driven 8 feet into the river gravel. When we reached the site, we found the A-frame standing intact, but the steel cable car was swinging slowly in the wind 60 feet out over the middle of the river. It wasn't supposed to be out there. When not in use, the cable car was locked to the north anchor frame with a 1/4-inch braided steel safety tether, and a heavy brass padlock to prevent the wind from driving it out across the span. The safety tether had been cut. It hadn't been sheared with wire cutters. The individual steel strands of the braided cable were frayed, untwisted, and stretched thin at the break point, as if the tether had been pulled with immense, steady tension until the cold steel simply gave up and snapped. Marcus stood at the edge of the riverbank, looking up at the dangling car. The wind was blowing hard off the glacier now, bringing down a fine, biting mist that smelled of ancient ice and wet stone. He pulled a pair of heavy leather gloves from his pocket, reached for the secondary pull rope attached to the car, and began hauling the aluminum cage slowly back toward the bank. The rope was wet and stiff with ice. As Marcus pulled, the rusted pulleys overhead shrieked against the main cable, a high, metallic scream that seemed to echo back from the dark spruce forest behind us. When the car reached the platform, Marcus locked the brake lever and looked inside. The floor of the aluminum car was covered in a thick layer of wet, black river silt. Mixed into the mud were 3 items. The first was a pair of brass leveling screws from a 1950s-era surveyor's transit. The second was an official USGS discharge field book, a waterproof yellow pocket notebook, with its pages completely saturated with ice water. The third was a heavy 75-pound teardrop-shaped lead-sounding weight, used for measuring deep, fast-flowing river currents. The sounding weight was supposed to be stored inside a locked steel toolbox bolted to the platform floor. The steel box was still locked tight with a heavy deadbolt, yet the weight was sitting outside the box, resting in the middle of the cable car floor. Marcus reached down and picked up the yellow notebook. The paper was swollen and pulpy, but the pencil markings on the top page were still legible. The handwriting was neat, slanted, and precise, the unmistakable hand of a trained field engineer. The top line read, Station 1528805, Kaliak River at Cape Yakataga, October 14th, 1958. Below it were 3 lines of stage readings, followed by a brief note written in the margin. Channel depth increasing without velocity change. Riverbed material soft, mobile. Intakes submerged 12 feet. Bottom sounding hits non-aqueous resistance at 10-foot mark. Object is smooth, curved, extending across whole bed width. Cold line rising. Below that line, the pencil had dragged off the bottom of the page in a long, dark, erratic mark that tore straight through the waterproof paper. I looked at Marcus. His face was gray, the skin around his mouth tight and pale. I asked him if he knew who had been working the Yakataga run in 1958. He didn't answer right away. He closed the wet notebook carefully, wrapped it in a piece of clear shop plastic from his pack, and tucked it deep into his waterproof parka. He said there was a 3-man survey crew sent down by the regional office in Juneau in the autumn of '58 to establish permanent baseline cross-sections for the coastal rivers. They were supposed to be picked up by a coastal tender ship in late October. The tender arrived on October 20th. They found the crew's camp on the Yakataga Spit completely intact. The tents were standing, the food was stored in sealed tin drums, and their radios were functional. Their boat, a 16-foot heavy wooden skiff, was found washed up on the sand spit 3 miles west of the river mouth. The outboard motor was tilted up, the fuel line was disconnected, and the brass drain plug had been removed from the transom and laid neatly on the center thole pin. The men were never found. The Coast Guard searched 40 miles of shoreline from Cape Suckling to Yakutat, but found no bodies, no flotation vests, and no trace of their survival gear. The official report concluded they had been caught in an unseasonable autumnal gale while attempting to take a late-season stream discharge measurement from an unanchored skiff. Marcus looked out over the gray, boiling water of the Kaliak River. The mist was thickening now, turning into a steady, freezing downpour that blurred the distant southern bank into a ghost image of black trees and dark water. He said we were done for the day. He said we were going back to the base shelter, packing our gear, and calling for an emergency extraction as soon as the satellite window opened. I didn't argue with him. We turned back toward the coast. By the time we hit the beach strand, the wind had grown into a full coastal gale. The Pacific Ocean was no longer breaking in neat rows of white water. It had turned into a chaotic, churning wall of gray brine that threw sea foam 30 feet up the sand, washing over the drift logs and splashing against the base of the coastal tundra bluffs. Walking into the wind was like walking into a wall of wet sand. We had to tilt our heads down, squinting through the glare of our rain hoods, pulling our collar zippers tight against our chins. Halfway back to the shelter, I stopped. I looked down at the gravel at my feet. The trackway was back. This time, it wasn't a single shallow groove near the tide line. There were 3 distinct broad drag paths coming straight out of the roaring surf. They cut across the wet gravel, crossed the high water log line, and continued directly into the tall, frozen wilderness grass at the base of the spruce forest. They moved parallel to each other, spaced roughly 6 feet apart, pressing the heavy volcanic gravel down into smooth, flat trenches 18 inches wide. I stepped off the gravel ridge and walked toward the edge of the tree line where the tracks disappeared into the dark moss and devil's club thickets. The forest was completely silent, protected from the ocean gale by the dense canopy of ancient Sitka spruce. The air inside the tree line smelled of damp needles, rot, and something else. Something bitter, cold, and metallic, like copper wire stored in a wet iron box. Standing in the moss, 4 feet inside the forest margin, was a wooden survey rod. It was an old-style 8-foot Philadelphia leveling rod, constructed of yellow-painted maple wood with oxidized brass fittings and hand-painted black foot markers. The wood was completely gray with age, split by decades of frost and rain. But it was standing perfectly upright, driven 18 inches into the soft, mossy earth. At the 4-foot mark on the rod, a small piece of copper wire had been wrapped tightly around the wood. Attached to the wire was a heavy brass property tag stamped with 3 letters and a 4-digit number, USGS, 1958. I reached out my gloved hand to touch the wood. The moment my fingers brushed the gray maple, a sound came out of the deep forest behind the rod. It wasn't an animal call. It wasn't the wind in the branches. It was the distinct, wet, mechanical sound of a brass cable drum turning under heavy load. The rhythmic clack-clack-clack of a ratchet powell dropping into a steel gear, accompanied by the slow straining groan of high-tensile steel wire being pulled taut through cold water. I backed out of the tree line immediately, my boots slipping on the wet gravel of the beach strand. Marcus was 30 yards ahead of me, his head down against the wind, his heavy pack surging up and down with his stride. He hadn't seen me stop. I ran to catch up to him, my heart hammering against my ribs, the cold air burning my lungs with every breath. I didn't tell him about the survey rod. I didn't tell him about the sound of the cable drum in the dark spruce. We reached the shelter at 4 in the afternoon. The sky was already blackening into night, the gale driving sheets of freezing rain against the tin siding until the noise inside the small plywood room sounded like standing inside a drum. Marcus immediately went to the radio. He flipped the power switch on the satellite phone, extended the folding antenna, and held it up to the small window facing south toward the ocean. The screen lit up with a pale blue glow. Searching for signal. No service available. He tried 3 times, turning the unit, resetting the battery, re-entering our station location coordinates. Nothing. The storm system sitting off the Gulf was too deep, the cloud layer too thick, the atmospheric ionization too high. We were completely cut off. He set the phone down on the wooden desk, sat down on his cot, and unlaced his wet leather boots. He told me we would wait until morning. He said if the weather cleared even slightly by noon, Arnie would fly down the coast to check on us. He said Arnie was an old pilot who knew the Yakataga beach and wouldn't leave two men sitting in a coastal shelter during an October gale if there was a 200-foot ceiling he could fly under. I didn't answer him. I lit the oil stove, set a pot of river water on the burner to boil, and pulled our equipment loggers out of their protective cases. I couldn't leave them alone. I opened the Panasonic Toughbook, booted the hydrographic analysis software, and plugged in the data cable from Data Logger 04B, the pressure sensor unit with the scratched copper strip. I wanted to run the raw acoustic data file through a digital signal filter. The unit's internal hydrophone had been recording low-frequency ambient underwater sound from the riverbed alongside the pressure data. I donned a pair of heavy rubber-insulated field headphones and opened the audio file for February 12th, the night the sine wave started. The audio began with the dull, continuous background roar of the Yakataga River, the low-frequency rumble of water moving over cobbles, mixed with the sharp, erratic clinking of river ice sliding along the bank. Then at precisely 03:15 a.m., the background sound dropped away. It didn't fade out. It was instantly dampened, as if someone had placed a thick, heavy woolen blanket directly over the underwater microphone intake. The river roar became a muted, hollow hum. Through the hum came a voice. It was faint, drowned in static and hydrographic hiss, but it was unmistakably human. It was reading numbers. The voice was dry, flat, and completely devoid of inflection, speaking with the clear, measured cadence of an old-time radio announcer or a military observer recording target coordinates. Station 15288000, stage elevation 9.4, channel clearance 0. The voice paused for 6 seconds. During the pause, I heard the clear metallic click of a spring wound stopwatch button being depressed. Bottom material, displaced, sensor intake, enclosed. Repeat, sensor intake, enclosed. The voice continued for 40 minutes, repeating the same 4 lines at exact 22-second intervals, the precise period of the sine wave carved into the copper ribbon and logged by the float tape. I pulled the headphones off my ears and set them down on the wooden desk. My hands were shaking so hard I could barely guide the cursor to close the audio application. I looked over at Marcus. He was sitting on the edge of his cot, holding his pocket knife in one hand and a small piece of spruce firewood in the other. He wasn't carving the wood. He was just holding the blade against the grain, staring at the small oil stove burner. He asked me what was on the tape. I told him it was just signal noise, hydrodynamic interference from ice buildup around the intake ports. He looked up at me then. His eyes were small, bloodshot, and sunken deep into his skull. He told me I was a terrible liar. He stood up, walked over to the desk, and picked up the heavy brass padlock we had removed from the Kaliak cableway platform earlier that day. He set it on the desk beside my laptop. He told me he had checked the serial number stamped on the shackle while I was lighting the stove. The padlock didn't belong to the Alaska Water Science Center. It was an old department of the Interior issue lock, marked with a 3-digit code that corresponded to the 1958 field inventory ledger, the ledger that belonged to the 3 men who had vanished off Yakataga Spit 56 years before. He said the lock hadn't been cut or picked. The shackle was open because the bronze key was still turned inside the keyhole, a key made of solid brass that showed 0 rust, 0 tarnish, and was coated in a thin, fresh film of cold river silt. Neither of us spoke after that. The storm reached its peak at 2 in the morning. The wind was no longer coming in gusts. It had turned into a continuous screaming wall of air that lifted the edges of the tin roof, rattling the iron nails in their timber purlins until the whole cabin shuddered and groaned against its concrete footings. The high ocean tide was pushing the Pacific surge straight up the mouth of the Yakataga River. We could hear the river rising, a heavy, churning roar that crept closer to the shelter with every passing hour. At 2:20, the oil stove went out. The wind had driven a backdraft down the iron chimney pipe, blowing the pilot flame clear off the burner ring and filling the small cabin with the sharp, choking reek of vaporized diesel fuel. I got out of my cot with my headlamp, reached for the fuel shut-off valve on the wall, and closed it tight. The room immediately began to cool. The temperature inside dropped rapidly toward freezing as the coastal gale whistled through the narrow gaps in the plywood walls. Marcus was standing by the south window, holding his heavy 4-cell Maglite flashlight. He was looking out through the rain-streaked glass toward the beach strand. I walked over to stand beside him. The flashlight beam could barely penetrate the rain and ocean spray. It illuminated 6 feet of glistening, ice-sheathed wildry grass and a wall of horizontal white water driving across the gravel. Then the light hit something standing at the edge of the beach grass, 30 feet from the cabin door. It was a figure. It was dressed in a heavy, full-length yellow oilskin coat, the old-fashioned, stiffened canvas rain gear worn by coastal mariners and field workers in the early half of the 20th century. It was standing perfectly still in the middle of a 60-knot gale, its back turned toward the cabin, facing out toward the boiling gray chaos of the Gulf of Alaska. It held a long timber pole upright in its right hand, an 8-foot maple leveling rod held perfectly vertical against the wind. The beam of Marcus's flashlight flickered across the back of the figure's coat. The coat was torn open down the center seam, revealing the dark, soaked wool shirt beneath. The fabric wasn't moving in the wind. Despite the 80-mile-an-hour gusts whipping through the wildry grass, the yellow oilskin hung flat, heavy, and lifeless, as if it were made of solid lead or frozen canvas. Marcus didn't move the light. He held the thick aluminum tube of the flashlight in both hands, his knuckles white, his breath coming in short, ragged plumes in the freezing air of the cabin. Then the figure began to turn. It didn't turn its feet. It didn't step on the gravel. The entire upper torso rotated with a smooth, mechanical motion, turning slowly on its axis until its left profile was visible in the pale beam of the flashlight. Where its face should have been, under the dripping wide brim of the yellow oilskin hat, there was no skin, no eyes, no nose. There was only a solid, opaque mass of gray river silt, smooth and frozen, into which 2 clean horizontal intake holes had been cut, identical to the intake ports of a steel stream gauge stilling well. A sound came from the radio on the desk behind us. The VHF speaker, turned off at the main power switch 3 hours before, began to vibrate with a high, clear, harmonic tone. It wasn't static. It was a synthesized 1000 Hz reference tone, the precise calibration frequency used to zero out field hydrophones. The tone ran for 3 seconds, then cut out. Then came the voice again, loud and sharp, coming directly through the unpowered speaker cone. Station 1528, 8000. Stage elevation 12.2. Warning. Stage elevation 12.2. Structure submerged. Vacate baseline. The figure outside lifted its left hand. It wasn't a hand. It was a heavy, 3-jaw bronze sampling clamp, holding a stainless steel float tape that unwound from its sleeve in a long, shining silver ribbon that trailed off into the dark surf behind it. Marcus dropped the flashlight. It struck the wooden floorboards, rolled twice, and illuminated the bottom of the front door. A thin, dark line of water was slowly seeping under the door threshold. It wasn't ocean salt water. It was thick, milky gray glacial water, carrying fine black sand and wet river silt that spread across the wood floor in a wide, creeping hand toward our cots. Marcus ran to his gear bag, grabbed his heavy rubber hip boots, and began pulling them on over his wool trousers. His hands were frantic, his face completely drained of color. He kept repeating 3 words under his breath over and over like a mechanical chant. The cables snapped. The cables snapped. The cables snapped. I grabbed him by the shoulders, shaking him hard, forcing him to look at me. I yelled at him that we couldn't go outside. I told him the coast was in a storm surge, the river was flooding, and if we stepped out into that beach grass in the dark, we would be swept out into the Gulf within 50 yards. He looked at me, his eyes wide, wild, and glassy. He didn't hear a word I said. He shoved me back against the desk with incredible force, throwing his weight against the cabin door, throwing the iron bolt open, and stepping straight out into the freezing gale. I screamed his name into the rain, grabbing my own heavy coat and headlamp, and lunged out the door after him. The wind hit me like an iron beam, knocking me to my knees in the wet gravel. The air was deafening, a roaring, terrifying wall of sound made up of wind, ocean breakers, and the tearing of tree limbs in the spruce forest behind us. I clicked on my headlamp. The narrow LED beam sliced through the driving mist, showing Marcus 40 feet ahead of me, running directly toward the flooded river mouth. He was carrying his steel survey rod over his shoulder, stepping knee-deep through the swirling black floodwater that was sweeping across the beach grass. Behind him, following 10 yards in his wake, were 3 shapes. They were not walking. They were moving through the 6-inch sheet of surface water with smooth, silent velocity, their yellow oilskins glistening under the glare of my lamp, holding their brass leveling rods like survey markers in the dark. I ran after Marcus, my boots heavy with cold water, slipping and falling on the smooth, wet drift logs that were being lifted and thrown around by the rising tide. "Marcus, stop! Get back to the ridge!" I screamed, but the wind took my voice and tore it to pieces before it reached my own ears. Marcus reached the crest of the gravel bar overlooking the lower river station. The river was no longer a contained channel. It had swollen into a 300-yard lake of boiling white water, carrying uprooted trees, ice blocks, and mud banks down into the ocean surf. The fiberglass shelter box of Station 15288,000 was gone. The timber platform had been sheared off at ground level by the ice surge. Only the top 4 feet of the vertical corrugated steel stilling well remained visible above the roaring flood, leaning at a 45-degree angle against the torrent. Marcus stepped off the gravel crest. He didn't hesitate. He stepped straight into the 3-foot-deep, swift-flowing current of the river channel, moving directly toward the leaning steel pipe. "Marcus!" I reached the edge of the bank just as the current swept his legs out from under him. He went down into the freezing black water, his yellow headlamp beam spinning wildly under the surface before disappearing into the silt. I didn't think. I threw myself down onto the gravel bar, extending my 4-foot steel leveling rod out over the boiling edge of the riverbank with both hands. "Grab the rod! Grab the rod!" For 3 agonizing seconds, there was nothing but the gray water roaring past the bank. Then a hand broke the surface, a hand encased in a wet leather glove, and clamped onto the aluminum base of the survey rod with desperate, crushing strength. I hauled back with everything I had, digging my heavy boot heels into the wet volcanic gravel, screaming against the wind as I dragged Marcus's weight up the slipping mud bank. He spilled over the lip of the gravel bar, coughing, choking on ice water, his face blue, his clothes dripping with gray glacial silt. I didn't give him time to recover. I grabbed the haul strap of his life jacket, dragged him to his feet, and began forcing him back away from the riverbank. back toward the higher ground of the spruce forest bluff. Behind us, in the middle of the flooded channel, the three yellow-coated figures were standing. They were waist-deep in a torrent moving at 12 feet per second, a current strong enough to roll multi-ton boulders along the riverbed. Yet they stood completely stationary, anchored to the submerged river bottom like concrete pilings. They lifted their leveling rods in unison. The long wooden shafts rose out of the white water, catching the stray light of my headlamp. The brass fittings on the rods were bright, clean and polished, reflecting the cold white beam with blinding intensity. Then, from the top of the flooded steel stilling well, came a sound that drowned out the wind, the river, and the ocean gale. It was a whistle, a long, high-pitched, steam-driven acoustic signal, identical to the shift whistle of a 1950s coastal survey vessel entering a harbor. The tone rose in frequency, vibrating through the gravel beneath our feet, shaking the bones in my chest until my vision blurred in the dark. I turned my back on the river, threw Marcus's arm over my shoulder and hauled him into the thick, dark cover of the spruce forest. We spent the rest of the night crouched in a deep hollow behind a deadfall Sitka spruce, wrapped in a single wet emergency space blanket, shivering so hard our teeth cracked against each other in the dark. We didn't speak. We didn't turn on our lights. We simply sat in the cold mud, listening to the ocean storm smash the beach strand 300 yards away, while the high rhythmic tone on the radio frequency echoed faintly through the trees until dawn. The weather broke at noon the following day. The storm system shifted east toward Yakutat, leaving behind a sky of pale, brilliant blue and a cold, dead calm that made the flooded landscape look like a mirror made of gray glass. At 2 in the afternoon, the low, distant hum of an aircraft engine echoed down from the northern mountains. It was Arnie. He brought the Cessna 206 down onto the highest ridge of the gravel airstrip, the wide tundra tires splashing through 4 inches of standing seawater before coming to a stop 50 yards from our shelter. He left the engine idling at 800 RPM, stepping out onto the cabin step with his boots on, looking around at the shredded wildree grass and the timber wreckage strewn across the black sand. When he saw us walking out of the forest, he didn't ask any questions. He looked at Marcus, who was walking with a strange mechanical limp, his eyes fixed on the airplane's aluminum wing strut, and then looked at me. He helped us toss our dry cases into the back cargo space. We abandoned our tent, our stove, our fuel drums, and our field tools where they lay in the mud. As I climbed into the front passenger seat beside Arnie, I looked back through the plexiglass window at the Yakataga Spit. The beach was littered with thousands of silver salmon that had been tossed out of the ocean by the storm surge, lying dead and glistening in the black sand. And sitting at the high water mark, 50 yards from the destroyed cabin, was our fiberglass shelter box from station 15288,000. It had been washed 2 miles down the coast from its original foundation. It was sitting upright on the gravel bar, completely undamaged by the flood. The heavy brass padlocks were still locked in their latches, and from the small 3-inch vent tube on top of the housing, a thin, continuous plume of dry white nitrogen gas was venting slowly into the freezing autumn air. We flew back to Yakutat in total silence. Marcus resigned from the United States Geological Survey 3 weeks after we returned to Anchorage. He didn't submit a written letter of resignation. He simply walked into the regional office on a Tuesday morning, turned in his security badge and field keys, picked up his personal belongings from his desk, and drove away. Last I heard, he was living in a small retirement park outside Tucson, Arizona. He doesn't have a phone, he doesn't use email, and he hasn't spoken to anyone from the Bureau in over 10 years. I stayed with the survey, but I requested a permanent transfer to the Internal Data Quality Audit Division at the Anchorage office. I haven't set foot on a bush plane or taken a river discharge measurement since that field season in 2014. My job now is entirely administrative. I spend 8 hours a day sitting in an air-conditioned office on the 4th floor of the Federal Building, reviewing digital hydrographic records sent in by younger technicians from stations all across the state of Alaska. The official Bureau report on the events at Cape Yakataga was filed in January 2015. It concluded that Station 1528-8000 and Station 1528-8005 had been destroyed by an unprecedented autumnal storm surge combined with river ice damming. The unusual data logs were officially attributed to structural sensor damage caused by extreme mechanical tension on the transducer cables during the initial embankment collapse. The matter was closed. The Yakataga stations were officially decommissioned and never rebuilt. I didn't contest the report. I signed my name at the bottom of the audit sheet, filed the paper copy in the archive cabinets on the basement floor, and went home to my apartment. I thought it was over. Then, 3 months ago, in May of 2026, our office began migrating 60 years of legacy analog paper files into the Bureau's new cloud data network. As part of my auditing duties, I was tasked with verifying the digital scans of archived field ledgers from the late 1950s. I was working late on a Thursday evening, sitting alone in the quiet office with only the soft hum of the air handlers running in the ceiling above my desk. I opened a file folder designated USGS HYD 1958 Gulf Coast Regional. The first file was a high-resolution scan of a hydrographic stage chart from an automated roll recorder deployed near Cape Yakataga in October 1958. The chart was a long strip of green grid paper showing an ink line that tracked the water level of the Yakataga River 50 years ago. I zoomed in on the bottom corner of the scan, where the field engineer had signed off on the instrument setup before the storm hit. The signature was written in faint blue fountain pen ink. It wasn't a name I knew from the historical records. The signature read, Samuel Vance, Hydrologic Technician. Below the signature was a single line of notes, written in the same hand I use every day to sign off on my morning field audits. Transducer internal strip etched. Sine wave established at 22-second interval. Sensor awaiting arrival of secondary audit team. Do not decommission. I sat at my desk for an hour, staring at my own signature on a piece of paper that was scanned from an archived box that had been locked in an iron vault in Juneau, 8 years before I was born. I didn't print the page. I didn't save the file to my desktop. I simply closed the application, shut down my computer, and walked out of the building into the cold spring rain of downtown Anchorage. I still have one object from that season in my desk drawer at home. It is the small optic glass tube from data logger 04B, the sealed airtight cylinder that contained the etched copper ribbon. The tube has been sitting in a soft velvet jewelry box on my nightstand for 12 years. It is still completely dry. The glass is crystal clear, showing no moisture, no leaks, and no oxidation on the bright copper metal inside. Every night, before I turn off the lamp beside my bed, I pick up the tube and hold it up to the light. And every night, without fail, a tiny new hatch mark appears at the end of the spiraling thread, scratched clean and bright into the copper from the inside of the sealed glass, perfectly spaced at an interval of 0.82 millimeters, waiting for the next reading to begin. When I pulled the raw data file from the submersible pressure transducer submerged under 7 feet of hard river ice on the North Fork of the Swift River. I found an 8-hour window where the water level sensor had registered a continuous downward force equivalent to 42,000 pounds, resting directly on top of the orifice line, while the temperature probe 5 inches away recorded liquid water held at a constant 86 degrees Fahrenheit in a river channel where the ambient air temperature had not risen above 40 below zero for 3 straight weeks. In my line of work, you learn very quickly that data lies all the time. Transducers suffer from signal drift, desiccant tubes plug with moisture and freeze solid. Lithium battery packs drop voltage in extreme cold and cause internal microprocessors to spit out gibberish, and frazzle ice can build up around an intake pipe until the pressure readings look like a mountain range. I was sitting at a scarred laminate desk in the rear office of the United States Geological Survey field station on the edge of the gravel runway in McGrath, holding a warm mug of black coffee in both hands to thaw my knuckles, looking at the smooth, bell-shaped curve on my monitor. The computer was displaying a hydrograph from station 15303-800, a remote satellite telemetered stream gauge positioned on a sheer bluff along the upper Swift River, deep within the roadless interior between the Kuskokwim Mountains and the western foothills of the Alaska Range. The graph showed a perfectly stable baseline, then a sharp vertical cliff, where the water pressure skyrocketed and the water temperature surged from 32.1 degrees up to 86 degrees in less than 4 minutes, holding that flat, impossible plateau for 8 hours before dropping back down to absolute freezing at 3 o'clock in the morning on December 14th. My name is Ethan Vance. I was 36 years old at the time, working as a hydrologic technician for the USGS Alaska Science Center. It was the winter of 2013. My job was not romantic. It consisted mostly of hauling gas cans, recalibrating pressure sensors, cutting 5-foot-thick river ice with heavy gas-powered augers, clearing frost out of NEMA electronics enclosures, and making sure the streamflow data for the Kuskokwim Basin uploaded reliably to the National Public Database every 3 hours via GOES satellite uplinks. I knew the physical geography of that river network better than almost anyone outside the local Athabascan trappers. I knew where the gravel bars shifted after the spring breakups, where the sweepers hung low out of the cut banks to snag snow machine windshields, where the natural warm springs bubbled up through the permafrost near Lime Village, and where the river narrowed into deep black structural pools that never froze completely to the bottom, no matter how hard the winter hit. The Swift River site was one of our most isolated installations. There were no roads within 200 miles. In the summer, you reached it by air taxi landing on a gravel bar or by hauling a riverboat 3 days upriver from Sleet Mute through shallow, boulder-strewn riffles. In the deep winter, you flew in on skis with a local bush pilot or you didn't go at all. The station itself was simple. A heavy steel pipe called a stilling well anchored into the riverbed bedrock, a flexible synthetic orifice line running up the bank to protect the copper wiring, and a yellow fiberglass instrument shelter mounted 5 feet high on a white spruce pole to keep it above the spring flood mark. Inside that shelter sat a digital data logger, a dry cell battery, a small solar panel that was useless for 3 months out of the year, and a satellite transmitter antenna pointed at a precise spot in the southern sky. I called Marcus Lindqvist over to my desk. Marcus was 54 years old, a senior technician who had spent 31 winters gauging rivers from the Colville down to the Stikine. He was a broad, quiet man with graying stubble, skin like tanned moose hide, and a permanent slight stoop in his shoulders from spending 3 decades bent over ice augers and snow machine handlebars. He walked over holding a pair of needle-nose pliers he'd been using to wire a heater element, leaned his heavy forearms on the back of my chair, and squinted at the monitor through his bifocals. I pointed at the screen with the eraser end of a pencil and told him that the pressure transducer at 3800 must have suffered a complete diaphragm rupture or a short in the signal cable. Marcus stared at the red spike on the hydrograph for a long time without saying anything. The only sound in the office was the steady, rhythmic clatter of the oil heater in the corner, and the distant hum of a twin-engine plane taxiing out on the frozen runway outside. He reached down, took the mouse from my hand, and clicked on the diagnostic tab to bring up the secondary sensor array. The secondary array was an entirely independent, battery-powered vented transducer housed in a separate armored casing 12 feet upriver from the main intake, installed specifically to cross-check readings in case of mechanical failure. The hydrograph for the secondary sensor populated the screen a second later. The curves were identical. The secondary unit had recorded the exact same pressure spike, the exact same 42,000 pounds of downward load, and the exact same 86-degree thermal surge, starting and stopping at the exact same minute. Marcus straightened up slowly and wiped his thumb across his jaw. He didn't offer a theory. In our line of work, when two redundant instruments built by different manufacturers and powered by separate battery banks record the exact same physically impossible event at the exact same location, you don't start talking about ghosts or monsters. You assume there's a physical anomaly you haven't accounted for, a subterranean geothermal vent blowing open under the riverbed, a massive ice jam forcing hydrostatic pressure backward up the channel, or a localized pocket of methane discharging from the thawing permafrost beneath the mud. But even as I thought of those explanations, I knew they didn't hold up. A geothermal vent wouldn't exert 20 tons of direct downward pressure on a 4-inch area without scouring the riverbed gravel away entirely. And methane gas wouldn't hold liquid water at 86 degrees in a shallow, high-velocity subarctic river without melting every square foot of ice for 100 yards downriver. We decided to head out to the site on Friday. The weather forecast called for a stable window of clear, cold weather before a heavy Arctic low-pressure system rolled in from the Bering Sea early the following week. We chartered a flight with Neil Hoff, a veteran bush pilot who ran a commercial air taxi service out of McGrath using a high-wing Cessna 185, equipped with wheel skis. Neil was a thin, leathery man in his late 60s who smelled perpetually of stale coffee and aviation fuel. A man who had flown thousands of hours over the Kuskokwim drainage and knew every ridge, oxbow, and emergency landing strip between Anchorage and Nome. When we loaded our gear into the belly of the Cessna early Friday morning, the air was minus 38 degrees. The sky was a pale, hard, metallic blue, and the exhaust from the plane's engine heater rose straight up in a thick white column that hung motionless in the frozen air. We packed 2 heavy gas-powered ice augers, extra cans of 50-to-1 two-stroke fuel, 3 sets of snowshoes, a pair of Marsh McBurney current meters, a spare pressure transducer unit, our cold weather survival bags, a winter tent, an emergency satellite phone, and a 12-gauge Remington shotgun wrapped in a padded canvas case. Carrying a firearm was standard procedure for field crews in the summer because of coastal and interior grizzlies. But in December, deep in the interior freeze, bears were long asleep in their dens. We brought it mostly out of habit, and because the USGS field manual required a perimeter defense weapon on any multi-day remote winter deployment. Neil pulled the prop through by hand to loosen the cold oil, primed the engine, and fired up the 185. The engine roared, rattling the aluminum skin of the fuselage, and we taxied down the hard-packed snow strip before lifting off into the dim, amber twilight of the midwinter morning. Below us, the town of McGrath dropped away into a tiny cluster of dark wooden structures, smoke trails, and snow-draped spruce trees, surrounded instantly by an endless, white, featureless wilderness. The flight to the upper Swift River took 45 minutes. From 3,000 feet, the Alaskan interior in December looks like a dead world, painted entirely in shades of white, charcoal, and ice. The Kuskokwim River wound below us like a broad, frozen highway, its oxbows and sloughs frozen solid under layers of wind-driven drift. To the east, the ragged white teeth of the Alaska Range rose up against the low sun, casting long purple shadows that stretched 30 miles across the tundra flats. There were no roads, no power lines, no cabins, no cut lines, no sign that human beings had ever set foot on the earth. There was only the endless expanse of black spruce boreal forest, snow-covered muskeg, and frozen waterways locked in winter sleep. Neil banked the plane over the upper Swift River drainage, dropping altitude until we were skimming 200 feet above the treetops. The river here was narrow and sinuous, cutting through steep, timbered bluffs and gravel benches. We located stream gauge 15303800 easily enough. The bright yellow NEMA enclosure on its spruce pole stood out against the uniform white of the bank, like a high-visibility marker. A mile downriver from the gauge sat a small, rough-hewn log shelter cabin built in the late 1960s by the Alaska Department of Highways during a long-abandoned winter road survey. The cabin was public domain, maintained casually by passing trappers, hunters, and field technicians who kept it stocked with dry firewood, matches, and shelf-stable canned goods for emergency shelter. Neil lined the Cessna up on a long, straight stretch of frozen river ice below the shelter cabin, dropped the ski gear, and brought the plane down. The skis touched with a loud, hollow shh clack as they hit the wind-crusted snow, sliding smoothly across the ice before coming to a stop near the south bank. Neil kept the engine idling to prevent the oil from freezing up in the crankcase, while Marcus and I unloaded our heavy gear bags, augers, and fuel jugs onto the river ice. Neil leaned out of the cockpit window, his breath plume whipping away in the propeller wash. He told us he had a charter booked to drop hunting supplies in Aniak on Sunday morning, so if the weather held, he'd be back to pick us up at 10 o'clock Sunday morning. If the Bering Sea storm moved in faster than expected, he said, we'd hear him overhead by Saturday afternoon. But if the weather closed down completely, we had enough firewood and canned chili in the shelter cabin to sit out a week-long blizzard. I gave him a thumb up, stepped back from the ski track, and watched as he throttled up. The Cessna surged down the river ice, lifted off into the pale yellow sunlight, and banked west toward McGrath. The roar of the engine faded quickly into the distance, replaced by an absolute, heavy, crushing silence. That is the first thing that strikes you when an aircraft leaves you in the interior wilderness in deep winter. The silence isn't just an absence of sound. It is a physical presence. It presses against your eardrums with a heavy, cold weight. There were no birds calling, no wind in the tops of the black spruce, no water running over gravel, no distant hum of machinery. There was only the sound of our own heavy breathing, the creak of our cold rubber boots on the dry snow, and the sharp metallic pinging of the metal fuel cans cooling down on the ice. We pulled our gear up the bank on 2 plastic sleds, dragging them through knee-deep powder snow to the old highway cabin. The cabin was small, maybe 12 by 14 feet, constructed of unpeeled white spruce logs notched at the corners, with a low metal roof and a single small window made of thick yellowed plexiglass. Inside, it smelled of dry timber, old wood smoke, mouse droppings, and paraffin wax. In the corner sat a crude box stove welded together from half-inch steel plate, connected to a rusted stovepipe that extended up through the roof. Marcus set to work immediately on the shelter setup, cleaning out the stove, laying tinder from dry birch bark he'd shaved off a deadfall tree, and splitting several armfuls of spruce logs from the woodpile under the eaves. Within 15 minutes, he had a roaring fire going, the metal stove glowing dull orange at its base, pushing a thick wave of heat into the small room that smelled richly of burning resin. While Marcus prepared the cabin, I grabbed my toolkit, the handheld telemetry receiver, an ice auger, and my snowshoes, and began the 1-mile trek up the frozen riverbank to the stream gauge installation. Walking on snowshoes through river-bottom timber in minus 35 degrees is slow, rhythmic work. Every breath you draw feels dry and thin, burning slightly in the back of your throat, and the condensation from your lungs freezes instantly into a hard, white crust of hoarfrost on the fur trim of your parka hood. When I reached Station 15303-800, everything looked superficially normal. The yellow fiberglass box was bolted securely to its spruce post, completely undisturbed. The small solar panel was tilted to the south, coated in a fine layer of blown snow that I brushed off with my thick leather mitt. I unlocked the heavy brass padlock on the enclosure door, swung it open, and inspected the internal electronics. The digital logger display was active, its liquid crystal screen somewhat sluggish from the extreme cold, but reading normal system parameters. Battery voltage 12.6 volts. Internal temperature minus 18 degrees, signal strength to the Goose satellite nominal. I hooked up my laptop using an armored serial cable to pull the full raw high-frequency data buffer directly from the logger's non-volatile flash memory. As the file downloaded, I walked down the steep cut bank toward the edge of the river ice where the steel orifice line disappeared under the snowpack. The line was enclosed in a heavy, 3-inch galvanized steel conduit anchored to the bank with steel rebar stakes driven deep into the gravel bed. That was where I found the first physical evidence that something had happened at the site that defied mechanical logic. The galvanized steel conduit was bent. It hadn't been bent by a falling spruce tree or an ice jam pushing downstream. The steel pipe, 3/4-inch thick and rated for heavy structural loads, was bent sharply downward at a right angle precisely where it crossed from the gravel bank onto the river ice. The metal was distorted and crushed flattened, as if an immense, concentrated hydraulic press had clamped down on it from above. The crushed section was roughly 18 inches long, and the galvanized coating on the steel was melted and discolored, showing dark, bluish-purple heat bands characteristic of metal exposed to temperatures exceeding 500 degrees Fahrenheit. I knelt in the snow, pulling off my outer mitt to trace my bare fingers over the cold, burnt steel. The snow immediately surrounding the crushed pipe wasn't drifted loose powder like the rest of the bank. It was melted down to the bare river gravel and refrozen into a clear, solid block of hard, dense, glass-like ice that was completely free of air bubbles or frost crystals. I stood up, my heart beating slightly faster in my chest, and looked out across the river ice. The swift river at this point was about 80 yards wide. The ice was flat, covered in a uniform layer of wind-scoured snow, roughly 8 inches deep, drifting up against the willow bushes along the far bank. There were no tracks. No animal prints, no snow machine tracks, no sign of human activity. There were no downed trees, no sign of rock slides from the bluffs, no scorched vegetation on the bank above. I walked back up to the shelter box and checked my laptop screen. The raw file download was complete. I opened the high-resolution event log for December 14th. The data was far more detailed than the compressed summaries we received via satellite back at the McGrath office. The sensors sampled water pressure, conductivity, and temperature once every 2 seconds. I scrolled through the timeline leading up to the incident. At 7:12 p.m. on December 14th, the water temperature probe was reading 32.2 degrees Fahrenheit, and the hydrostatic pressure transducer registered 3.4 feet of head, standard for midwinter low-flow conditions under ice cover. At 7:12:04 p.m., the pressure reading went off the chart instantly, jumping from 3.4 feet to an equivalent water column height of over 900 feet, a localized load of 42,000 pounds over the sensor footprint. Simultaneously, the water temperature didn't climb gradually as it would if warm water were pumping into the stream. It spiked from 32.2 degrees to 86.4 degrees in 2 seconds. The event lasted for exactly 8 hours, 32 minutes and 11 seconds. Then, at 3:44:15 a.m., both values returned to their baseline instantly. Not over minutes or hours, within a single 2-second sampling interval, the pressure dropped back to 3.4 feet, and the temperature collapsed back to 32.2 degrees. I sat on an upturned wooden crate in front of the open shelter box, staring at the numbers on the glowing screen while the bitter cold slowly began to seep through my insulated bib snowpants. A thermal spike that sharp and localized should have generated an enormous cloud of steam that would have deposited inches of heavy hoarfrost on every tree branch within 50 yards. It should have melted a massive hole through the 7-foot ice sheet directly over the sensor array, creating an open water lid that would take weeks to refreeze under winter conditions. Yet the ice surface over the sensor was solid, uniform, and covered in unbroken snow. I shut down the laptop, packed it into its padded flight case, locked the NEMA box, and strapped my snowshoes back on. I wanted to get back to the shelter cabin before the low sun dropped behind the Kuskokwim bluffs and plunged the valley into the deep, blue gloom of winter twilight. When I got back to the cabin, the sun was a sliver of bloody red resting on the western ridge. Marcus was sitting on his wooden bunk near the stove, sharpening his hunting knife with an oil stone. The cabin was warm enough that he had unzipped his heavy wool shirt, and the air smelled comfortably of boiling coffee and fried salt pork. I laid out my findings on the small, rough-cut pine table between the bunks. I told him about the crushed, heat-discolored galvanized steel conduit, the solid block of clear melt ice at the gravel bank, and the instantaneous nature of the data transition. Marcus listened quietly, his stone making a steady, wet shh against the steel blade. He didn't interrupt me once. When I finished, he laid the knife down on a piece of rag, wiped his fingers, and picked up his coffee mug. He looked at the frost building up along the edge of the small plexiglass window. Marcus said that back in the winter of 1982, when he was working out of the Fairbanks field unit, they had a seasonal water quality monitoring station on the upper Salcha River, way up in the hills off the Richardson Highway. He said they had a technician named Dan Crenshaw, a man who had spent 15 years in the bush, practical, level-headed, not given to tall tales or drink. Dan went out alone in January to service a submersible water quality sonde that had stopped transmitting data. 2 days later, when Dan didn't check in by radio, the state troopers flew a plane out to his field site. They found Dan's dog team tied to a clump of alder bushes on the bank. The dogs were fed, healthy, and completely unharmed. Dan's snow machine and toboggan sled were parked out on the river ice directly over the stream gauge installation, completely undamaged. His snowshoes were standing upright in a snowdrift beside the sled. His thermal parka, his beaver skin cap, his heavy mittens, his boots, and his woolen socks were all lying on top of the river ice in a neat, organized pile, unbuttoned and untied, as if he had carefully undressed and laid his clothes out on the snow in -40 degrees. Dan himself was gone. They searched 30 miles of riverbed with dogs, helicopters, and ground crews, but they never found a single trace of his body, a footprint in the snow, or a hole through the river ice. Marcus looked across the table at me, his blue eyes flat and unreadable in the dim lantern light. He said the troopers listed it as an instance of paradoxical undressing brought on by severe hypothermia, closed the file, and shipped Dan's gear back to his sister in Minnesota. But Marcus said he had checked the weather records for the Salcha Valley for those 2 days. The temperature had been -20, cold enough to freeze exposed skin in a few minutes, but Dan was an experienced bushman wearing 3 layers of commercial down survival gear, sitting 20 feet from a timber shelter stocked with dry birch wood. A man who knows Alaska doesn't suddenly take off every stitch of clothing he owns and walk naked across solid ice into thin air because he feels a little chilly. I asked Marcus what he thought happened to Dan Crenshaw. Marcus drank his coffee, set the cup down with a soft click on the wood table, and said he didn't know, but he knew that there were things in the high country and deep river drainages of this state that were old, cold, and didn't operate on any mechanics found in a university textbook. He said the land here wasn't designed for people, and sometimes the wilderness tolerated us, and sometimes it didn't. That night, the temperature outside dropped to minus 46 degrees. Inside the cabin, the wood stove creaked and popped as the spruce logs burned down to glowing red coals. The heat sat near the ceiling in a thick layer, while down near the floorboards, the draft coming through the log seams was cold enough to freeze a damp rag solid within half an hour. I lay in my sleeping bag on the top bunk, staring up at the dark timber rafters, listening to the vast, heavy stillness of the night. At around 2 o'clock in the morning, I woke up. It wasn't a sudden noise that woke me. It was a change in the atmosphere inside the cabin. The temperature in the room had dropped dramatically. My breath was blooming in thick, heavy white clouds directly above my face, and the tips of my ears were burning with bitter cold. The wood stove was still full of glowing spruce coals, radiating a dull orange light through its intake vents, but the heat seemed completely localized, unable to penetrate more than a few inches beyond the steel plate of the stove body. Then I heard the sound. It came from beneath the cabin floorboards. The cabin was built on rough-hewn spruce sills resting directly on a bed of river gravel and permafrost silt, elevated perhaps 6 inches off the ground. From directly beneath my bunk, deep down in the frozen earth, came a sound like liquid water under massive, violent hydrostatic pressure. It wasn't the trickle of a small stream or the bubbling of a spring. It was a low, heavy, rhythmic churning sound, the muffled thrum, thrum, thrum of thousands of gallons of dense, viscous fluid moving rapidly through tiny subterranean channels in the frozen subsoil directly under the cabin floor. The sound was accompanied by a strange, low-frequency vibration that rattled the brass buttons on my wool shirt where it hung on a nail beside the bunk. The small, heavy cast-iron skillet hanging on the wall began to swing slowly back and forth, tapping against the log wall with a soft, rhythmic tick, tick, tick. I turned my head carefully toward the bottom bunk. Marcus was awake. He was sitting bolt upright in his sleeping bag, his back pressed hard against the log wall, holding his Winchester .30-06 across his lap. He had his thumb resting on the safety, his eyes wide and fixed on the rough-cut spruce floorboards in the center of the room. He didn't move. He didn't speak. He barely seemed to breathe. As we watched, the frost that had accumulated on the inside of the plexiglass window began to change. In sub-zero cold, window frost forms in delicate feather-like patterns, crystalline ferns and lace built by ambient indoor moisture freezing against cold glass. But the frost on the cabin window was melting from the inside out, turning into liquid water that ran down the pane in heavy, greasy streams, pooling on the wooden sill. As the water ran, the air inside the cabin grew strangely humid, thick with a heavy, wet warmth that carried a distinct, bizarre odor. It didn't smell like river water, decay, or sulfur. It smelled like warm, clean, sterile ocean brine mixed with the sharp, metallic tang of an industrial arc welder. The liquid water on the window pane paused. Then, within 3 seconds, the runoff stopped, turned opaque white, and refroze instantly into thick, rough sheets of solid, amber-tinted ice that sealed the window completely, blocking out the dim starlight from outside. The vibration beneath the floorboards grew stronger. The entire cabin groaned as the timber sills shifted slightly on their gravel pads. Outside, from down on the frozen river, came a sound that I will never forget for as long as I live. It wasn't a roar or a cry or an animal sound. It was the sound of 7 feet of thick, solid blue river ice being subjected to structural stress beyond its breaking strain. It was a continuous, resonant boom-crack-boom that echoed off the river bluffs, repeating every 3 seconds, moving slowly, deliberately up the river channel from the direction of the stream gauge installation toward our cabin. The ice wasn't shattering. It sounded like something enormously heavy was moving through the solid ice sheet, displacing thousands of tons of frozen river without breaking the upper crust of snow, advancing upriver against the 8-knot current like a ship moving through open water. Marcus reached out from his bunk, caught the sleeve of my heavy parka, and pulled me down toward him. His grip on my arm was terrifyingly strong, his fingers digging into my muscle. He leaned close to my ear, his voice barely a rasping whisper. He told me not to move. He told me not to look out the window. He told me that whatever was down on the river, it operated on thermal signatures, and if we stayed still and kept our body heat trapped inside our down bags, it would pass us by. We sat frozen in the pitch-dark cabin for 45 minutes. The heavy, resonant booming on the river ice moved slowly up the channel, passing directly in front of the shelter cabin at a distance of no more than 50 yards. As it passed, the air inside the cabin became so cold that my eyelashes began to stick together with frost, and the metal framing of my backpack in the corner emitted a sharp, pinging scream as the aluminum contracted violently under thermal shock. Through the log walls we heard a strange, wet, dragging sound, the sound of an immense weight dragging itself across the dry, powdery snow on the riverbank, accompanied by the distinct snap crack of 3-inch white spruce trees being sheared off clean at the ground level. Then, as suddenly as it had begun, the vibration beneath the floorboards died away. The sound of water rushing through the subterranean silt faded into silence. The heavy booming on the river ice grew fainter and fainter as it moved upriver, heading north toward the high, impassable canyons of the upper Swift River headwaters, until it was completely gone. The silence returned. It was the same crushing, absolute silence of the interior winter, but it felt different now. It felt empty, hollowed out, like the air itself had been scoured clean by something that had no business existing in our world. Neither of us moved or spoke for 3 hours. We stayed locked in our positions, listening to the slow, steady ticking of the cooling wood stove, until the long, blue twilight of the winter dawn began to bleed through the frosted cracks around the cabin door. When full light finally broke over the valley at 9 o'clock Saturday morning, Marcus unlatched the cabin door and pushed it open. The door moved 3 inches, then caught on something hard outside. Marcus braced his shoulder against the timber and shoved with all his weight. The door groaned and popped open through a thick layer of freshly formed ice. We stepped out onto the porch. The weather had changed overnight. The temperature had plummeted to minus 52 degrees Fahrenheit. The air was thick with a dense white ice fog that hung over the river bottom like smoke, restricting visibility to 50 yards. The sky above was a pale, dead gray. We walked down the wooden steps to the riverbank. The snow that had covered the river ice in front of the cabin was completely gone. Over a strip 50 yards wide, and extending as far downriver as we could see through the fog, the 8 inches of loose powder snow had been entirely melted away down to the hard ice surface, leaving behind a smooth, glassy, amber-tinted sheet of pure solid ice that was as slick as a polished mirror. Embedded within that glassy surface, sealed 6 inches beneath the smooth top ice, were hundreds of small, pristine, unfrozen bubbles of liquid water. They weren't moving. They were suspended motionless inside the solid ice sheet, like insects trapped in ancient amber, holding liquid form despite the 52 below air temperature radiating directly above them. We followed the path of melted snow along the bank. 50 feet from the cabin, a stand of young white spruce trees had been wiped out. The trees hadn't been pushed over by wind or knocked down by a snow avalanche. They were snapped off clean at the snow line, their 4-inch trunks sheared smooth as if cut by a hot blade, and the wood at the breakpoints was dark, carbonized and scorched black. Beside the stump of one of those scorched spruce trees sat an object. It was half embedded in the refrozen ice crust on the bank. I stepped closer, knelt in the snow, and brushed away a thin layer of hoarfrost with my mittened hand. It was an old heavy brass river-sounding weight, a fish-shaped lead and brass sinker used by USGS hydrographers in the mid-20th century to pull heavy measurement cables down into high-velocity river currents. It was heavily oxidized, its surface covered in a deep green patina, stamped with an old federal department seal and a mechanical serial number, USGS HYD 1971042. The weight was bone dry. In 52 below cold, any metal object left exposed to the open air is painfully cold to the touch, capable of stripping skin off an unwary finger in seconds. But when I reached out and touched the brass fish with my bare hand, it wasn't cold. It radiated a soft, steady, ambient warmth, hovering precisely around 80 or 90 degrees, like a stone that had been sitting in the summer sun for 5 hours. I picked it up. It weighed roughly 15 pounds. It felt solid, heavy, and strangely comforting in my frozen palm. A tangible piece of human brass in a landscape that had suddenly become completely terrifying. Marcus walked up beside me, looked down at the brass weight in my hand, and turned his head away toward the river fog. He didn't say a word. He didn't look at the serial number. He didn't ask where it came from. He just turned around, walked back to his sled, pulled his heavy rifle out of its canvas case and levered a 300-grain soft-point cartridge into the chamber with a sharp, metallic clack-clack. He sat down on the edge of his sled with the rifle across his knees, staring into the white ice fog downriver, waiting for the plane. Neil Hoff arrived 4 hours early. He had seen the Bering Sea low-pressure system moving over the Kuskokwim Mountains on his morning weather briefing in McGrath, and knew that if he didn't pick us up immediately, the storm would lock us into the upper Swift River Valley for a week. When the ski-equipped Cessna dropped through the ice fog and landed on the smooth, glassy river ice, Neil didn't shut down the engine. He kept the prop turning fast, his face tense behind the windscreen as he watched us haul our gear bags across the slick ice. We threw our equipment into the belly of the plane, strapped the snowshoes and augers down with cargo netting, and climbed into the leather seats. As I pulled my seatbelt tight, Neil looked back over his shoulder at us, his eyes narrow and sharp. He asked what the hell had happened to the snow on the river ice. He asked why the river looked like somebody had run a hot iron across 3 miles of channel. Marcus sat in the front passenger seat, staring straight out through the propeller arc at the gray horizon. He told Neil that a warm spring had opened up under the cut bank and flushed a layer of overflow across the river flats before freezing back over in the cold. It was a standard, plausible, completely mundane explanation that happens in the Alaskan interior all the time during early winter freezes. Neil looked at Marcus for a long moment, then looked back at me in the rear seat. He saw the 15-pound brass-sounding weight sitting on my lap. He didn't ask about the weight. He just nodded once, pulled the throttle back, and flew us out of the valley. As the Cessna lifted off into the gray storm clouds, I looked down through the side window at the Swift River drainage one last time. From 800 feet, the line of melted, refrozen amber ice was visible as a long, dark, jagged scar cutting through the pristine white snow of the river bottom. It extended from the stream gauge site, past our cabin, and wound away up into the steep, trackless mountain valleys of the high country, where no human being lived, where no roads existed, and where no stream gauge would ever record its passage again. We got back to McGrath just as the Bering Sea blizzard hit the interior. The wind roared through the spruce timber at 50 knots, burying the runway in 4-foot snowdrifts, and dropping the visibility to 0 for 3 days. I filed the official field report on Station 15-303-800, 2 weeks later at the USGS main office in Anchorage. In the official record, I logged the anomalous data event from December 14th as a severe mechanical failure caused by a transient thermal short in the submerged transducer array, combined with an ice damming event that exerted abnormal hydrostatic pressure on the intake pipe. I recommended that the station be decommissioned and relocated downriver during the summer field season due to unstable channel geometry and localized geothermal activity. The report was accepted without question. Nobody in the regional office cared about an 8-hour glitch on an isolated stream gauge in the middle of nowhere, as long as the data column had an official technical code assigned to it in the national database. Marcus retired 6 months later. He didn't wait for his 35-year pension milestone. He packed up his gear, sold his house in McGrath, and bought a small secluded homestead 3 miles off the Sterling Highway, near Anchor Point on the Kenai Peninsula. He never returned to the USGS field office. He never attended any of the retirement dinners, and whenever I tried to call him over the years to ask how he was doing, his line went straight to an automated answering service that he never checked. I stayed with the Geological Survey for another 2 years, but I transferred out of the field operations unit. I took a desk job in the data modeling section in Anchorage, spending my days analyzing surface water runoff algorithms and satellite snow cover maps in a warm, carpeted office with fluorescent lighting and coffee pots that didn't freeze. I kept the brass-sounding weight. It sits right now on the bottom shelf of my oak bookcase in my home office in South Anchorage, behind a stack of old hydrological journals and topographic map rolls. It looks like nothing more than an interesting antique paperweight, a heavy fish-shaped piece of tarnished metal stamped USGS HYD 1971-042. I don't show it to visitors. I don't talk about the Swift River. But every winter, when the heavy Arctic cold drops over the Chugach Mountains and the temperature outside my house drops below 0, something happens to that piece of brass. In a warm house held at a comfortable 70 degrees by a natural gas furnace, the brass weight gathers a thick, heavy layer of dense, clear frost that forms only on its underside, adhering to the smooth metal surface like hard river ice. And yesterday morning, while working at my computer, I opened the public USGS real-time water data portal to check the status of the interior stream gauge network during the annual freeze-up. Stream gauge 15-303-800 on the upper Swift River was officially decommissioned and dismantled 9 years ago. Its fiberglass shelter was hauled away. Its steel stilling well was cut off at the bedrock with an oxyacetylene torch, and its satellite uplink frequency was permanently retired by the agency. Yet when I looked at the live telemetry map for the Kuskokwim Basin, an active data icon was glowing bright yellow over the exact geographic coordinates of the old Swift River site. I clicked on the icon. A hydrograph populated my screen. It showed a fresh, clean data line recorded at 3 o'clock yesterday afternoon. The water level sensor was registering a continuous downward load of 42,000 pounds, and the submerged temperature probe was holding liquid water at a constant, steady 86.4 degrees Fahrenheit. The ground-penetrating radar scan we pulled from the gravel pad behind the ruined Fort Morrow hangar did not show the buried aviation fuel line we were searching for. Instead, the digital display rendered a perfectly clear, high-density cross-section of a 40-foot wooden skiff buried 7 feet beneath the frozen gravel, complete with the outline of a man sitting upright in the stern, holding what appeared to be an iron lantern. We were working on the wind-sheared coast of the upper Alaska Peninsula, 4 miles outside the isolated village of Port Hayden, and the ground we were scanning was solid tundra hardpack that had not been disturbed since the United States Army abandoned the airfield in 1947. When I brought the portable readout screen back to the heated mess trailer to show Harlan, he didn't even stop buttering his toast. He took a brief look over his reading glasses, blew a puff of cigarette smoke toward the ceiling fan, and told me that ground radar units always played tricks when you ran them over high salinity soil mixed with volcanic ash from the Aniakchak caldera. He said the iron content in the beach sand created false ghost images, phantom density returns that looked like machinery or human skeletons if you squinted hard enough at the noise. I wanted to believe him because Harlan Ross had spent 31 years managing heavy civil engineering projects from Prudhoe Bay down to Adak, and if anyone knew how Alaskan Earth lied to digital sensors, it was him. My name is Arthur Vance. I was 34 years old in the autumn of 2018, working as a senior environmental field technician for a private contractor hired by the U.S. Army Corps of Engineers under the formerly used Defense Sites program. Our job was routine, unglamorous, and cold, cataloging environmental contamination, soil petroleum plumes, and buried ordnance remnants at the sprawling, decaying site of Fort Morrow. The base had been slapped together in 1942 as a staging airfield during the Aleutian Islands campaign, housing thousands of soldiers in corrugated Quonset huts before being dismantled and left to rot against the gray expanse of Bristol Bay. The team consisted of just 3 of us stationed at the edge of the abandoned runway system. Beside Harlan Ross, who served as our project manager and site safety officer, there was Elena Cruz, a 28-year-old hydrogeologist from Boise, who spent most of her days in the mobile laboratory trailer, analyzing soil cores for volatile organic compounds and heavy metals using a portable gas chromatograph. We lived in 3 interconnected weatherproof shelter trailers parked on the northern apron of the gravel strip, powered by a central 6-cylinder Cummins diesel generator that chugged continuously day and night, its deep mechanical thrum our only anchor against the endless, scouring maritime wind. Port Haydn itself was miles to the south, accessible only by a rutted tundra track that became impassable whenever the sea fog rolled in off the Bering Sea or when high tides flooded the lower tidal flats along Meshik River. The village was home to little more than 100 permanent residents, an air taxi gravel strip, and a small tribal council office. We rarely saw anyone from town. They kept to themselves, living their lives between the tundra and the sea, while we spent our 12-hour shifts trudging through frost-crusted crowberry bushes, driving rusted steel sampling augers into the dirt, and marking contaminated GPS points with orange surveyor flags that whipped in the gale until they stripped down to threads. The morning after the radar glitch, the weather took a turn toward the heavy, damp, cold characteristic of the peninsula in late October. The air smelled of salt, wet tundra moss, decaying kelp, and the faint, bitter tang of diesel exhaust from our generator. A wall of sea fog had banked up over Bristol Bay, hanging 100 feet off the beach like a wet wool blanket, blocking out the low sun and reducing the world to a flat, featureless shadowland of gray grass and rusted iron. Elena was sitting at her lab bench when I walked in with a fresh set of soil gas monitoring logs. She had her headlamp pulled down around her neck and was staring intently at her computer screen, her fingers hovering over the keyboard. She didn't look up when the heavy insulated door latched shut behind me. She just pointed at her monitor and asked me if I had reset the atmospheric calibration on the multi-gas detector before I took my mid-morning round near the old pump house. I told her I had calibrated the sensor at 6 o'clock that morning, using the standard zero gas canister in the tool shed. She turned the screen toward me. The baseline environmental readings from the sensor I had carried across the south taxiway showed standard nitrogen and oxygen ratios until 11:15 a.m. At that exact minute, for a duration of 4 seconds, the instrument had logged a complete absence of atmospheric oxygen. The reading hadn't dipped or dropped gradually as if affected by a methane pocket. It had dropped to absolute 0% volume, while the ambient temperature reading on the same sensor registered an instantaneous drop from 28 degrees Fahrenheit down to -40, before snapping back to ambient parameters on the very next data point. I told her it had to be a loose battery contact or a frozen optical sensor. The sea air was brutal on delicate circuitry, and the condensation inside the housing could easily bridge a contact and scramble the register. Elena didn't argue, but she didn't agree either. She pushed her glasses up her nose, tapped her pencil against the aluminum desk, and noted that the sensor hadn't logged a fault code or a power disruption event. As far as the internal memory was concerned, the instrument had simply passed through a pocket of air that was 4 miles outside Port Heiden, 4 feet off the tundra surface, and frozen to a degree that shouldn't exist anywhere on the planet in October, let alone inside a breathable atmosphere. We tried to maintain our routine. In fieldwork, routine is what keeps you grounded when the isolation starts to press against the back of your neck. You take your samples, you run your blank controls, you record your coordinates, you check the fuel oil levels in the day tanks, and you clean your equipment. But the landscape around Fort Morrow had a way of wearing down your certainty. The base was vast and dispersed, spread over thousands of acres of treeless rolling hummocks. Everywhere you looked, the past was poking out of the moss. Rusted iron fuel drums collapsed like fallen barrels. Concrete foundation pads where officers' quarters had stood. Wooden pilings rotting in the marsh, and long lines of dark gravel runways that stretched into the ocean fog until they simply vanished. That afternoon, I had to drive our Polaris Ranger track vehicle out to the far western perimeter, near an old ammunition bunker embedded in a natural sand dune overlooking the beach. The Corps of Engineers maps indicated that a series of transformer banks had been buried there in the 1950s, and we needed to take core samples to check for PCB leakage into the coastal aquifer. The wind was picking up from the southwest, driving spray off the Bering Sea waves that hammered the black sand beach half a mile away. The noise was constant, a low rhythmic booming that vibrated through the floorboards of the track vehicle. I parked near the entrance of the bunker, a half-collapsed concrete archway overgrown with beach wildry and orange lichen. The interior was dark, filled with wind-blown gravel, rusted wire netting, and the sodden remains of wood framing. I grabbed my hand auger, my soil sample jars, and my photoionization detector, stepping out into the cold wind. The air felt heavy, saturated with moisture that didn't quite fall as rain but coated my oilskin jacket in a glossy sheen of fine droplets. I set to work 20 feet from the bunker mouth, twisting the heavy T-bar handle of the auger into the soil, biting through the top layer of frozen peat into the dark sand beneath. It was heavy, exhausting work. Every foot of depth required pulling the bit out, clearing the dirt into a stainless steel tray, taking a PID gas measurement, and logging the depth in my yellow waterproof notebook. I was on my 4th borehole when I heard the engine. It was the distinctive, high-pitched whine of a small 2-stroke engine, like a snowmobile or a small outboard motor, coming from somewhere in the sea fog toward the beach. I stopped, resting my weight against the auger handle, and listened. Motorized travel on the beach wasn't entirely unusual. Sometimes locals from Mesquite would ride four-wheelers along the high tide line to hunt seals or search for driftwood, but the fog was so dense that visibility was down to less than 50 yards, and the surf was running high enough to swallow the lower beach. The sound didn't approach or recede. It stayed at a fixed pitch, hovering somewhere in the white mist just beyond the crest of the dune. I stepped up the incline of the dune to get a better look, my rubber boots sinking into the loose black volcanic sand. When I reached the crest, looking down at the broad, empty expanse of the beach, there was nothing there. The gray waves were breaking hard against the sand, tossing dark tangles of bull kelp into the foam. The engine sound was louder now, right in front of me, no more than 20 feet away in the open air, but the space was entirely empty. I stood there on the ridge for 2 full minutes, the wind tugging at my hood, listening to the sharp metallic rattle of an engine that had no physical source. Then, as suddenly as it had started, the character of the sound changed. The high-pitched idle slowed down, struggling, coughing twice with a dry, suction-like thump, and choked out. In the immediate silence that followed, the sound of the ocean seemed to drop away entirely, as if someone had turned a dial on the coast itself. For 10 seconds there was no wind, no sound of surf, no cry of gulls. The silence was so dense it created a heavy, painful pressure in my eardrums, the kind of silence you experience deep inside a dry cave system. I stood motionless on the dune, feeling the cold air stiffen the hair on the back of my arms. Then, from the precise spot in the air where the engine sound had cut out, I heard a sound that didn't belong to the coast, to the base, or to any machine. It was the clear, distinct sound of a heavy wooden door swinging open on iron hinges, followed by the dry, firm scrape of a leather boot stepping onto dry hardwood floorboards. The footstep shifted weight, creaked once, and then stopped. I didn't run, but I didn't finish the core hole either. I stepped back down the dune, packed my auger and sample jars into the back of the Polaris, turned the key, and drove back toward the main camp pad at full throttle, keeping my eyes fixed firmly on the red tail lights of the mess trailer glowing through the fog ahead. When I told Harlan about it over dinner, he set his fork down and looked at me across the Formica table. The trailer was warm, smelling of boiled potatoes and fried pork chops, but the atmosphere had grown thin. Elena was sitting in the corner, her laptop open, working through the soil analysis data. Harlan cleared his throat and told me that coastal fog in the Alaska Peninsula was famous for acoustic reflection. He explained that temperature inversions, where a layer of warm ocean air sits over a cold layer of tundra air, could act like a lens for sound, bending audio signals from miles away and dropping them right beside you. He said a skiff running its engine 3 miles up the Meshik River could sound like it was standing right in front of your face if the inversion layer was tight enough. "What about the boot on the wood floor, Harlan?" I asked, leaning forward. "There isn't a hardwood floor within 40 miles of this strip." "You heard an iceberg cracking on the mudflats," he said quietly, his voice hard and flat. "Or a piece of sheet metal blowing around on the old officer housing pads down at South Field. Sound travels sideways in this moisture, Artie. It twists around. You've been out here 3 weeks without a trip to Anchorage. The light gets flat, your ears get tired, and your brain fills in the blanks. That's all it is." Elena didn't say anything to defend Harlan's theory, but she didn't support mine either. Later that evening, after Harlan had turned into his sleeping quarters at the back of the administrative trailer, she called me over to her workstation. She had brought up a historical aerial photograph of Fort Morrow taken by an Army Air Corps reconnaissance plane in August of 1943. She zoomed in on the exact location where I had been drilling, the sand dune near the ammunition bunker. In the high-contrast black and white photograph, the dune wasn't there. Instead, there was a shallow inlet cutting in from the sea, and docked along a crude timber pier was a long, dark vessel. Sitting on the shore beside the pier was a 2-story timber frame building with a wide plank porch. "That was the old Russian-American company trading post," Elena said, her voice barely above a whisper so as not to wake Harlan. "It was built in 1884. The Army bulldozed it in 1942 to clear the approach for the south runway, and the dune drifted over the footprint during the winter storms of '44. It's been gone for 75 years, Artie." She stared at the screen, her finger tracing the crisp square outline of the building where the sand dune now stood. I looked at the image, then out the small double-paned window of the trailer. Outside, the fog was pressing against the glass, lit from above by the pale yellowish glow of our exterior floodlight. The wind slammed into the side of the trailer, making the steel jacks beneath the frame groan against their footings. That night, I couldn't sleep. My bunk was situated at the end of the residential trailer, right against the exterior wall. Every half hour, the Cummins generator would change its engine note slightly as the automatic load governor adjusted for the heating cycles in the lab trailer. The deep, rhythmic thump-thump-thump of the diesel motor was supposed to be comforting, a sign that we had light, heat, and power in the middle of a wilderness that stretched for hundreds of miles in every direction. At 2:20 in the morning, the generator sound changed. It didn't drop RPM or surge. Instead, a second lighter engine note joined it, a hollow metallic rattling that matched the exact frequency of the sound I had heard out on the dune. It wasn't coming from outside. It was coming from the floorboards directly beneath my aluminum bunk frame. I sat up in the dark, my heart thumping against my ribs. The trailer was freezing. The propane heater in the hallway had cycled off, and my breath bloomed in faint white clouds in the dim light filtering under the door. I swung my legs out from under the heavy wool blankets and placed my bare feet on the linoleum floor. The floor was cold, colder than it should have been, and the vibration passing through my soles wasn't the steady, low-frequency hum of the Cummins unit 50 feet away. It was a fast, erratic flutter, like something small and hard tapping rapidly against the underside of the trailer frame. I reached for my headlamp, clicked it onto its lowest setting, and pulled on my thermal pants and leather boots. I walked down the narrow central corridor of the trailer, past Harlan's closed door, and stepped into the small vestibule that led to the heavy exterior door. I grabbed my down parka, pulled it over my shoulders, and unlatched the deadbolt. The cold air hit me like a wet towel across the face. The fog had thinned slightly, pulled into long, ragged streamers by a bitter northwest wind blowing off the mountains inland. The night was vast and black, the sky above choked with heavy clouds that obscured the moon and stars. The floodlight on the mess trailer threw a harsh cone of white light across the frost-covered gravel of the apron. I walked around the perimeter of our residential unit, my headlamp beam cutting through the drifting vapor. The Cummins generator was sitting on its skid 30 yards away, its exhaust stack spitting a pale blue haze into the freezing air. Everything looked normal. The fuel lines were intact. The electrical umbilical cables were suspended off the frozen ground on timber horses, and the snowless gravel was bare and gray. Then I looked under the trailer. The space beneath the raised floorboards was supported by 6 heavy-duty steel screw jacks resting on thick wooden pads. In the center of the footprint where the ground should have been untouched tundra gravel, there was a deep, sharp depression in the dirt. It looked like a long, narrow trench, roughly 6 feet deep and 8 feet long, filled with dark liquid water that did not reflect the beam of my headlamp. As I watched, a series of small rhythmic ripples spread out across the surface of the black water, as if something heavy were moving slowly through the liquid beneath. The air rising from the trench didn't smell like tundra peat or diesel. It smelled of ancient, stagnant river mud, wet dog fur, and raw sulfur. I backed away slowly, my boots crunching on the frost. I didn't yell for Harlan. I didn't go back into the trailer to grab a flashlight or a camera. I went into the tool shed, retrieved 2 heavy 6-inch steel deck plates we used for securing equipment skids, carried them back to the trailer and laid them over the gap between the gravel and the frame. When morning came, the trench was gone. The ground beneath the trailer was flat, hard-packed gravel, frozen so solid that when I struck it with the point of a crowbar, the steel rebounded with a dull, ringing tone, leaving only a faint white scratch on the stone. I didn't say anything to Harlan or Elena about what I had seen under the floorboards. In remote field operations, there is a fine line between reporting an operational hazard and convincing your crew that you're losing your sanity. If you get tagged as unstable, the project manager calls the charter operator in King Salmon. An air taxi shows up on the strip and you're sitting in an office in Anchorage by nightfall while your career as a field technician evaporates. I needed the work, and more than that, I needed to know if I was actually seeing what I thought I was seeing. We spent the next 3 days working on the eastern boundary of the site, near an old radar tower structure that had been stripped of its dish decades ago. The tower was a massive, skeleton-like frame of riveted steel that towered 80 feet above the tundra, creaking and groaning whenever the wind shifted. The work there was tedious. We were using a hand-portable soil gas probe to check for volatile organic compounds around the transformer footings. The temperature was dropping steadily every afternoon, hovering around 20 degrees, and the ground was freezing deeper each night, making probe insertion increasingly difficult. On Thursday afternoon, Elena was working 40 yards from me, taking soil conductivity readings with a digital meter, while Harlan was back at the utility vehicle updating the daily safety log on his tablet. The wind had dropped to a light breeze and the air was crisp and painfully clear. One of those rare, blindingly bright autumn days on the peninsula where you can see the white peak of Mount Aniakchak jagged against the southern horizon 60 miles away. I was leaning my weight onto the driver rod of the gas probe when Elena called my name. Her voice wasn't loud, but it had a high, strained tightness that made me drop the handle immediately and look up. She was standing next to one of the concrete tower footings, her conductivity meter held in her left hand, her right hand pointing down at the base of the structure. She wasn't looking at me. Her eyes were locked on the ground at her feet. I walked over to her, my iron-toed boots thumping heavily on the frozen moss. When I reached her side, I looked down. In the hard, frost-crusted soil surrounding the concrete footing, there were footprints. They weren't bear tracks, and they weren't the tread marks of our Dunlop winter boots. They were the crisp, deep impressions of bare human feet. A pair of large, wide feet with long, distinct toes, pressed half an inch deep into soil that was frozen as hard as concrete. The tracks didn't lead anywhere. They didn't come from the tundra, and they didn't continue toward the tower. There were simply 4 distinct footprints, 2 left, 2 right, positioned as if a tall person had been standing right next to the concrete pad, facing northwest toward the Bering Sea. "I was standing right here 2 minutes ago, Artie," Elena said, her voice dry and brittle. "I stepped away to get a new battery out of the case. When I walked back, these were here." I knelt down, pulled off my heavy leather work glove, and hesitated before touching the ground. I slowly lowered my hand and pressed my bare thumb into the center of one of the heel prints. The earth inside the track wasn't cold. It was warm like the skin of a horse or a person sitting in the sun. The soil yielded slightly under my thumb, yielding to pressure like soft, damp clay before slowly springing back into shape when I pulled my hand away. "It's a wolf track that melted and expanded, Cruz," Harlan repeated, staring directly at her. "We're 4 miles from town. There is nobody out here barefoot in 20-degree weather. We have 40 holes left to probe on this grid, and we lose daylight at 5 o'clock. Get your gear back together." He turned on his heel and walked back toward the track vehicle, his head hunched down between his shoulders, his pace noticeably faster than usual. Elena looked at me, then back down at the tracks. Without saying another word, she reached into her field kit, grabbed a tub of quick-setting plaster she used for sealing monitoring wellheads, and began mixing it with water from her canteen in an aluminum bowl. She poured the white slurry into the left heel print, her hands trembling slightly as she smoothed the surface with a spatula. We finished the grid in absolute silence. The sun dipped low toward the western ocean, turning the sky a vivid, bruised purple and cold amber. By 4:30, the shadow of the radar tower stretched 200 yards across the tundra, thin and dark, like a long finger pointing toward our camp. That night, the maritime storm that had been building off the Aleutian chain finally hit the peninsula. It wasn't a snowstorm. It was a cold, driving gale carrying sleet, freezing rain, and 50-knot wind gusts straight off the open water. The shelter trailers shook continuously, the steel tie-down straps screaming under the tension as the wind battered the aluminum siding. The temperature dropped to 16 degrees, and the rain froze as soon as it hit any surface, coating the equipment, the Polaris, and the gravel pad in a thick, clear shell of glare ice. By 9 o'clock, the main satellite communications dish mounted on the lab trailer roof was torn from its bracket by a gust and sent clattering across the gravel strip into the dark. We lost our internet connection and our landline equivalent phone link to the office in Anchorage. Our only connection to the outside world was the high-frequency VHF marine radio mounted on the wall of the mess trailer. Harlan sat at the radio table, clicking through the channels, trying to pick up the continuous marine weather broadcast from Kodiak or the Coast Guard cutter stationed in Bristol Bay. All he got was thick, static-laden ocean noise, interrupted by erratic bursts of atmospheric popping that sounded like wet leather snapping in the cold. "We're stuck here until Saturday," he said, setting the microphone back on its cradle. "Air taxi out of King Salmon won't fly in 60-knot wind with freezing rain. The runway here is an ice rink anyway. Nothing lands on this strip until the temperature flips or the salt air melts that shell." "How are the generator fuel levels?" I asked, sitting across from him, sipping a mug of stale black coffee. "We have 200 gallons in the day tank," Harlan replied. "That gives us 4 days at full load. We're fine. We stay inside, keep the heaters burning, and wait for the front to push east toward Cook Inlet." Elena was in her corner room. She hadn't come out for dinner. I walked down the short corridor and knocked on her hollow wooden door. "Elena?" "Come in, Artie." Her voice was low, flat, and exhausted. I opened the door. She was sitting at her small desk, illuminated only by the harsh white light of a desk lamp. On the blotter in front of her was the plaster cast she had taken at the radar tower. The white cast was clean and fully cured. Now that it was turned upside down, showing the three-dimensional form of the footprint, the details were terrifyingly clear. It wasn't a bare human foot. The shape had 5 distinct digits, but the proportions were entirely wrong. The heel was narrow and elongated, terminating in a sharp, wedge-like bone structure. The arch was absent, replaced by a thick, flat pad that showed deep, parallel ridgelines in the skin, similar to the whorls on a human thumb but vast and coarse, like ridges cut into thick rubber. The middle digit was nearly 6 inches long, with a distinct, curved depression at the tip that looked like the imprint of a heavy, blunt nail. "I measured the depth of the displacement," Elena said softly, without looking up from the cast. "To make an impression that deep in frozen tundra soil, whatever stepped there had to weigh between 1,400 and 1,800 pounds. On one foot." "Elena," I said, leaning against the doorframe, "Harlan thinks we're just tired. He wants to keep the project on schedule." She finally turned her head to look at me. Her face was pale, and there were dark gray circles under her eyes. "Harlan knows, Artie. He went out to the utility shed an hour ago while you were checking the heater lines. I saw him through the lab window. He was carrying his old Remington 30-06 rifle. He loaded 5 rounds into the magazine and stood by the door for 20 minutes, just looking out at the runway in the dark." The revelation hung in the cold air of the room, heavy and cold. Harlan Ross was an old-school Alaskan. If he had pulled a hunting rifle out of his gun case, he wasn't worried about temperature inversions or melting wolf tracks. At midnight, the generator stopped. It didn't sputter or run out of fuel. The light simply vanished. The rhythmic thump-thump-thump of the engine died instantly, and the sudden, total silence was broken only by the screaming of the wind against the trailer walls. Within 30 seconds, the interior temperature began to drop. The darkness in the trailer was total, a thick, suffocating blackness that felt heavy against the skin. I grabbed my headlamp from the nightstand, clicked it on, and stepped out into the hallway. Harlan was already there, wearing his heavy parka, holding a heavy Maglite flashlight in one hand and his rifle in the other. Elena came out of her room a second later, bundled in her winter gear, her headlamp beam cutting through the freezing mist of our combined breath. "Fuel line must have frozen," Harlan said, his voice hard, but I could see the light beam vibrating slightly in his hand. "Or the automatic cutoff tripped on the oil pressure sensor. I have to go out and manually prime the pump." "I'm coming with you," I said, reaching for my coat and boots. "No," Harlan snapped, turning to face me. "You stay here with Cruz. Keep the door locked from the inside. If I'm not back in 10 minutes, you switch the emergency battery bank on to keep the radio alive." He didn't wait for an answer. He unlatched the heavy vestibule door, stepped out into the roaring, icy night, and pulled the door shut behind him. The lock clicked into place with a sharp metallic snap. Elena and I stood in the narrow corridor of the trailer, the beams of our headlamps crossing in the freezing air. Outside, the wind was howling, a high shriek-like whistle as it cut through the aluminum seams of the building. We listened to the slow, heavy crunch of Harlan's boots on the iced gravel as he walked 30 yards toward the generator shed. Then his footsteps stopped. For 2 long minutes there was no sound except the wind. No sound of the metal generator shed door opening. No sound of a wrench or a hand primer pump. Then, over the high-frequency VHF radio speaker mounted on the wall in the mess room, a voice came through the static. It was Harlan's voice, perfectly clear, without a trace of wind noise or radio interference. "Artie," the radio said, the tone calm, conversational, and completely flat. "Artie, come outside for a second. I found something under the north runway pad. Bring the heavy auger." Elena grabbed my sleeve, her fingers digging deep into the fabric of my parka. "Don't answer it," she whispered, her teeth chattering from the cold. "Artie, don't go near that radio." I walked slowly into the mess room, my headlamp beam shaking across the Formica table. The VHF unit's red power LED was dark. The main breaker panel was tripped off and the emergency battery bank hadn't been activated yet. The radio was completely unpowered. Yet the speaker continued to vibrate, the voice coming through with terrifying, uncompressed clarity. "It's about 6 feet down, Artie," the voice said from the dead radio. "It looks like an old iron lantern. It's still burning. Come out to the north pad." I reached out with a trembling hand, grabbed the rubber microphone cable, and pulled it hard. The wire snapped out of the back of the plastic housing with a sharp pop. The voice didn't stop. It kept repeating the exact same sentence over and over at 6-second intervals, the intonation identical down to the smallest inflection. "It's about 6 feet down, Artie. It looks like an old iron lantern. It's still burning. Come out to the north pad." "Where is Harlan?" Elena cried out, her voice breaking into a sob. "Artie, where is he?" I ran to the narrow double-paned window facing the generator shed and wiped the thick frost off the inner pane with my bare hand. Out in the ice-covered apron 40 yards away under the pale sky, the generator shed door was swinging wide open in the wind, slamming repeatedly against the corrugated iron frame with a hollow clack, clack, clack. Sitting in the ice in front of the open door was Harlan's .30-06 rifle. It was laid neatly across 2 wooden timber blocks as if placed there deliberately for display. Harlan was gone. There were no tracks in the fresh sleet around the rifle. There were no drag marks. The ice sheet covering the gravel was an unbroken, mirror-smooth expanse of clear gray, reflecting the dark sky above. "We have to get to the Polaris," I said, my voice barely audible above the roaring wind. "We have to get south toward the village." "The track vehicle is frozen solid, Artie," Elena yelled, pulling her hood tight around her face. "The tracks were iced over when we came in at 4. We'll never get it started without the engine heater." "Then we walk," I said. "We take the emergency packs, the satellite beacon, and we walk the road toward Mashik." "It's 4 miles through 16-degree wind," she cried. "We'll freeze before we reach the river bridge." "If we stay in this metal box without heat, we freeze anyway," I snapped, grabbing her by the shoulders and forcing her to look at me. "And whatever is out there is already using the radio. We're leaving now." We grabbed our survival backpacks, heavy nylon rucksacks loaded with emergency rations, bivouac sacks, space blankets, flare guns, and handheld GPS units. I pulled a heavy iron wrecking bar from the tool locker to use as a walking stick and a weapon, though I knew deep in my gut that 6 feet of forged carbon steel would be useless against whatever was shifting the earth beneath our feet. I kicked open the exterior door. The wind hit us like a solid wall of freezing needlepoints, driving sleet deep into our parka hoods and instant freezing the moisture around our eyes. We stepped out onto the ice sheet. Walking was almost impossible. The rain had coated the gravel in 2 inches of clear, glass-like ice that offered zero traction. Every step was a deliberate, sliding effort, our boots slipping and scraping as we leaned hard into the 50-knot gale. We skirted the generator shed, avoiding the wide-open door and the abandoned rifle sitting on its timber blocks. As we passed the open shed, I glanced inside for a fraction of a second. The 6-cylinder Cummins engine wasn't broken or frozen. The heavy iron engine block had been split entirely in half down the center line, as if a massive, invisible wedge had been driven through 4 inches of solid cast iron from top to bottom. The dark oil had spilled out onto the concrete floor and was frozen into a thick black gel. We turned south, setting our faces into the driving sleet, following the line of rusted steel barrels that marked the edge of the tundra road toward Port Hayden. The night was a screaming void of black and gray. Our headlamp beams were useless, picking up only the blinding, dense vortex of flying ice particles 2 feet in front of our faces. We moved by touch and by the dim outline of the barrel line, keeping our left hands on the rusted steel drums as we stumbled over frost-heaved hummocks and slick patches of frozen mud. After 20 minutes of exhausting, agonizing progress, my thigh muscles were burning from the effort of stabilizing myself on the ice. The cold was beginning to seep through my heavy felt-lined boots, deadening the nerves in my toes until my feet felt like wooden blocks at the end of my legs. Elena was struggling behind me, holding onto the strap of my rucksack. I stopped near an old wooden signpost that had lost its wooden face decades ago, leaving only 2 square timber uprights rotting in the tundra. I pulled my handheld Garmin GPS unit out from inside my parka, shielding the screen with my glove. The liquid crystal display was sluggish from the extreme cold, the pixels smearing across the screen as it searched for a satellite lock. When the position finally locked, the red dot on the top-down map didn't show us 2 miles south of camp on the road to Port Hayden. It showed us sitting in the exact geometric center of the north runway at Fort Morrow, the exact spot where the radar scan had recorded the buried wooden vessel 4 days earlier. "That's impossible," I muttered into my face mask, my breath freezing into a thick crust of white ice on the neoprene. "We've been walking south for half an hour. The road runs straight." I looked down at the ground. Beneath the clear layer of surface ice, embedded 3 inches deep in the dark, frozen gravel, was something long, pale, and smooth. I dropped to my knees, scraping the frost away with my gloved hand, shivering violently as the wind tore at my back. It was a piece of timber, a heavy, hand-hewn oak rib from the hull of a wooden ship, complete with square iron nails protruding from the wood. It wasn't rotten. The wood was fresh, pale yellow pine, smelling strongly of fresh resin and salty seawater, as if it had been cut from a forest hours ago. Beside the wood, frozen into the same ice layer, was a man's heavy leather boot. It was attached to a long gray wool trouser leg that stretched down into the dark earth beneath the gravel pad. I pulled back, scrambling onto my feet, my heart pounding violently against my ribs. Elena was standing 10 feet away, her headlamp shining down into the fog. She wasn't looking at the ground. She was looking up into the dark sky above us. "Artie," she called out. Her voice wasn't afraid anymore. It was dull, empty, and strangely peaceful. "Artie, look at the lights." I looked up, high above the abandoned airfield, through the driving sleet and the raging cloud deck. 3 vast, silent shapes were hanging in the air. They weren't airplanes and they weren't helicopters. They were massive, irregular masses of dark, wet tundra earth. Enormous floating islands of soil, rock, and rusted metal, each one 200 feet across, torn directly from the ground and suspended motionless in the screaming gale. Hanging from the underside of the largest suspended mass was the decayed wooden frame of the Russian-American trading post, its heavy plank porch dangling upside down in the cold air, its square windows glowing with a dim, flickering yellow light like an iron lantern burning behind thin glass. As I watched, paralyzed by a cold that had nothing to do with the temperature, one of the massive dirt masses shifted silently in the sky, descending 10 feet through the fog without making a single sound, without disturbing the wind around it. A sharp metallic voice rang out across the open tundra, not from the sky, not from a radio, but from inside the hollow cavity of my own teeth. A flat, uncompressed recording of Elena's voice from 3 days ago. "I was standing right here 2 minutes ago, Artie." Elena dropped her backpack onto the ice. She didn't look at me. She didn't scream. She simply stepped forward, off the edge of the gravel runway, and walked out into the open, featureless black tundra toward the descending shadow. "Elena!" I screamed, lunging forward, my boots slipping instantly on the glare ice. I fell hard, my shoulders slamming into the frozen ground, the iron wrecking bar clattering across the ice into the dark. I scrambled to my feet, my knee throbbing with pain, and ran after her through the deep, crusted moss. But the fog had closed in around us, thick, gray, and cold, dropping visibility back down to 5 feet. I ran until my lungs felt like they were filling with broken glass. I yelled her name until my voice cracked into a hoarse whisper. There was no answer. Only the endless, rhythmic booming of the Bering Sea surf crashing against the black sand beach 2 miles away, and the cold, thin whistle of the Arctic wind passing through the rusted steel frame of the radar tower. I don't remember the rest of that night. They found me at 10 o'clock the following morning, 3 miles south of the airfield on the banks of the Mishik River. A hunting party from Port Hayden on 6-wheel ATVs spotted me sitting on a drift log near the frozen mudflats, my hands frozen to my knees, my headlamp still running on its last dying spark of battery power. My toes were frostbitten, and I had severe second-degree cold injuries across my cheeks and chin, but I was alive. The search and rescue operation lasted for 6 days. The Alaska State Troopers brought in 2 helicopters from Kodiak and a ground team with search dogs from King Salmon. They searched every square yard of the Fort Morrow site, the ammunition bunkers, the coastal dunes, and the beach flat for 10 miles in either direction. They found the shelter trailers. The mess trailer had suffered severe structural damage. The interior wall facing the runway had been pulled outward as if subjected to a sudden, violent vacuum, scattering equipment and personal belongings across the gravel strip. They found Harlan's rifle lying on its timber blocks near the generator shed. The barrel was filled with frozen sea mud. They never found Harlan Ross. They never found Elena Cruz. The official trooper report, released 6 months later, concluded that the crew had experienced a catastrophic environmental emergency during an extreme winter gale. The report hypothesized that a failure of the heating system had led to severe hypothermia, causing paradoxical undressing and irrational decision-making, leading the crew members to wander off into the tundra where they succumbed to exposure and were likely washed out to sea by the storm surge along the river mouth. The Army Corps of Engineers canceled the remediation contract at Fort Morrow 3 weeks after the incident. The site was classified as indefinitely suspended due to hazardous geotechnical instability and unexploded ordnance risks. The gravel strip was decommissioned, and the FAA removed the landing markers from the regional aeronautical charts. I spent 2 months in the hospital in Anchorage undergoing skin grafts and physical therapy. When I was released, I resigned from my position at the environmental firm. I moved down to a small, quiet town in western Washington state, took a low-paying job processing water quality reports for a municipal utility, and bought a modest wood frame house 10 miles from the ocean. I don't go near the coast. I don't listen to marine radio broadcasts, and I keep 3 independent propane heaters in my house, checked and serviced every autumn before the first night frost. I tried to put it behind me. I tried to tell myself that Harlan was right, that the isolation, the flat light, the sea salt, and the sudden drop in temperature had created a toxic delirium that scrambled our senses and drove us into the cold. Then, 3 weeks ago, a package arrived at my home in Washington. It was a small, heavy cardboard box with no return address, postmarked from the Regional Processing Center in Anchorage. Inside was a hard plastic case containing an archival backup thumb drive from my old company's server, along with a brief, formal cover letter from a junior technician in the Anchorage office. The letter stated that during a routine digital migration of legacy field data from suspended FUDS projects, they had found several unindexed data files from the 2018 Fort Morrow site assessment that belonged to my unit. I sat at my desk in the quiet bedroom, the rain tapping gently against the window pane, and inserted the drive into my computer. There were dozens of standard spreadsheet files, soil pH readings, hydrocarbon concentrations, GPS coordinates, photo logs. At the bottom of the directory was a single raw data file from the ground-penetrating radar unit I had used behind the hangar on my second day at the base. The file that Harlan had dismissed as a sensor glitch caused by volcanic ash and salt sea sand. I opened the file using a standard subsurface rendering software viewer. The high-density cross-section loaded slowly, line by line, rendering the grayscale density layer of the frozen gravel pad beneath Fort Morrow. The wooden ship was still there in the center of the frame, buried 7 feet down in the hardpack. The upright outline of the man sitting in the stern was crisp and clear. I zoomed in on the figure's right hand, the hand holding the iron lantern. The image wasn't a shadow or a density anomaly caused by iron sand. The digital radar return had picked up the fine, high-density metal frame of a modern, heavy-duty wristwatch worn on the figure's wrist. I adjusted the contrast settings, filtering out the background noise of the soil matrix, and enlarged the watch face until the pixels began to break down. The watch was a stainless steel field watch with a reinforced nylon strap. The exact model I had bought at the BX in Anchorage 3 days before we flew out to Port Hayden. Engraved on the tiny, high-density steel backing plate visible beneath the wrist bone were 4 clean, clear capital letters: A-V-A-N. I found 3 months of continuous audio frequency pressure logs from deep well transducer YK04 that recorded a heavy, rhythmic dragging sound 500 feet underground, registered 4 weeks after the well casing had been filled with 6 tons of dense industrial slurry and capped with a half-inch welded steel plate. The file was sitting on an unformatted flash drive inside a waterlogged Pelican case that had been retrieved from a salvage dump near the Yakutat harbor. At first glance, I assumed the data was corrupt. Low-frequency signals on subsurface pressure sensors are notorious for picking up mechanical noise from marine diesel engines, tidal surge harmonics, or even microseisms caused by calving ice miles inland. But when I isolated the channel and ran it through a basic bandpass filter to strip out the ambient rumble of the Gulf of Alaska, the cadence was too uniform. It wasn't the irregular, sharp cracking of a thermal fracture in the bedrock, nor was it the smooth, oscillating hiss of pressurized groundwater forcing its way through a gravel aquifer. It sounded like something solid, thick, and immense being pulled inch by inch through compacted marine silt, pausing for precisely 7 seconds, and then dragging again. My name is Ethan Vance. In the autumn of 2018, I was 38 years old and working as a regional field maintenance engineer for Northern Seismic Systems, a private contractor tasked with servicing remote geodetic and seismic monitoring stations for the Geophysical Institute in Fairbanks. My sector covered a brutal, largely roadless corridor of the coastal plain bounded by the Robinson Mountains to the north and the Gulf of Alaska to the south. It was a strip of temperate rainforest, black sand beaches, shifting glacial outwash, and endless alderbrush, where the weather was manufactured in the North Pacific and dumped against 4,000-foot ice walls without warning. The station designated YK04 sat a narrow gravel terrace just north of Cape Yakataga. Cape Yakataga isn't a town in any modern sense. It's an isolated coastal shelf about 120 miles west of Yakutat, accessible only by beach-landing aircraft or high-end coastal vessels if the surf doesn't break your hull against the offshore reefs. Back in the late 1950s and early 1960s, oil companies poured millions into the region, drilling exploratory wells through the thick coastal sediment into the underlying tertiary rock. They found nothing commercially viable, abandoned the sites, and left behind rusted machinery, rotting timber skid shacks, and a scatter of capped boreholes slowly being reclaimed by Devil's Club and Sitka spruce. The Geophysical Institute had appropriated several of these old exploratory holes in the early 2000s, dropped subsurface instrument packages down the steel casings, and wired them to solar-powered digitizers to monitor micro-earthquakes along the Yakataga fold and thrust belt. Station YK04 was one of the older installations. It was scheduled for decommissioning in September 2018 because the casing had finally succumbed to salt air corrosion and groundwater intrusion, prompting the state to contract an environmental crew out of Valdez to seal the top 500 feet with concrete to prevent subterranean aquifer contamination. The sealing had been completed on August 12th. I knew this because I had filled out the access permits myself and verified the work order. The concrete crew had pumped the grout, allowed it to set, welded the top plate flush with the soil line, and evacuated their heavy equipment on a barge before the autumnal gales hit. The seismic package was supposed to be dead, disconnected, and buried. Yet the flash drive I held contained clear data from the transducer logged between September 10th and September 14th. I called Marcus Lehane that afternoon. Marcus was 52, born and raised in Cordova, and operated a small charter air service out of the Yakutat airport using a worn 1974 Cessna 206 outfitted with oversized Tundra tires. He knew the coastal beaches better than anyone alive, capable of reading the sand density from 50 feet in the air just by watching how the tide foam set on the beach bars. He met me at the hangar, wiping hydraulic fluid off his knuckles with a shop rag, while the Cessna's engine ticked softly in the cold air. I laid the printout of the seismic waveform on the hood of his tool chest. He looked at it for a long moment, squinting through heavy bifocals, then looked up at me with the flat, unhurried expression of a man who spent his life waiting out bad weather. He asked if I thought a bear had dug up the cable. I explained that the cable had been severed 3 feet below the surface when the cap was welded. The transducer buried inside the concrete shouldn't have had power, let alone a data link to the solar array. The flash drive had been plugged directly into the backup logger box, which sat in an aluminum shelter 50 yards back in the spruce line. Someone or something had physically plugged the drive into the logger, recorded 4 days of subsurface telemetry, and then left the drive on the floor of the hut where the salvage crew later picked it up. Marcus didn't offer a theory. He simply asked when I wanted to go down there. The weather window was narrow. A low-pressure system was spinning out of the Aleutians, bringing 60-knot winds and heavy rain by the weekend. If we were going to clear the equipment and figure out why the station log was showing activity, we had to go immediately. We took off early the following morning. The flight west along the coast was low and dark. Below us, the Gulf was a violent gray churn, throwing 20-foot rollers against the pitch-black beaches of the Cool Teeth River Delta. To our right, the massive snout of the Guyot Glacier poked through a dense blanket of coastal fog, its blue ice crevasses looking like open wounds in the rock. The landscape here felt unfinished, constantly being crushed, ground down, and rebuilt by ice and ocean. Marcus lined the Cessna up on the hard-packed gravel strip near the mouth of Pole Creek. The strip was old, built by the FAA during World War II, and now largely overgrown with beach rye and wild sweet pea. The tires touched down with a soft, heavy rumble, kicking up spray from shallow meltwater pools. As soon as the engine sputtered into silence, the absolute isolation of the place settled over us like weight. The only sound was the deep, rhythmic boom of the ocean half a mile to the south, and the wind whistling through the guy wires of the abandoned FAA radio tower on the bluff. We pulled our gear from the hold, my diagnostic tools, a pair of handheld VHF radios, a Garmin GPS receiver, heavy rain jackets, and a 12-gauge Remington shotgun loaded with lead slugs that Marcus carried as a matter of habit whenever we entered thick brush. The path from the airstrip to the YK-04 site led through a corridor of old-growth Sitka spruce. The forest floor was a thick carpet of green moss that muffled our boots completely. Rusted steel cables, moss-covered fuel drums, and the disintegrating frames of wooden truck chassis from the 1950s lay scattered among the trees, swallowed so thoroughly by vegetation that they looked like geological formations rather than human debris. When we reached the site, the first thing I noticed was the quiet. The coastal forest usually carries a background noise of ravens, red squirrels, and wind in the upper canopy. But here the air was still and heavy with the smell of damp earth, rotting seaweed, and a faint, sharp metallic tang that smelled like wet iron. The seismic instrument shelter, a small corrugated aluminum box mounted on a pressure-treated wooden platform, was standing open. The door had not been forced. The latch was simply flipped up. Inside, the RefTech digitizer was missing its internal lithium battery, but the auxiliary solar regulator was still clicking rhythmically as its panel on the roof caught the dim gray light filtering through the cloud layer. 50 yards away, sitting in a small clearing cleared by the concrete crew weeks prior, was the capped wellhead of YK-04. It was a steel cylinder, 12 inches in diameter, protruding about 2 feet above the mud. The top plate was heavy structural steel, scarred by the gray-blue bead of a fresh arc weld along its circumference. There was no damage to the steel, no scratches, no rust stains around the seam, no indication that a jackhammer or torch had been brought anywhere near it. The ground surrounding the casing was firm, packed gray clay mixed with river gravel, undisturbed since the heavy machinery had backed out. I walked over and laid my hand on the cold steel plate. The ground was solid beneath my boots, but through the heavy metal of the cap, I felt a faint, faint tremor. It wasn't a continuous vibration. It was a rhythmic pulse, occurring every few seconds, so subtle that if I hadn't been pressing my palm flat against the steel, I would have dismissed it as the ocean surf hitting the beach. I pulled out my portable signal generator and a handheld oscilloscope, connecting the probe leads to the ground test terminals near the base of the casing. The trace on the small liquid crystal display was flat for 3 seconds, then spiked into a high-amplitude, low-frequency sine wave that saturated the screen before clipping off. Marcus stood a few feet back, his hands resting on the barrel of his shotgun, his eyes scanning the dense line of Devil's Club that bordered the clearing. He asked if I was getting anything. I told him the transducer was transmitting. He spat into the mud and stepped closer, watching the line on the screen jump and clip. He noted that the pipe was supposed to be full of concrete. It was. The cement ticket from the contractor in Valdez had listed 300 sacks of Portland cement, mixed and pumped under high pressure down the length of the casing. The pipe should have been a solid, inert block of artificial stone extending 500 feet into the slate bedrock. I knelt down and cleared away the wet leaves and gravel around the base of the pipe where the old signal cable had been cut. The thick black rubber jacket of the cable had been sheared clean by the concrete workers' wire cutters, the copper wires inside oxidized to a dull green. It was completely dead. The signal I was receiving on the oscilloscope wasn't coming through the wire. It was being picked up directly through the steel casing itself, as if the entire 12-inch pipe were acting as an antenna for a mechanical vibration, originating far below the concrete plug. Marcus looked up at the sky. The gray ceiling had lowered significantly over the last hour, the clouds thickening into a dark, bruised purple that hung low over the ocean. The wind was picking up from the southwest, bringing a fine, driving salt spray through the treetops. He suggested we check the secondary monitoring hut on the ridge before the weather shut down our visibility. The secondary hut sat 300 feet higher, on an exposed marine terrace that overlooked the entire Yakataga foreland. It had been built by the Federal Aviation Administration in the late 1940s to house a weather observer and a low-frequency radio beacon for aircraft flying the Gulf Coast between Juneau and Anchorage. It was a low, square structure made of heavy creosote-treated timber, anchored to the bedrock by thick steel guy wires. The radio equipment was long gone, but the Geophysical Institute used the site as a reference benchmark for GPS crustal deformation studies. We hiked up the switchback trail, our boots slipping on wet slate and rotting spruce needles. The forest opened up near the crest, revealing the full scale of the isolation. Below us, the black sand beach stretched for miles in both directions, completely devoid of human presence, disappearing into the white mist where the ocean surf met the rain. Inland, the high peaks of the Robinson Mountains were entirely hidden behind a wall of dark weather. The FAA hut was weathered to a silver gray, its windows boarded up with heavy plywood sheets. A rusty iron stovepipe stuck out of the turf-covered roof, bent sideways by decades of coastal storms. When we stepped inside, the air was cold, dry, and smelled strongly of old cedar, wool, and coal dust. A heavy wooden bench ran along one wall, and an old cast-iron cook stove sat in the corner, its surface covered in a layer of fine brown rust. I set up my gear on the bench and pulled out the benchmark log for the station. The site was equipped with a high-precision Trimble GPS receiver that recorded ground movement down to the millimeter, transmitting its position via a satellite link once a day. I flipped open my laptop, connected it to the local storage module, and initiated a manual data dump. The screen flickered, showing a list of daily position files spanning the last 6 months. I scrolled down to the entries for the past week. Under normal conditions, the crustal movement along the Cape Yakataga coastline is predictable. The Pacific Plate is pushing north into the North American Plate at about 2 inches per year, causing the coastal terraces to rise and tilt gradually over decades. The log entries for the last 3 days didn't show 2 inches per year. On September 11th, the benchmark recorded a horizontal displacement of 11 inches to the southwest. On September 12th, it moved another 14 inches in the same direction. On September 13th, the movement recorded was over 3 feet. Yet there was no record of a major seismic event on any regional network. If the ground had moved 3 feet in 72 hours, every seismograph from Anchorage to Juneau should have been ringing off the hook. The fault should have ruptured, creating massive surface shearing, displaced stream channels, and visible landslides along the ridge. I stepped outside with the handheld GPS receiver to check the physical benchmark. A 3-inch brass disc stamped by the U.S. Coast and Geodetic Survey in 1958, cemented directly into an outcrop of solid granite 20 feet behind the hut. The brass disc was there, untouched, its inscription crisp and clean. The granite outcrop showed no fractures, no spalling, no stress cracks in the moss growing around its edges. The surrounding trees were vertical and healthy. The ground hadn't torn open. The rock itself hadn't broken. It was as if the physical space occupied by the entire terrace, the rock, the forest, the cabin, and the mountain ridge behind it, had been displaced uniformly without experiencing acceleration or stress. Marcus was standing by the edge of the terrace, looking down through his binoculars at the beach below. The wind was blowing his oilskin coat against his legs, making a loud snapping sound in the gale. He called me over, his voice flat and tight. I walked over and took the binoculars from him. He pointed toward the mouth of Pole Creek, where the brown river water emptied into the ocean surf. Along the sand spit, half submerged in the tide, was a long line of wooden pilings, the remains of an old fish cannery trap that had burned down in the 1930s. The pilings were heavy timber, green with algae and encrusted with barnacles, standing 6 feet above the waterline. They were no longer straight. The line of pilings, which had stood in a rigid parallel row for 80 years, was now curved into a broad, smooth arc that pointed inland toward the forest behind YK04. The sand around them was smooth, wiped clean by the rising tide, but the timbers themselves had been shifted, pushed, or drawn sideways through 30 feet of wet gravel without snapping a single beam. I lowered the binoculars and looked at Marcus. He was looking at his watch. He stated that the wind was 30 knots at the strip and the ceiling was dropping below 400 feet. He said if we didn't take off within 15 minutes, we would be staying on the beach until the storm cleared, which could be 3 days. We walked back down the trail toward the Cessna. The forest felt darker now, the canopy dripping with heavy water droplets that rattled against our rain jackets like small pebbles. The sound of the surf was louder, a continuous dull roar that seemed to vibrate through the floorboards of our boots rather than travel through the air. As we reached the clearing around YK04, Marcus stopped short. The wellhead was still standing in the mud, but the ground around it had changed. A circular trench about 4 inches deep and 2 feet wide had settled into the earth around the steel pipe. It looked as though the casing had been pulled downward into the earth and then pushed back up, drawing the surrounding soil down with it like thick syrup. The single-strand steel guy wire that anchored the nearby antenna mast had been snapped. The break was clean, the steel strands twisted and frayed as if subjected to immense tensile strain. I walked to the borehole cap and placed my hand against the metal again. The tremor was no longer subtle. It was a strong, steady, mechanical thrumming that pulsed at regular 2-second intervals. It felt like standing on the deck of a large diesel vessel when the engines are idling in deep water. Marcus reached out, grabbed my shoulder and pulled me back toward the trail. He didn't say anything, but his grip was hard enough to press through 3 layers of wool and rubber. We reached the airstrip just as the rain turned into a blinding, horizontal sheet. The wind was blowing diagonally across the gravel bar, kicking up dark spray from the river mouth. Marcus climbed into the pilot seat, threw his shotgun into the back, and started the engine. The propeller sputtered, caught, and roared into life, the plane shaking against the force of the crosswind. I climbed into the passenger seat, pulled the door shut, and strapped myself into the harness. My hands were shaking slightly, cold and wet from the rain. Marcus didn't run through his usual pre-flight checklist. He taxied quickly to the far eastern end of the gravel bar, spun the plane around into the wind, and shoved the throttle fully forward. The Cessna surged down the narrow strip, the Tundra tires bouncing violently over the drift logs and beach gravel. For a moment, the plane skidded sideways toward the roaring surf as a sudden gust hit the rudder, but Marcus corrected with a hard foot on the pedal, pulling the yoke back into his chest. The tires left the ground 20 feet before the gravel bar vanished into the ocean. We climbed slowly out over the dark water, the wings banking sharply to avoid the sheer rock cliffs of the headland. Through the rain-streaked side window, I looked down at the coastline one last time. The black sand beach, the dark band of Sitka spruce, and the gray concrete platform of the abandoned FAA station were already swallowing themselves in the thickening fog. But right at the edge of the forest, where the trail led up toward station YK04, a long, wide, smooth line was visible in the vegetation. A continuous pale trough cut through the green canopy, stretching from the foot of the mountain range straight out into the deep water of the Gulf. It wasn't a road, and it wasn't a landslide track. It was a perfectly uniform swath where the tops of 60-foot spruce trees had been pulled downward, bent flat into the earth without breaking, as if something heavier than the mountains had rolled over them from beneath the floor of the forest. Marcus didn't look down. He kept his eyes fixed on the instrument panel, his hands gripping the yoke until his knuckles were white, pushing the small plane north through the dark, turbulent air toward the high wall of the coastal mountains. We landed back at Yakutat an hour later in a driving rain. We didn't talk about what we saw while we tied the plane down to the concrete anchors on the apron. The official report I filed with Northern Seismic Systems 2 days later cited severe coastal erosion, structural destabilization of the soil matrix due to groundwater saturation, and sensor failure caused by salt air corrosion. The Geophysical Institute formally decommissioned Station YK04 the following month, marking the borehole as permanently abandoned on all state land maps. I resigned from my position with Northern Seismic Systems in November of that year, and moved south to take an onshore facility maintenance job with a marine transport firm in Puget Sound. I haven't been back to Alaska since. A few months ago, while sifting through archived public geological data on a late-night shift, I accessed the real-time telemetry feed from a newly installed environmental monitoring station near Icy Bay, 30 miles east of Cape Yakataga. The station's primary broadband seismometer was functioning normally, recording the usual ambient microseisms from the Pacific tide. But tucked down in the secondary channel diagnostic files, the raw, unfiltered pressure data from a subterranean bedrock strain meter, there was a clear, high-amplitude, low-frequency signal that repeated every 7 seconds. It had moved 12 miles east along the coast, perfectly parallel to the beach, dragging its slow, invisible weight through the deep granite beneath the earth. The mechanical stylus on the Stevens A35 stream gauge drum inside the zinc-roofed shelter on the lower Egegik River had been tracing a line on paper for 7 days after the copper float line snapped. But when I unrolled the waxed chart roll across my workbench, the pen had drawn an unbroken, highly intricate topographic cross-section of a sharp mountain range that lay 42 miles to the north. inked in a dark, rusted silt that had no chemical connection to the blue water-based ink cartridges we stocked in our field kits. I sat on an overturned wooden dynamite crate inside the cold shelter, the salt mist from Bristol Bay blowing through the gaps in the corrugated wall seams, trying to convince myself that a waterlogged branch had caught in the bottom pulley, or that the internal clockwork spring had slipped under the constant vibration of the autumn storm winds. The shelter was deadbolted with a heavy brass lock, accessible only to survey crews, and the key had been clipped to my canvas field belt since we dropped into the river mouth by skiff 3 weeks prior. Outside, the lower river swept past the gravel bar in gray, turbid swells, carrying thick slabs of slush ice down toward the ocean under a low, leaden ceiling of clouds that had hung over the Alaska Peninsula since the middle of September. My name is Garrett Thorne, and at 38 years old, I had spent 11 seasons as a hydrologic technician for the United States Geological Survey Water Science Center out of Anchorage. My job was straightforward, unglamorous, and demanding. Maintain the network of automated stream flow gauging stations across the subarctic watershed, collect water quality samples, measure discharge rates across remote river basins, and pull the sensitive seasonal transducers before the Arctic freeze converted the interior waterways into solid sheets of river ice. It was late October of 2017, and my field partner, Sut Hayes, was down on the riverbank wearing yellow commercial bibs, trying to clear frazzle ice out of the steel intake pipe with a long copper rod so we could calibrate the underwater pressure sensor before the late afternoon light faded completely into the gray twilight. Sut was 29, fresh off a master's program in hydrology from Montana State, full of academic theories about sediment transport, and still energetic enough to fight through head-high alder thickets without complaining. Our transport for this 2-week rotation was Frank Mac McIntyre, a taciturn, silver-haired bush pilot who had flown charters across southwest Alaska for 34 years and owned a battered, tundra-tired Cessna 206 that was currently resting on a gravel bench 200 yards upstream, its prop tied down against the rising coastal gale. I stepped out of the shelter and walked down the slippery mud bank, holding the paper roll flat against my chest to protect it from the horizontal freezing drizzle. Sut was leaning over the dark water, his breath rising in thick white plumes against the black volcanic gravel of the shore. When I unrolled the chart on the tailgate of our aluminum river skiff and showed him the dark brown trace, he squinted at the paper, wiped rain off his brow with the back of a neoprene glove, and let out a short, skeptical breath. He told me it was just a mechanical artifact caused by gears stripping when the float cable jammed in the shelter well, suggesting the pen had simply bounced repeatedly against the drum as the shelter vibrated on its timber pilings in the river current. But when I handed him my hand loop and pointed to the fine details along the apex of the traced peaks, he went quiet. Under 4 times magnification, the dark silt line wasn't a random scrawl of ink. It was composed of microscopic, perfectly parallel contour lines, spaced with mathematical precision, and at the highest point of the ridge, written in letters smaller than a grain of fine river sand, were the letters G152, corresponding exactly to an unmapped volcanic ridge near gas rocks on the southern shore of Beckeroff Lake. We spent another hour checking the shelter setup from top to bottom. The float well was a vertical corrugated steel pipe, driven 8 feet into the riverbed, connected to the open river by 2 horizontal intake tubes. There was no way for wind to turn the internal clockwork drum, which was driven by a heavy brass weight mechanism that ticked off hours with mechanical precision. Furthermore, the pen assembly was intact, its reservoir filled with fresh blue ink. Yet the dark line on the paper was completely dry, smelling faint and bitter, like crushed shale and old damp charcoal. Mac eventually walked down from the aircraft, his heavy oilskin jacket glistening with sleet, and reminded us that the atmospheric pressure was dropping fast over Bristol Bay. A massive maritime depression was pushing in from the Aleutian chain, bringing gale-force winds and temperature drops that would shut down all air travel across the peninsula within 18 hours. If we wanted to service the 2 remaining lake-level stations up at Beckeroff Lake before the freeze grounded us in king salmon, we had to pack our gear and fly inland immediately. We loaded the skiff back onto its trailer, secured the gauge house, and stowed our gear into the belly pod of Mac's Cessna. As the plane lifted off from the river gravel, the flat yellow-green tundra of the lower Agegik spread out beneath us like an endless wet carpet, broken only by winding black sloughs, tundra ponds, and the wide silver ribbon of the river twisting eastward toward the mountains. There are no trees on this part of the Alaska Peninsula, no tall spruce or birch forest like you find in the interior around Fairbanks or the Copper River Basin. It is a raw oceanic landscape dominated by dwarf willow, moss, volcanic ash dunes, and dark exposed rock, squeezed between the freezing waters of Bristol Bay to the north and the jagged snow-capped peaks of the Aleutian Range to the south. The wind here is a living thing, constant and relentless, blowing down off the glaciers with enough force to turn rain sideways and rip the doors off unlatched cabins. 20 minutes later, Mac banked the Cessna over the western arm of Beckeroff Lake, a massive body of water nearly 60 miles long that sits in a glacial basin near the base of Mount Pulik. From 3,000 feet, the lake looked like a sheet of dark slate, its surface whipped into white-capped waves by the prefront winds. Gas rocks rose out of the tundra near the southern shore, a cluster of dark, ominous basalt domes where cold carbon dioxide and subterranean gas vents bubble up through the tundra mud, leaving the surrounding earth barren, gray, and littered with the rusted remains of oil exploration rigs abandoned by survey crews in the late 1950s. Near the shore sat an old, 3-room plywood shelter cabin built by the federal government decades ago, used intermittently by fish and wildlife crews during summer salmon counts and USGS technicians during seasonal maintenance runs. Mac brought the Cessna down onto the rough gravel airstrip behind the cabin, the heavy tundra tires bouncing over the frozen tussocks before coming to a stop near an old fuel rack. The air here was noticeably colder than at the coast, hovering right around 20 degrees Fahrenheit, and the wind carried a distinct, sharp, metallic smell that had nothing to do with the ocean. We unpacked our cold-weather survival gear, 2 Honda gas generators, our water sampling kits, and an acoustic Doppler current profiler, a high-tech disc-shaped sonar device used to map underwater lake bottom topography and flow velocity. The plan was simple: set up our base at the cabin, launch our inflatable Zodiac boat out onto the lake to pull the underwater pressure sensors, record the lake stage data at the gas rock station, and wait out the approaching storm before Mac flew us back to King Salmon. By 5 in the afternoon, the sky had turned the color of bruised iron. The wind was gusting up to 40 knots, rattling the loose tin roofing of the cabin with a rhythmic, deafening clatter. While Mac stayed behind to drain the plane's fuel sumps and tie down the wing struts to heavy concrete deadmen sunk in the gravel, Sut and I dragged the Zodiac down to the lakeshore to run our acoustic sonar line across the outlet. The water was crystalline and extraordinarily clear, cold enough to ache through our neoprene gloves in seconds. As Sut steered the outboard motor, keeping us on a straight transect line 300 yards offshore, I sat in the bow with the Toughbook computer open inside a waterproof casing, watching the real-time bathymetric sonar return sweep across the screen. The bathymetry of Beckeroff Lake near Gas Rocks drops off sharply into a deep, glacial trough, running from 30 feet near the shore down to over 200 feet in the central basin. For the first 200 yards, the sonar displayed a standard, gently sloping profile of volcanic gravel and fine silt. Then, as we passed over the deep trench directly off the Gas Rocks headland, the depth display flickered, scrambled into a pattern of static, and suddenly locked onto a flat bottom reading of 0 feet. The digital gauge on the screen indicated that the sonar transducer, which was submerged 3 feet below the surface in open water, was resting on dry, solid ground. I reset the transducer signal and checked the underwater cable connections, but the readout remained locked at 0. Seconds later, the sonar screen began rendering a structural profile of the lake bottom that made my chest tighten. It was not mapping the lake floor or underwater boulders. The acoustic pulses were drawing a clear, sharp, inverted outline of a building sitting on the lake bed 80 feet below us. A rectangular structure with a peaked roof, timber supports, and a small square tower that matched the exact dimensions and floor plan of the federal shelter cabin sitting on the shore behind us. As I watched the screen in silence, the underwater sonar return showed a tiny, clear acoustic image of a human figure standing beside the submerged roof, holding a long rod upright in the water column. I called out to Sut over the roar of the outboard engine, telling him to kill the throttle. The boat drifted into the trough of a large wave, the rubber hull slapping hard against the frigid water. I picked up our weighted Kemmerer water sampling bottle, attached to the brass cable reel, and dropped it over the side to take a physical depth sounding and sample the bottom water. The brass weight pulled the line down smoothly through the clear water. I watched the depth counter on the reel turn. 30 feet, 40 feet, 50 feet. Then the line went completely slack at 52 feet, as if the lead weight had struck solid ground. I tugged on the braided steel wire. It was firm and taut, resting on something hard and unyielding. I began cranking the hand winch to haul the bottle back up to the surface. When the heavy stainless steel sampling cylinder broke the surface, it wasn't filled with silty lake water or volcanic mud. The clear acrylic tube of the bottle was packed tightly with dry, pale gray soil that smelled faintly of crushed willow leaves and dry lichen, earth that had not been used seen water in 100 years. Sut reached over, took a pinch of the soil between his fingers, and dropped it into his palm. It was bone dry, floating away on the coastal wind like fine gray dust. Neither of us said anything on the boat ride back to the shore. We pulled the Zodiac up beyond the storm tide line, secured the outboard motor, and carried our gear up the tundra ridge to the cabin. Mac had a wood fire burning in the old cast iron stove, using scrap spruce framing from an old oil rig crate he had found near the airstrip. The warmth inside the small cabin was a relief, but the atmosphere was heavy and subdued. I set the tough book on the laminate table, pulled up the raw data files from the sonar run, and tried to find a logical explanation for the strange readings. Sound waves in water can be bent or reflected by extreme thermal layers, high salinity, or heavy gas concentrations, and since gas rocks was known for subsurface carbon dioxide emissions, it was entirely possible that a concentrated plume of dense gas bubbling out of the lake bed had created a false acoustic mirror, reflecting the profile of the shoreline cabin back into the sonar receiver. It was a reasonable, scientific explanation, one that I wanted desperately to believe. We ate a cold dinner of canned beef chili and pilot bread, listening to the gale howl across the iron roof. By 8 o'clock, night had fallen completely, casting the peninsula into total impenetrable darkness. Out here, 50 miles from the nearest village, there is no light pollution, no glow on the horizon, no sound except the endless voice of the wind scraping across hundreds of miles of empty tundra. Mac spread his sleeping bag out on the lower wooden bunk, while Sut sat in the corner by the battery-powered radio, slowly tuning through the frequencies on our high-frequency single-sideband rig, trying to pick up the evening aviation weather update from the FAA station in King Salmon. The radio speaker didn't output the standard static or voice chatter. Instead, as Sut turned the dial across the marine and aviation bands, the speaker produced a dry, rhythmic, mechanical sound, a faint, steady tick, 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 that sounded precisely like the mechanical escapement gear of an old clockwork hydrograph drum recorder, ticking off time at exactly 16 beats per minute. Sut adjusted the squelch, switched to the emergency frequency on 121.5 MHz, and then to the USGS regional repeater channel, but the same steady, dry ticking followed across every single channel on the dial. Max sat up on his bunk, cleared his throat, and asked Sut to turn the radio off, saying the noise was making his teeth ache. Sut switched off the power toggle, but the small internal speaker continued to emit the faint, dry ticking for another 3 minutes before slowly fading into silence. At midnight, I couldn't sleep. The temperature inside the cabin had dropped as the stove burned down to white ash, and the wind outside was screaming in 3-note gusts that made the wall studs creak and flex. I pulled on my heavy insulated parka, pulled my headlamp over my wool cap, and stepped outside onto the small wooden porch to check the wing tie-downs on the Cessna. The storm had brought no fresh snow, only a thin, glassy crust of black ice that coated the tundra tussocks and turned the gravel path into a skating rink. The air was bitterly cold, dropping well below 10 degrees Fahrenheit, and the wind was strong enough to push me off balance as I walked around the side of the cabin. I shone the bright white beam of my headlamp across the gravel bench toward the aircraft. The Cessna was resting safely on its heavy tires, its ropes taut against the ground anchors. But as I swept the light across the frozen mud beside the left main tire, I stopped. There, pressed deeply into the ice-crusted soil, were 3 fresh boot prints. They were clear, sharp, and deeply indented, as if someone weighing 200 pounds had stepped off the wing of the plane and walked 3 paces toward the dark tundra. I walked over and knelt in the freezing wind to examine them. The tread pattern was an exact match for the heavy Vibram lug soles of my own Irish setter hunting boots, the very boots I was wearing at that moment. But what made my skin go cold was not the pattern. The mud inside the footprints was not frozen. While the ground all around them was hard as iron, the earth inside the impressions was soft, wet, and steaming faintly in the sub-zero air. And floating in the center of the middle print was a single, perfectly fresh green spruce needle that smelled of rich, wet forest soil. I stood up and swung my headlamp beam out into the pitch-black tundra, searching the low, dwarf willow thickets that stretched away toward the base of the Gas Rocks headland. There was nothing out there, only the gray expanse of frozen vegetation, the howling wind, and the dark, looming shape of the basalt domes 2 miles to the west. I called out Sut's name, then Max, but the wind tore my voice away instantly, carrying it out over the dark expanse of Becheroff Lake. I backed away from the plane, keeping my eyes fixed on the tundra, and hurried back inside the cabin, bolting the heavy wooden door behind me. I didn't tell Sut or Mac what I had seen near the plane. I sat on the edge of my bunk with my back against the wall, my hand resting on the aluminum case of our satellite phone, watching the frost form in crystalline patterns across the inside of the cabin window. At 3 a.m, Sut quietly got out of his bunk, pulled on his boots and canvas parka, and picked up his handheld Garmin GPS unit and a flashlight. I asked him where he was going in the middle of a gale, and he turned to me with a blank, tired expression on his face, his eyes heavy with sleep. He said he had left his water sampling notebook down at the secondary lake stage gauge shelter 1/2 mile down the shore, and that he needed to fetch it before the morning tide flooded the intake housing. I told him the lake had no lunar tide, and that stepping out into a 40-knot wind at 10 degrees below zero in total darkness was dangerous and unnecessary. He simply nodded, unlocked the cabin door, and stepped out into the dark before I could pull my boots on to stop him. I grabbed my coat, pulled Mac awake to let him know what was happening, and ran out into the gale after Sut. The wind was so intense now that it forced me to walk at a lean, driving ice spicules into the exposed skin around my eyes like small needles. Sut's flashlight beam was visible 200 yards ahead of me, moving along the low gravel ridge that ran parallel to the lakeshore. I called his name through the storm, but the wind swallowed the sound completely. I followed his light, my boots crunching through the frozen crust of the tundra, keeping my eyes on the white spot of his headlamp ahead in the blackness. When I finally caught up to him at the secondary gauge shelter, a small 4-foot-tall aluminum housing mounted on steel posts right at the water's edge, he was standing motionless in front of the padlocked shelter door, his flashlight pointed down at his own feet. He didn't turn around when I grabbed his shoulder. He was staring down at the base of the aluminum housing. The door of the gauge shelter was secured with a brass padlock that was coated in a thick shell of clear river ice. But from inside the sealed metal box came a loud, distinct sound that made my breath catch in my throat. It was the sound of a human hand knocking firmly against the inside of the thin aluminum wall. 3 short, sharp raps. Knock, knock, knock. Then a pause, followed by the faint, dry sound of a heavy paper roll unrolling across a wooden table, and the clear, distinct scratching of a pen drawing a continuous, jagged line. Sut reached out with his gloved hand and took hold of the icy padlock. He looked at me, his face pale under the light of my headlamp, his lips chapped and white from the cold. He whispered that he had tried to open it, but his key wouldn't fit into the keyhole because the keyhole was packed solid with dry, warm spruce needles. I pulled my heavy brass key out of my pocket, brushed the ice off the lock face with my thumb, and forced the key into the tumbler. The lock clicked open with a hard metallic snap. I yanked the shelter door open, throwing the beam of my flashlight into the small enclosed space. The shelter was completely empty. The mechanical hydrograph drum was gone. The float well was gone. The vertical intake pipe that should have dropped 8 feet down into the water-bearing gravel of the lakebed was replaced by an open, dry, circular shaft, lined with ancient, hand-hewn spruce timber, dropping straight down into absolute darkness. I leaned over the open shaft, holding onto the edge of the shelter frame to steady myself against the wind. From deep within the dry wooden shaft, 60 or 70 feet below the surface of the frozen lakeshore, came a warm, quiet draft of air that smelled of dried moss, wet wood smoke, and old oil lamps. And down in the deep, black floor of that wooden shaft, far beyond the reach of my flashlight beam, I heard a voice. A quiet, calm, American voice that matched the tone and cadence of my own voice perfectly, reading off a slow, monotonous sequence of numbers. Station, 15298,000. Stage height 0.0. Gauge height -40. OCT 24, 2017. I grabbed Sut by his safety harness, pulled him away from the shelter door, and slammed the aluminum cover shut, jamming the padlock back through the hasp. Sut didn't resist. He was staring at his Garmin handheld GPS screen. The digital map on the unit showed that our current location was not the shore of Becheroff Lake on the Alaska Peninsula. The satellite coordinates on the screen indicated that we were standing on a high, dry ridge in the interior of the Yukon Territory, 800 miles to the east at an elevation of 4,000 feet above sea level. Then the GPS screen flickered, displayed a series of garbled lines, and died completely, the screen turning solid black. We ran back along the shore toward the cabin, fighting against a wind that seemed to have shifted directions entirely, blowing from the lake toward the land with a cold, dry ferocity that tore the breath from our lungs. The darkness around us was absolute, unbroken by any shore light or star. Every 20 yards I looked down at the ground in front of my boots. The tundra tussocks were gone, replaced by a flat, smooth expanse of gray, dry silt that gave off a soft, powdery cloud with every step we took. The temperature had stopped dropping. In fact, the air was warming rapidly, turning soft, dry and thick, with the heavy scent of an old, undisturbed forest. When we finally saw the faint yellow light of the cabin window through the darkness, we rushed up the wooden steps and burst through the door, slamming it tight against the night. Mac was sitting by the stove, his face gray with exhaustion, a .30-06 hunting rifle resting across his knees. He looked up at us with wide, bloodshot eyes, his hand shaking as he pointed toward the small cabin window that faced the lake. He whispered that while we were gone, something had walked past the cabin from the direction of the lake. Not an animal and not a man, but something that left no sound in the wind and made the air inside the cabin turn so dry that the wood in the table had cracked open with a loud pop. None of us slept for the rest of the night. We sat around the wood stove in silence, listening to the cabin walls creak under the relentless pressure of the gale. The wind didn't die down until 6 in the morning, when the first pale gray light of the Arctic dawn began to filter through the frost-coated window pane. As soon as the light was strong enough to see the airstrip, Mac stood up, grabbed his flight bag, and said we were leaving immediately, storm warning or no storm warning. We didn't bother packing the skiff, the Honda generators, or our water sampling gear. We left everything in the shelter cabin, loaded our personal packs into the plane, and cleared the frost off the Cessna's wings with a stiff broom. The flight back to King Salmon was silent and turbulent. The sky was a vast sheet of gray stratus clouds, and the tundra below was buried under a thin, fresh dusting of powdery snow that smoothed out the contours of the land into a blank, featureless white expanse. When we landed at the King Salmon Airport, the FAA weather station reported that the storm had moved faster than predicted, dropping temperatures down to 5 degrees Fahrenheit across the peninsula. We checked in at the USGS field station, handed our logbooks to the regional supervisor, and reported that the lake stage gauges at Gas Rocks and the lower Egegik had been pulled and secured for the winter season. I filed my official field report 2 days later at the regional office on C Street in Anchorage. In the report, I noted that gauge 15298,000 on the Egegik River had suffered an internal mechanical failure due to a broken float line and gear slippage caused by ice accumulation in the intake well, resulting in corrupted chart data. I made no mention of the dry silt on the hydrograph paper, the inverted sonar profiles on Becheroff Lake, the dry wooden shaft beneath the lake gauge shelter, or the coordinates on Sut's GPS unit. In our profession, if you report something that violates the basic physical laws of surface water hydrology, you don't get an investigation. You get a mandatory medical evaluation and a desk job transferring paper records into digital spreadsheets. Sut left the survey 3 months later, in January of 2018. He packed his belongings into a small trailer, resigned from his position at the USGS, and moved to a small town in southern Arizona, far from any major rivers, lakes, or coastal watersheds. I spoke to him on the phone once, a year after the incident. His voice was flat, tired, and distant. He told me he had sold all his field gear, including his boots and rain suits, and that he could no longer stand to be in a room with a ticking clock or a running faucet. He didn't ask about Becheroff Lake, and I didn't bring it up. I stayed with the Water Science Center, but I transferred out of the Field Operations Division, taking a permanent office position in the Historical Data Archives in Anchorage. I spend my days cataloging old analog paper hydrograph charts, microfiche records, and survey maps from the early days of territorial Alaska, working in the quiet, windowless basement of the federal building. I haven't been back to the Alaska Peninsula since that October, and I have no desire to ever cross the Aleutian Range again. 6 months ago, while organizing a stack of uncatalogued paper streamflow rolls from a deactivated territorial survey station that operated near Becheroff Lake in the autumn of 1961, I found a rolled drum chart stored in a rusted tin canister. The waxed paper was yellowed and brittle with age, faded around the edges from 60 years of basement storage. I carefully unrolled the chart across my light table, weighting the corners down with brass paperweights. The ink line drawn on the yellowed paper was an exact, identical duplicate of the topographic cross-section I had pulled from the lower Egegik Gauge House in 2017. The same razor-sharp peaks, the same mathematical contour spacing, drawn in the same dark, dry brown silt that had never seen a pen cartridge, and written in pencil along the bottom margin of the 1961 chart roll, in clear, precise technical lettering that I recognized instantly as my own distinct handwriting, was a brief field note. Intake clear, sounding depth 0. Garrett Thorne, Oct. 24, 2017. The secondary storage drive recovered from an autonomous oceanographic weather buoy off the Yakataga Reef contained 42 minutes of uncompressed audio recorded while the unit was fully submerged in 90 feet of salt water, its internal microhydrophone recording a dry rhythmic knocking from the inside of its own sealed, vacuum-tested titanium casing. The buoy had been deployed 3 miles off the Gulf of Alaska coastline to record wave heights, water temperatures, and localized barometric shifts for shipping channels operating between Cordova and Yakutat. When the unit washed ashore on the black gravel flats west of the Yakataga River mouth, the physical housing was intact, the O-ring seals were pristine, and the internal nitrogen charge had maintained positive pressure throughout its 7-month immersion. There was no water ingress, no structural warping, and no sign of electrical shorting. Yet when the audio data was dumped onto my bench laptop during a routine maintenance pull, the waveform showed precise, high-frequency kinetic strikes against the interior wall of the acoustic chamber. The strikes occurred at exact 43-second intervals, each sound preceded by a slight 2 Hz voltage drop across the secondary telemetry board. My name is Caleb Ross. In the autumn of 2014, I was 38 years old, working as a senior contract telecommunications specialist for Alaska Avcom Services, a small firm based out of Anchorage that maintained automated navigational aids, remote radio repeaters, and automated weather observing systems for the Federal Aviation Administration and the National Oceanic and Atmospheric Administration along the outer Gulf Coast. I spent 6 months of every year living out of duffel bags, climbing lattice towers, swapping out lead-acid battery banks, and troubleshooting ground loop interference at some of the most isolated infrastructure sites in the Pacific Northwest. Cape Yakataga was one of those places where the logistics were always complicated and the weather was always in control. Cape Yakataga sits on a narrow, exposed strip of coastal tundra and glacial gravel pinched between the roaring gray, tempestuous expanse of the Gulf of Alaska and the towering, ice-choked wall of the Robinson Mountains, part of the St. Elias Range. There are no roads leading into Yakataga. There is no deep-water port, no regular ferry service, and no municipal grid. The entire settlement consists of a rough W-Twee-era gravel airstrip that is continuously encroached upon by coastal alder and drift logs, a handful of decaying Quonset huts left behind by mid-century oil prospectors, and a small wood-framed USGS field cabin nestled near the mouth of the river. To the north, the Bering Glacier spills millions of tons of ice into Vitus Lake, sending cold, katabatic winds whipping down the river drainage even on clear summer days. To the south, the ocean pounded the coast with a relentless, heavy surf that could be heard miles inland, a constant, low-frequency roar that formed the background noise of every hour spent on that shore. My assignment that September was straightforward on paper. The non-directional radio beacon and automated weather observing system at the Yakataga airstrip had been dropping signal intermittently for 6 weeks. Pilots flying the coastal route between Juneau and Anchorage relied on the Yakataga station for weather updates and low-frequency navigational bearing, especially when cloud ceilings dropped below 200 feet and squeezed air traffic into the narrow visual corridor over the surf line. I was tasked with spending 5 days at the airstrip shelter to replace the backup generator's automatic transfer switch, reseat the main antenna array's ground radial field, and pull the seasonal data drives from the nearby oceanographic monitoring buoys that the Coast Guard had retrieved from the surf. I flew out of Yakutat on a cold, overcast Tuesday morning aboard a battered Cessna 206, operated by Gabe Mercer. Gabe was 52 years old, a former commercial fisherman who had turned to bush flying after a hydraulic winch crushed his right knee in the 90s. He knew every beach landing strip, every spit of gravel, and every prevailing wind pattern along the 500 miles of jagged coast between Prince William Sound and Cross Sound. He sat in the pilot's seat with a half-empty mug of black coffee wedged between the control yokes, his faded ball cap pulled low over eyes that never stopped scanning the cloud bases and the gray water below us. The flight west took us low along the beach line. To our right, the massive cracked ice cliffs of the Malaspina Glacier looked like a frozen continent pushing into the sea, shrouded in gray mist and drizzle. The plane bounced and shuddered as we crossed the cold air plumes tumbling off the glacial valleys. Below us, the tide was coming in, washing over miles of dark, coarse sand strewn with massive Sitka spruce logs that had been swept out of river mouths during winter storms and beaten smooth by the ocean. Gabe lined the Cessna up on the Yakataga gravel strip, dropping us down through a layer of cold sea fog that smelled faintly of rotting kelp and wet silt. The landing was rough, the fat tundra tires throwing up showers of loose shale and gravel against the underside of the aluminum wings as we rolled to a stop near the rusted hulk of an old bulldozer. When the propeller spun down and the engine died, the sudden silence of the place hit me, as it always did at remote strips. Then the real sound of Yakataga filled the cabin, the deep, heavy thrum of the Gulf surf crashing against the beach 300 yards away, accompanied by the whistle of the cold wind through the rusted Quonset huts and the alder thickets. Gabe unbuckled his harness and reached into the back to help me haul my gear out onto the damp gravel. I had 4 heavy Pelican cases filled with diagnostic meters, soldering gear, replacement circuit boards, and a high-frequency time domain reflectometer, along with my cold weather survival suit, a canvas wall tent, a propane cook stove, and 2 weeks of dry rations. We weren't entirely alone at the strip. Standing near the edge of the overgrown brush was Dr. Arlene Vance, a 44-year-old coastal geomorphologist from the University of Alaska Fairbanks. She had been staying at the USGS cabin for 3 weeks, collecting core samples from the tidal mudflats to measure shoreline uplift following the major seismic events of the previous decade. Arlene was a practical, sharp-spoken woman who wore oilskin bibs, a stained wool sweater, and mud boots that were perpetually caked in gray glacial clay. She came out to the plane to help us carry the heavier tool cases toward the small plywood shelter at the base of the 80-foot lattice radio tower. Gabe didn't like staying on the ground at Yakataga longer than necessary. The coastal weather was notoriously unstable, and a sudden wind shift off the Gulf could pull a wall of zero-visibility fog over the strip in 15 minutes, trapping an aircraft for days. He checked his fuel tanks with a wooden dipstick, took a quick sip from his thermos, and told me he'd be back in 4 days to pick me up, provided an autumn storm system building down near Kodiak didn't accelerate its movement eastward. He throttled up the Cessna, turned around on the narrow strip, and within 2 minutes his aircraft was just a fading buzz in the gray overcast toward the east, leaving Arlene and me standing on the gravel surrounded by miles of empty tundra and ocean. I spent the first afternoon setting up my workspace inside the radio shelter. The structure was little more than an 8 by 10 foot windowless shed made of exterior grade plywood, painted dark green, and anchored to a heavy concrete pad with galvanized steel cables. Inside, the air was cold and damp, smelling strongly of ozone, battery acid, and old diesel fuel. A rack of aluminum equipment frames held the dual VHF transmitters, the shortwave receiver units, the solar charge regulators, and the backup lead-acid battery array. My primary task was to figure out why the automated weather observing system had been logging erratic signal drops every few hours. I hooked my diagnostic laptop into the main bus line and ran a full system diagnostic. The equipment was old, but simple. The weather sensors, a mechanical cup anemometer, a heated tipping bucket rain gauge, a barometric pressure sensor, and a temperature probe, were mounted on a crossarm 20 feet up the lattice tower. The raw data was digitized in the shelter, encoded into a low-frequency radio burst, and broadcast continuously on a dedicated aviation frequency. The diagnostic logs showed that the hardware itself was functioning within normal tolerances. The voltage outputs from the solar panels were clean. The battery cells held a solid 12.6 volts under load, and the transmitter output power was stable at 25 watts. Yet embedded in the digital log files were microsecond timestamps, where the input resistance on the external C-ground wire dropped to absolute zero. In a standard coastal installation, a C-ground wire is a heavy, braided copper conductor that runs from the base of the radio shelter down into the ocean or saturated tidal mud. Its purpose is to provide a low-resistance path to Earth for static electricity built up by ocean fog and lightning, protecting the sensitive solid-state electronics inside the building from high-voltage transients. When I ran a time domain reflectometer test down the copper ground wire to check for physical breaks or corrosion beneath the sand, the pulse display on my screen showed something that didn't make electrical sense. A standard TDR test sends a tiny electrical pulse down a cable and measures the reflection that comes back when the pulse hits an anomaly, a break, or the end of the wire. If the wire is intact and properly grounded in wet salt water, the signal trace should taper off smoothly into a flat, absorptive baseline. My trace didn't taper off. Exactly 74 meters down the cable, a distance that placed the end of the wire roughly at the high tide line on the beach, the signal hit an instantaneous infinite impedance wall, reflected back with 100% amplitude, and showed a secondary harmonic echo that mimicked the exact shape of a digital clock signal. It was as if the end of the copper cable was plugged directly into an active, highly regulated electrical circuit operating at an extreme high frequency, far beyond anything the low-voltage weather station could produce. I assumed it was a ground loop issue caused by stray currents from an old abandoned shore cable, or perhaps a corroded cathode protection system left behind by one of the defunct oil drilling rigs that had operated along the coast in the 1960s. I grabbed my insulated hand tools, a digital multimeter, and a handheld VHF scanner, and walked down the gravel track toward the beach to visually inspect where the ground wire entered the surf line. The afternoon light was already fading. In late September at Cape Yakataga, the sun sits low on the southern horizon, casting long, bruised shadows across the tundra before dipping into the sea, leaving behind a cold, blue twilight that lasts for hours. The wind off the Gulf was picking up, pushing 3-foot waves onto the black gravel beach. The air was wet and bitter cold, forcing me to pull my grease-stained beanie down low over my ears. I traced the heavy green insulated copper wire from where it exited the concrete foundation of the radio shelter, ran through a protective PVC conduit beneath the alder bushes, and emerged onto the upper terrace of the beach. The wire was anchored to heavy creosoted driftwood logs with brass staples, running straight down across the tide-washed shale toward the water. When I reached the point where the wire met the wet sand, I stopped. The copper cable had been neatly freed from its heavy brass staples. The thick wood had not rotted out, and the staples had not pulled free under wave action. They had been pulled straight out of the hard timber as if swung with a heavy pry bar, and laid neatly in a small pile beside the log. The copper wire itself had been lifted out of its trench in the sand, and unspooled in a perfectly straight line that extended down past the low tide line, continuing directly out into the roaring surf. I knelt down on the damp sand and pulled off my heavy work gloves to inspect the wire. The thick insulation on the cable showed no signs of friction wear, ocean drag, or bite marks from wildlife. It was clean, but where the wire entered the churning, cold, gray water of the Gulf, it was held rigid under immense tension. I reached down and gripped the cable, tugging on it gently. It didn't budge. It felt as though the end of the wire had been anchored to a massive, submerged weight sitting far out beyond the breaker zone. As I held the wire, I felt a faint mechanical vibration traveling up the copper strand through my bare fingers. It was not the organic, chaotic sloshing of the ocean waves or the heavy thud of surf hitting the shore. It was a precise, high-frequency kinetic pulse that hit my hand 3 times in rapid succession, paused for 2 seconds, and repeated. It was the exact physical sensation of someone taking a small steel hammer and striking the wire beneath 90 feet of ocean water. I dropped the cable. The sudden shock of the cold salt water and the unexplainable pulse made my chest tighten. I stepped back onto the dry gravel of the upper beach, rubbing my cold fingers against my canvas trousers, scanning the gray expanse of the Gulf of Alaska. Out to sea there was nothing visible except the dark, violent waves rolling toward the shore, a few whitecaps breaking over the shallow reef 2 miles out, and the low, heavy ceiling of gray clouds stretching all the way to the horizon. I picked up my multimeter and set the dial to test for direct current voltage between the copper wire and a steel ground rod I drove into the dry shale above the tide line. The digital display flickered, cleared, and locked onto a steady reading, 1.414 volts. That specific number struck me immediately. It was not a random leakage voltage. In electrical engineering, 1.414 is the square root of 2. The exact mathematical factor used to calculate the peak voltage of a pure, uncorrupted, sinusoidal alternating current wave from its root mean square value. Random galvanic action between salt water and copper produces fluctuating millivolts that wander wildly based on ocean temperature and salinity. It does not produce a precise, mathematically clean mathematical constant. I took out my notebook, recorded the voltage reading, the time, and the physical condition of the ground cable, and walked back up to the cabin as the last pale light faded from the sky. The USGS cabin was a low, sturdy building constructed from heavy spruce logs that had been brought in by barge back in the 1970s. It had a steep tin roof to shed winter snow, a wood-burning stove made from a cut-down iron barrel, and 4 double bunks lined with thin vinyl mattresses. Arlene had transformed the main wooden dining table into a field laboratory covered in sediment trays, plastic core tubes, glass specimen jars filled with marine silt, and a portable binocular microscope. A kerosene lamp hung from a rafters, casting a warm, flickering orange light across the room and filling the air with the familiar heavy smell of burning lamp oil and drying wool. When I walked in, shaking the cold drizzle from my rain jacket, Arlene was sitting at the table with a magnifying glass, making neat entries in a leather-bound logbook. "Did you find your ground fault?" she asked, without looking up from her work. Her voice was raspy, worn down by years of field work and cold ocean air. "The ground cable's intact, But it's been pulled off the drift logs, I said, leaning my back against the warm iron stove to dry out my trousers. It's resting out in the deep water past the low tide mark. Tension on it is incredible. Feels like it's hooked onto a submerged vessel or a heavy piece of marine debris that shifted in the last storm. Arlene paused, her pen hovering over the paper. She looked up at me through her wire-rimmed reading glasses. There aren't any vessels out on the reef, Caleb. Not within 4 miles. My hydrophone array has been in the water at 90 feet since last Tuesday. I would have heard a wreck shifting or an anchor dragging across the gravel shelf. The sea floor off the point is hard clay and basalt. What about the old drill platform casing from the offshore exploration in '68? I asked, reaching for the tin coffee pot sitting on top of the stove. The one NOAA marked as a navigational hazard on the coastal charts? That structure was blasted down to the mudline by the Army Corps of Engineers in '74, Arlene said quietly. She closed her logbook and sat back in her wooden chair, resting her hands on her lap. There's nothing down there except sediment beds and cold water. But I did pull something strange off my bottom-mounted bathymetric scanner this morning. She reached across the table, grabbed a roll of thermal paper, and unrolled it across the wood. The paper showed a long, continuous graphic printout of the seabed topography directly off Cape Yakataga, generated by her side-scan sonar. The seabed was rendered in shades of gray, showing the rough, jagged basalt ridges near the reef tapering off into the smooth, flat sediment beds of the continental shelf. She pointed her finger at a section of the printout 2 miles south of the radio tower. Running straight across the smooth gray background of the sediment bed was a series of deep, narrow, parallel channels. They were carved into the dense clay 60 feet below the waterline. What made them impossible was their direction and geometry. Natural underwater trenches formed by ocean currents or iceberg gouges always follow the line of the prevailing riptide, carving soft, curving paths along the path of least resistance. These channels were perfectly straight. They were spaced exactly 4 meters apart, running directly against the powerful 6-knot coastal current, heading in an unbroken, unyielding line straight out of the deep ocean toward the shallow waters of the Yakataga Reef. "How deep are those marks?" I asked, leaning closer to inspect the fine lines on the thermal paper. 14 inches deep into consolidated glacial clay, Arlene said. And they weren't there when I surveyed the same transect 14 days ago. Something heavy dragged itself, or drove itself, along the bottom, coming up out of the abyssal trench toward the shore. It cut through 2 miles of clay without deviating a single degree from a true north magnetic bearing. A sub? Navy Marine survey craft? Arlene shook her head slowly. The water inside the reef line drops to less than 20 feet at low tide. No submarine skipper in the world would run a hull into shallow water off Yakataga unless they wanted to tear their bottom open on the basalt shoals. Besides, look at the edges of the gouges. She handed me her pocket magnifying glass. I held it over the paper. The edges of the channels were not smooth and rounded, as they would be if carved by a towed cable, a ship's anchor, or an iron dredge. The edges were sharp, serrated, and stamped with a repeating pattern of small triangular notches, as if a massive gear-driven wheel or a segmented, heavy metallic track had been pressed into the seabed with enormous hydraulic force. "Is that where you found the buoy?" I asked, thinking back to the secondary storage drive I had pulled from the oceanographic logger that afternoon. "The buoy was anchored right at the eastern edge of those tracks," Arlene said. Its heavy concrete anchor block had been moved 80 yards to the west against the current before the steel cable snapped. Neither of us spoke for a minute. Outside, The wind rattled the tin roofing sheets and the roar of the surf seemed to grow louder as the tide turned, pushing heavy gray water against the black gravel beaches. I turned back to my tool bag, pulled out my laptop, and booted it up on the corner of the wooden table. I opened the audio processing software I used to analyze radio signal noise and loaded the 42-minute sound file I had extracted from the submerged buoy drive earlier that afternoon. "Listen to this," I said, tapping the spacebar to start playback through the laptop's small internal speakers. The room filled with the ambient, low-frequency white noise of the underwater recording. The deep, muffled rumble of distant wave action, the crackle of snapping shrimp on the seafloor, and the faint, hollow hum of the buoy's titanium housing vibrating in the ocean current. Then came the sound. It was a sharp, clear, dry strike against the inside wall of the casing. Tink. Arlene leaned forward, her face turning pale in the yellow light of the kerosene lamp. "That's an interior strike. That's not something hitting the outside of the hull through 90 feet of water. Water dampens high frequencies. That sound was generated inside an air-filled chamber. The titanium housing was nitrogen purged and vacuum sealed at the factory in Seattle," I said, pointing at the audio visualizer on my screen. There were no moving parts inside the sensor package except a solid-state pressure transducer and a circuit board. Nothing to swing, nothing to fall. The recording played on in silence for 43 seconds. Then, with absolute mechanical precision, the sound repeated. Tink. The visualizer showed a sharp, vertical spike in the upper frequency spectrum, a spike that reached 40 kilohertz, well beyond the range of human hearing, before settling into a ringing metallic resonance that took 3 seconds to decay. "Play it at half speed," Arlene whispered, her eyes fixed on the screen. I adjusted the playback speed control to 50% and hit spacebar again. The reduced speed exposed a layer of sound that had been compressed within the high-frequency strike. Before the physical impact hit the titanium wall, there was a tiny, localized air displacement sound. A faint, wet hiss, like high-pressure gas forcing its way through a microscopic valve, followed by a low vocal range harmonic vibration that sounded terrifyingly like a human throat clearing itself before speaking a single guttural, unpronounceable syllable. The laptop screen suddenly flickered, the audio froze on a screeching digital buzz, and the blue power light on my laptop turned dark. The machine was completely dead. I pressed the power button repeatedly. Nothing. The machine was dead. The machine was completely dead. The aluminum housing near the battery compartment was burning hot to the touch. "What was that?" Arlene asked, her voice tight, standing up from her seat so quickly her wooden chair scraped hard against the floorboards. "Thermal runaway in the laptop battery," I said, though I knew that was a lie. The battery wasn't hot from a chemical short. The heat was radiating evenly from the solid-state storage drive where the audio file was stored. Before I could remove the laptop battery, the small handheld VHF scanner sitting on my tool bag burst to life with loud, unsquelched static. The red signal indicator LED was glowing solid green, indicating a powerful, close-range signal was overriding the channel. Through the white noise came a voice. It was not a pilot reporting a flight position. It was not a Coast Guard vessel out in the Gulf. It was a synthesized, flat, rhythmic voice, the automated voice of the Yakataga AWOS weather system I had come to repair. Yakataga Automated Weather Observation 0359 observation time, wind 000 at 0 knots, visibility 0, cloud ceiling 0, barometric pressure 0.00, temperature -40, dew point -40, remarks, sea ground wire, connected, Sea ground wire, active. The voice stopped abruptly. The scanner returned to a flat, silent static. I stared at the radio. The AWOS transmitter was powered by a 24-volt lead-acid battery bank sitting inside the radio shelter, 300 yards away through the dark brush. The automated voice was generated by an old solid-state speech synthesis chip installed on the motherboard in 1998. That chip had a fixed vocabulary of 92 words, hard-coded onto an EPROM microchip. The word connected was not in its vocabulary chip. Neither was the word active. I grabbed my heavy flashlights, my waterproof yellow slicker, and my heavy tool belt. "I'm going back to the shelter," I said, my heart hammering against my ribs like a trapped bird. Something is backfeeding current into the transmitter array. "I'm coming with you," Arlene said, reaching for her oilskin jacket and a heavy 3-cell maglite torch from the wall peg. "You shouldn't be walking near those line feeds alone in the dark." We stepped out of the USGS cabin into the black coastal night. The storm that had been building off Kodiak had arrived early. The wind was whipping off the sea in 60-knot gusts, throwing freezing rain and ocean spray sideways across the gravel flats. The ambient light of the sky was completely gone. The heavy overcast cloud deck had dropped down to the tops of the coastal alders, sealing us in a pocket of pitch-black darkness that swallowed the light from our heavy flashlights 15 feet ahead of us. The air smelled strange. The clean, salty tang of the sea air was gone, replaced by a thick, metallic stench that smelled like wet copper plates, ozone, and ancient anaerobic river silt dredged up from the deepest trench in the earth. We made our way along the gravel track toward the radio shelter, our heavy boots sinking into the wet mud. The sound of the wind screaming through the lattice work of the 80-foot antenna tower sounded like a high-pitched siren echoing across the empty tundra. When we reached the shelter, I saw that the exterior safety floodlight mounted above the steel door was flickering wildly, dropping from bright white to a dull, glowing orange filament in rhythm with the roar of the surf hitting the beach. I pulled the iron handle on the shelter door and pushed it open. The air inside was hot, at least 90 degrees, and thick with the smell of scorched electrical insulation. The heavy lead-acid backup batteries sitting on the bottom shelf were off-gassing violently, their plastic cases bulging against their iron hold-down straps, small bubbles of sulfuric acid bubbling out of the vent caps. On the main radio rack, the diagnostic meters were all pinned to their maximum limits. The needle on the analog RF output meter was pegged hard against the right stop pin, so hard the glass face of the meter had cracked under the pressure of the indicator arm. The station was transmitting. It wasn't transmitting a standard aviation weather broadcast. It was dumping a raw, unmodulated, high-frequency ground wave signal directly down the sea ground wire into the ocean floor. "Caleb!" Arlene shouted, her voice barely audible over the loud 50 hertz hum vibrating through the plywood floorboards. She was standing at the threshold of the open door, pointing her flashlight beam down toward the base of the lattice tower. "Look at the concrete pad." I stepped out of the shelter and pulled my flashlight beam toward where she was pointing. The heavy, steel-reinforced concrete foundation pad for the 80-foot tower was 3 feet thick, poured deep into the underlying glacial till in 1982. The pad was smoking. Rainwater hitting the top of the concrete was instantly flashing into white steam, rising in thick, dancing plumes into the freezing night air. Around the base of the pad, the black gravel had been pushed back in a smooth, continuous circle 6 feet wide. It was not a footprint. It was a continuous, heavy depression, pressed 2 feet deep into the frozen stones, as if an enormous, toroidal ring of immense weight had lowered itself down around the tower foundation, crushed the shale into fine powder, and drawn back toward the ocean. Leading away from the smoking concrete pad, heading down the low bank toward the beach, was a wide, smooth track in the mud and tundra. The track was 12 feet wide. In the center of the track, the brush, the alders, and the coastal grass had not been broken or flattened. They had been calcified, turned into a brittle, white, mineralized ash that crumbled into fine powder when the freezing rain hit it. I walked to the edge of the track, my headlamp cutting through the steam rising off the ruined vegetation. I knelt down, pulled a pair of steel pliers from my tool belt, and touched the metal jaw to a piece of the calcified alder brush. The steel pliers instantly bonded to the plant stalk with a sharp, high-voltage spark that threw blue light across my face and sent a violent shock running up my arm into my shoulder, knocking me backward onto the wet gravel. "Don't touch it!" Arlene screamed, grabbing my yellow rain slicker and dragging me back toward the shelter door. "The entire ground plane is charged." I sat on the gravel, gasping for air, my arm completely numb, my jaw aching from the shock. My eyes were watering, but I could see the wide, bleached track clearly in the beam of Arlene's flashlight. It led down the tundra, across the gravel bank, and straight onto the beach toward the dark, thrashing waters of the Gulf of Alaska. Out on the water, half a mile off the point where the Yakataga Reef lay hidden beneath the storm waves, something was breaking the surface. It was not a vessel. It had no running lights, no mast, no superstructure, and no exhaust plume. In the flashes of lightning that lit up the low cloud base, we could see a massive, smooth, black geometric form rising 30 feet out of the breaking waves. It was shaped like a truncated pyramid, its sides completely smooth and non-reflective, cutting through the 12-foot sea swells without producing a bow wave or a wake. Around the base of the structure, the violent ocean water was not crashing or foaming. The waves simply stopped moving. For 50 yards around the black form, the surface of the Pacific Ocean was completely flat, smooth, and motionless, as if frozen into a solid sheet of dark glass despite the gale-force winds screaming across the Gulf. As we watched, a brilliant pale blue arc of static electricity, 10 feet thick and completely silent, leaped from the top of the black pyramid straight into the heavy cloud deck above. The sky illuminated with a soft, eerie violet glare that lasted for 6 seconds. During those 6 seconds, every metal object on our persons, my tool belt, Arlene's glasses frame, the brass grommets on our slickers, the steel watch on my wrist, began to sing with a high-pitched harmonic tone that sounded like a crystal glass being rubbed by a wet finger. Then the blue light vanished. The dark pyramid shifted position. It did not turn or bank like a ship. It slid sideways across the water with impossible speed, silent and effortless, moving against the tide and wind toward the deep water of the trench, disappearing into the black rain and sea fog within 5 seconds. The moment it passed beyond the reef, the flat, motionless patch of water collapsed. A massive 12-foot breaking wave smashed over the basalt shelf, throwing tons of white foam and black gravel high onto the beach with a deafening roar that shook the ground under our feet. Inside the radio shelter, the backup batteries stopped off gassing. The high-voltage hum in the floorboards dropped to nothing. The broken RF meter arm settled against its lower stop pin. The station was dead. We stood in the driving rain for over an hour, holding our flashlights, staring out at the black ocean where the object had been. Neither of us spoke. There were no words in standard navigational manuals, no terms in coastal geology textbooks, and no concepts in telecommunications engineering that could bridge the gap between what we had just witnessed and the reality we had lived in until that night. We spent the rest of the night inside the USGS cabin with the door barred, the wood stove burning at full heat, and every lantern we possessed lit on the wooden table. Arlene did not return to her sediment core samples. She sat on her bunk with a heavy wool blanket wrapped around her shoulders, staring at the floorboards, her hands clenched tightly in her lap. I sat at the wooden table with my hand tools, systematically taking apart my dead laptop and my field meters, cleaning salt spray off the components, trying to fix something, anything, that belonged to the rational mechanical world I understood. When dawn finally broke around 7 in the morning, the storm had moved inland toward the Wrangell Mountains. The sky was a pale, freezing blue, clear and sharp, revealing the white snow lines that had dropped down to 2,000 feet on the slopes of the Robinson Range during the night. The temperature had plummeted to 20 degrees Fahrenheit. The mud puddles along the airstrip track were frozen solid with clear, brittle ice that cracked under our boots as we walked back to the shelter. The physical evidence of the night was still there, preserved in the freezing mud and shale. The wide 12-foot track running from the sea to the radio tower had not washed away. The calcified vegetation had turned into a fine, white, chalky residue that lay frozen in the gravel. The base of the lattice tower concrete pad was cracked down the middle, a clean structural fracture 2 inches wide that extended through 3 feet of reinforced concrete, as if crushed by a weight the earth was never meant to support. The copper sea-ground wire was gone. It had not snapped. It had not been cut by a sharp rock or torn free by wave action. The thick 3-inch copper cable had been fused directly into the black basalt bed of the beach at the high tide line, transformed into a flat, smooth ribbon of green patinated copper slag that looked as though it had been melted by a thermite charge and pressed flat into the stone before cooling. At 10 o'clock that morning, we heard the faint, beautiful roar of an aircraft engine approaching from the east. Gabe Mercer brought his Cessna 206 down through the clear mountain air, lining up on the Yakataga gravel strip and dropping the plane onto the hard frozen ground with a sharp bounce. He rolled to a stop near the Quonset hut, killed the engine and stepped out onto the wing strut, holding a fresh thermos of coffee and looking around at the frosty tundra. "You two look like you got dragged through an ice chute," Gabe said, stepping off the tire and walking toward us, his boots crunching on the frozen gravel. "Weather blew up wild last night down in Yakutat. Had 70 knots at the airport. Thought for sure you folks would be blown out into the Gulf." I looked at Arlene. She looked back at me, her face pale, her lips thin and pressed tight together. She shook her head, a tiny, almost imperceptible movement that said everything that needed to be said. "We had some line trouble," I told Gabe, my voice sounding hollow and unfamiliar in my own ears. "Generator switch failed. Transmitter went down around midnight." Gabe looked at the cracked concrete pad at the base of the antenna tower, then at the scorched ground leading down to the beach, his sharp brown eyes taking in every detail. He was a man who had lived 52 years along the wild, lonely edges of Alaska. He had seen strange things in the bush, inexplicable lights on mountain passes, ice formations that didn't match the temperature, old native sites that dogs refused to walk through, and he knew when a story was not meant to be pulled out into the light. He didn't ask a single question. He helped us pack our gear into the back of the Cessna. Arlene packed her specimen jars and quart tubes in silent, careful movements, wrapping each glass container in heavy bubble wrap as if handling fragile explosives. I pulled my diagnostic tools, my diagnostic laptop, and my personal gear out of the shelter, padlocked the door, and left the Yakataga weather station completely dark and silent. The takeoff was smooth. As Gabe pulled the Cessna up over the surf line, banking hard to the east toward Yakutat, I looked down through the side window at Cape Yakataga spread out below us. From 3,000 feet in the brilliant autumn sunlight, the cape looked small, fragile, and utterly alone, a microscopic sliver of dark gravel caught between the infinite white wilderness of the glacial ice fields to the north and the endless deep blue expanse of the Pacific Ocean to the south. I could see the broad, straight track in the beach sand clearly from the air. It ran out from the base of the small green radio shelter, crossed the black gravel spit, passed through the shallow white breakers on the reef, and extended far out into the dark, deep ocean water of the Gulf, continuing in a straight, unyielding line until it vanished into the abyssal gloom of the coastal shelf. I left field maintenance work for Alaska Avcom 2 years later, in the autumn of 2016. I took an office job in Anchorage with a commercial telecommunications firm, managing fiber optic network routing layouts from a heated desk on the 7th floor of an office building on C Street. I stopped flying in bush planes. I stopped climbing lattice towers. I stopped carrying diagnostic meters into places where the road network didn't go. Arlene Vance resigned from the University of Alaska Fairbanks in 2015. She took a position with a marine research institute in Norway, spending her years on deep ocean bathymetric survey ships in the North Atlantic. We never spoke again after the flight back to Yakutat. We never exchanged emails, we never called each other, and we never mentioned the name Yakataga in any professional paper or public forum. The official report I filed with the Federal Aviation Administration for the incident at Cape Yakataga in September 2014 was 3 pages long. I cited a severe atmospheric high-voltage transient caused by a localized lightning strike on the main lattice tower, resulting in catastrophic battery failure, grounding field vaporization, and structural thermal stress to the concrete foundation pad. The report was accepted without question, filed away in a steel cabinet in the FAA regional office in Anchorage, and forgotten. The station at Yakataga was fully decommissioned in 2018. The lattice tower was taken down by an Army Corps of Engineers crew, the green shelter was hauled away on a sea lift barge, and the automated weather reporting was transferred to an orbital satellite link that requires no terrestrial line feeds and no ground wire. 7 years after that night, in the winter of 2021, I was working late in my Anchorage office, digitized archival records of early coastal navigational aids for an infrastructure historical project I was supervising for the State Telecom Board. I was going through digitized paper microfilms from the United States coast and geodetic survey records from the spring of 1964, specifically looking for records of radio beacon stations that had been damaged or destroyed during the Great Alaska Earthquake of March 27th. I opened a scanned PDF file containing the handwritten daily station log from the original Cape Yakataga radio monitoring site, dated March 28, 1964, 12 hours after the magnitude 9.2 megathrust earthquake had devastated the coast of Prince William Sound. The log had been written by hand in blue fountain pen ink by a lead technician named Arthur Lindquist, a man who had served at the Yakataga station throughout the early Cold War era. The handwriting was neat, precise, and professional, recording standard barometric pressures, generator fuel levels, and hourly shortwave signal check-ins with the station in Cordova. At 3 o'clock in the morning, on March 28, 1964, while the coastal ice shelves were collapsing into the sea and 30-foot tsunami waves were pounding the outer islands, Lindquist had made a single final entry at the bottom of the ledger page. The entry consisted of 2 lines written in shaky, pressed ink that had smeared slightly on the old paper. The first line recorded an anomalous harmonic frequency pulse picked up on the shortwave receiver, occurring at exact 43-second intervals, coming from a source located directly offshore on the Yakataga Reef. The second line was not an official technical observation. It was a short, handwritten note written in the margin, next to the frequency coordinates. The water on the reef has stopped moving. Something is coming up the sea wire to read the numbers. Pasted directly beside the handwritten note was a small, square, black and white Polaroid photograph that Lindquist had stapled to the paper log before abandoning the station 62 years ago. The photograph showed the interior of the Yakataga radio shelter, illuminated by the flash of the camera in the dark room. Sitting on the wooden workbench in front of the shortwave receiver array was an old, heavy metal-cased triplet analog multimeter, the direct mechanical ancestor of the digital diagnostic meter I had carried in my tool bag 50 years later. The photo was sharp enough that I could zoom in on the display face of the meter. The needle on the voltage dial was locked onto a position that indicated exactly 1.414 volts, and scratched clearly into the dull gray paint on the front metal panel of the vintage 1964 multimeter, scratched into the casing with the fine point of an electric engraving tool, was a 14-digit equipment serial number. It was my serial number. It was the exact, unique serial number of the digital multimeter I had bought brand new from a technical supply house in Seattle in the spring of 2013, and which I had left sitting on the wooden table inside the USGS cabin at Cape Yakataga when Gabe Mercer flew us out into the cold gray sky 7 years later. The acoustic pressure transducer buried beneath 8 feet of frozen river mud at Mesquite Station 4 recorded 42 minutes of rhythmically spaced, 25-pound physical impacts occurring against the inside of its sealed titanium casing, while the sensor was locked under 3 feet of solid ice. I still have the raw binary file saved on a flash drive that sits in the bottom drawer of my desk in Anchorage, though I do not need to open it to remember the spacing of those pulses. They were separated by precisely 4.2 seconds, a cadence that never varied by even a fraction of a millisecond over the entire duration of the file, recorded between 3 and 4 o'clock on the morning of October 24, 2016. At the time, I was 34 years old, working as a contract hydrologic technician for the United States Geological Survey, in partnership with the Alaska Department of Natural Resources, assigned to monitor seasonal water displacement, sediment transport, and bedload dynamics along the lower Alaska Peninsula. My partner for that field season was Marcus Lindquist, a 52-year-old senior hydrologist who had spent nearly 3 decades surveying river systems from the Yukon-Kuskokwim Delta down to the Aleutian Chain, a man whose practical, unsentimental approach to the harsh realities of rural Alaska had made him a legend among the small corps of technicians who kept the state's automated environmental monitoring network running. We were operating out of Port Hayden, a remote coastal village sitting on the northern shore of the Alaska Peninsula along Bristol Bay, roughly 400 miles southwest of Anchorage. The landscape there is defined by its radical, wind-scoured vulnerability. Low tundra covered in dwarf willow, crowberry, and lichen, bordered on one side by the gray, pounding waters of the ocean and on the other by the dark, jagged volcanic peaks of the Aleutian Range, dominated by the massive caldera of Mount Aniakchak. The village itself rests near the mouth of the Mesquite River, a wide, shallow, braided river system that drains the wet tundra basin between the mountains and the bay, carrying silt, volcanic ash, and glacial runoff through a complex maze of gravel bars, sloughs, and tidal mudflats. In late October, the peninsula enters a bleak transitional twilight where the sun hovers low over the horizon for only a few pale hours a day, casting long, bruised purple shadows across the tundra, while cold, high-density gale winds blow in off the Bering Sea, bringing freezing rain, ice pellets, and sudden, blinding snow squalls that can lock down the entire region for days at a time. Our job during those final weeks before the deep winter freeze-up was to service 4 automated hydrological stations positioned along the length of the Mesquite River Basin. These stations were self-contained monitoring units mounted on heavy steel pilings driven into the gravel banks or bolted to bedrock outcrops, powered by solar panels and deep-cycle marine batteries, and equipped with Campbell Scientific CR1000 data loggers that recorded water temperature, conductivity, turbidity, and hydroacoustic pressure. The data was stored locally on compact flashcards and transmitted once every 6 hours via a mast-mounted satellite antenna to the GEOES satellite network, allowing engineers in Anchorage and Fairbanks to track stream flow trends, flood risks, and freeze-up progression in real time. Station 4 was the most isolated unit in the network, situated roughly 18 miles upstream from the mouth of the river near a narrow oxbow slough, known locally as Gold Bend, accessible only by flat-bottomed jet boat during high water, or by snow machine once the river and tundra had frozen hard enough to support heavy loads. When the anomaly first registered on our central terminal back at our staging site in Port Hayden, neither Marcus nor I gave it a second thought. Environmental sensors in Alaska are subject to an endless variety of physical disruptions. River ice can scour anchor lines, gravel bars can shift during high-volume storm surges, brown bears frequently chew through rubberized sensor cabling out of curiosity, and permafrost thaw slumps can choke intake tubes with thick, glacial slurry. The first automated diagnostic ping from Station 4 simply flagged an out-of-range pressure differential on Channel 3. The submerged hydroacoustic transducer that hung 3 feet off the riverbed inside a perforated steel housing designed to measure bottom current turbulence and sediment load. The reading suggested that the sensor body had experienced a sudden, static downward force equivalent to roughly 30 pounds of extra weight, followed immediately by an acoustic resonance that saturated the instrument's hydrophone channel. Marcus sat at the wooden table in the back of our rented field office, a weather-beaten, prefabricated trailer left behind by a long-defunct mining exploration company near the old Bubuyuki Fort Morrow gravel runway, sipping lukewarm coffee from an insulated mug while he reviewed the telemetry output on his ruggedized laptop. Outside, the wind was howling through the rusted steel trusses of an abandoned hangar across the road, a low metallic moan that had been continuous since we had arrived 10 days prior. The air inside the trailer smelled faintly of diesel exhaust from our backup generator, damp wool, and the sharp, oily scent of the solvent we used to clean our sampling gear. Sensor housing is probably jammed with slush, Marcus said without looking up from his screen, his gray-flecked beard illuminated by the blue light of the monitor. The ice is forming fast up in the shallows. A floe probably broke loose from the bank, dragged a willow sweep over the casing, and lodged a mass of anchor ice against the mount. It happens every year around the first real hard freeze. The pressure spike isn't sitting flat like an ice load, I said, leaning over his shoulder to track the mouse cursor across the graphical plot. Look at the baseline signal. It's dropping and resetting at exact intervals. It looks like a physical pump cycle or a mechanical oscillation. It's river ice, Ethan, he replied, shaking his head with the weary confidence of a man who had seen every possible way an instrument could fail in the bush. The river is slushing up. The flow is forcing ice chunks down into the oxbow and they're wedging themselves under the sensor arm. Once the main freeze sets in and locks the bed down solid, the noise will stop. If it doesn't, we'll run the jet boat up there tomorrow morning on the high tide, clear the housing, pull the card, and wrap up the season. We spent the rest of that evening preparing our cold weather gear and securing our primary staging area. Port Hayden is a small, close-knit community split between the main village site near the bay and the old White Alice radar site near the airport, home to roughly 100 residents, mostly Alutiiq, who have lived along the coast for generations. It is a place where self-reliance is not a philosophical choice but a basic requirement for survival. Help from the outside world is measured in hours or days, depending entirely on whether the fog off Bristol Bay allows an air taxi to land on the gravel strip. The people who live there respect the land and the ocean with a quiet, unpretentious seriousness, knowing that the environment does not forgive carelessness, stupidity, or arrogance. The following morning broke cold and gray, the sky heavy with bruised, purple-tinted storm clouds dragging low across the tundra. The thermometer mounted outside the trailer door read 18 degrees Fahrenheit, but the 20-knot northern breeze sweeping off the water dropped the wind chill well below zero, freezing the wet sand along the shoreline into a hard, brittle pavement. We loaded our gear into the 20-foot aluminum jet boat, a heavy, flat-bottomed craft powered by an inboard jet engine built specifically for navigating shallow, gravel-choked Alaskan rivers, and pushed off from the muddy boat launch near the river mouth just as the morning tide began to flood the delta. The Mesquite River at that time of year is a grim, beautiful, and unforgiving waterway. The lower reaches are broad and flat, winding through gray mud flats and low banks of frozen peat, where scattered clumps of yellow grass and leafless alder scrub clutch the edge of the water. As you travel upstream, the river narrows into a maze of shifting gravel channels, where black, volcanic sandbars hide just beneath the surface of the dark, sediment-heavy water, ready to ground a boat that strays even a few feet outside the main channel. Huge plates of shore ice, jagged and milky white, had already formed along the calm edges of the river, projecting out over the current like fragile shelves that cracked and boomed as the rising tide shoved seawater up into the river channel. I ran the boat from the stern console, wrapped in heavy rain gear over my goose-down parka, my hands protected by thick neoprene gloves that were already slick with freezing spray from the bow wave. Marcus stood forward, leaning against the bow rail with a long wooden pike pole, watching the water ahead for submerged logs, anchor ice, or shallow gravel spits. The sound of the jet engine was a loud, flat roar that filled the river corridor, drowning out the wind and the cry of gulls circling over the mud flats. It took us nearly 2 hours to make the 18-mile run up to Station 4, fighting against the downstream slush and the icy wind that hit us full in the face every time the river turned north. By the time we rounded the final bend into the Gold Bend Oxbow, the landscape felt impossibly vast and lonely. There were no cabins here, no power lines, no footpaths, and no sign that human beings had ever set foot on these banks, save for the tall, silver-painted steel tripod of our monitoring station, standing on a low gravel point overlooking the brown, swirling water. I throttled the engine down, letting the boat glide into the calm eddy beneath the point, and Marcus tossed our braided nylon bowline around the base of the station's steel leg, pulling the aluminum gunnel tight against the icy bank. The silence that fell over us when I cut the ignition was absolute and heavy, broken only by the continuous dry rustle of wind through the dead willow brush and the soft, slushy lap of water against the boat's hull. "Looks clean from here," Marcus said, stepping out onto the frozen gravel, his boots crunching loudly in the stillness. He walked up the bank to the main instrument box, a heavy weatherproof aluminum enclosure secured with a padlock and mounted 4 feet above the high water mark on the station frame. I grabbed our toolkit, a spare marine battery, and a portable field interface laptop, then scrambled up the slippery slope behind him. My toes were numb inside my insulated boots, and my breath billowed out in thick white plumes that vanished almost instantly in the dry air. "Check the satellite mast first," I said, wiping a thin layer of frost off the clear plastic housing of the solar regulator. "The data signal dropped entirely at 6 this morning. We didn't get the automated sunrise transmission." Marcus unlocked the enclosure, swung the heavy door open, and stared inside for a long moment without speaking. I stepped up beside him to look over his shoulder. The interior of the box was clean, dry, and cold. The green LED indicator light on the Campbell Scientific data logger was flashing steadily, showing that the system was receiving power from the battery bank. But the wiring harness for the lower sensor bus? The heavy, arm-thick bundle of shielded cable that ran down the station leg into the river water was pulled taut, stretched so tight that the heavy rubber strain relief boot had been torn completely free from the aluminum chassis. "Something snagged the lower cable," Marcus remarked, reaching in to test the tension on the wire with his gloved fingers. "Must have been a heavy piece of driftwood caught in the bottom slush." "A drift log would have snapped that 4-gauge cable clean off or pulled the whole mount loose," I said, kneeling down in the frozen gravel at the edge of the water to trace the path of the wire. The cable vanished into the dark, murky current, extending straight out into the deep channel at a steep, downward angle, taut as a piano wire. "Look at the angle. Whatever is holding that line isn't floating downstream. It's anchored up current, almost directly underneath the main piling." Marcus grunted, grabbed a heavy pair of pliers from the tool bag, and began disconnecting the interface cable so we could hook up the field laptop directly to the logger's serial port. "Let's pull the raw log off the internal memory before we mess with the anchor line. I want to see what the depth sensor was reading when the cable got yanked." I booted up the field laptop, shielding the screen from the sky with my jacket, and connected the interface cable. The software established a connection with the CR1000, and the status log scrolled across the screen in line after line of plain white text. Everything was normal up until 03:14 a.m. The water temperature had been holding steady at 31.8 degrees Fahrenheit. The river stage height was flat, and the hydroacoustic sensor was recording standard low-frequency ambient noise from the water flowing over the gravel bed. Then, at precisely 03:14:22 a.m., the hydroacoustic channel recorded a massive, instantaneous increase in ambient pressure. Not a sharp spike like a physical impact on the housing, but a smooth, rapid rise that doubled the ambient atmospheric equivalent load within 3 seconds. Immediately following that pressure change, the acoustic sensor recorded the first of the rhythmic pulses, a 25-pound physical strike against the housing, repeating every 4.2 seconds without variation. "Look at the turbidity log," I said, pointing at the second column of data on the display. The turbidity readings, which measure the clarity of the water by bouncing an infrared beam off suspended particles, had dropped to 0 the exact moment the pressure increased. The water around the sensor hadn't become muddy or clogged with sediment. It had become completely clear, as if all the silt and suspended glacial dust in that section of the river had been instantly cleared or suppressed. "That doesn't make any sense," Marcus muttered, leaning down closer to the screen, his brows furrowed. "If a log or a mass of slush knocked into the housing, it would kick up a cloud of bottom mud. Turbidity should have spiked off the scale. Why did the water go clear?" "And look at the acoustic recording," I added, switching the software view to the raw audio stream captured by the internal hydrophone. "That's not ice clicking or wood banging against steel. Listen to the wave file." I clicked the play button on the diagnostic software. The laptop's small internal speaker emitted a harsh, static-heavy hiss, followed by the deep, muffled sound of water moving over gravel. Then, rising out of the ambient sound, came the noise recorded at 3 in the morning. It was a wet, heavy, incredibly dense thud, followed immediately by a low, resonant vibration that sounded remarkably like a hollow wooden chamber being struck underwater. But beneath the impact itself, barely audible under the rushing water, was another sound. A wet, rhythmic sliding noise, like something heavy and soft being dragged slowly across thick frozen mud, accompanied by a faint sub-audible hum that made the laptop casing vibrate slightly in my lap. The thud repeated. 4.2 seconds later. Then again. 4.2 seconds. We listened to it in silence for nearly 2 minutes, standing on that cold gravel point 18 miles from the nearest human habitations, while the north wind swept through the tall grass around us. "It's a loose cable slapping against the steel piling in the current," Marcus said finally, though his voice lacked its usual certainty. He reached into his coat pocket, pulled out his tobacco tin, and put a chew between his lip and gum, his eyes fixed on the dark water where the cable disappeared. "The current gets weird in this oxbow when the tide backs up the lower river. It creates a standing wave underwater. The cable was probably humming in the flow, bouncing against the leg structure. The piling is 3 feet to the left of the sensor housing, Marcus," I reminded him quietly. "And the cable isn't loose. It's pulled tight toward the middle of the river." He didn't answer right away. He walked down to the edge of the water, took hold of the taut sensor cable with both hands, and gave it a sharp, vertical tug, trying to lift the submerged sensor housing off the riverbed. The cable didn't move. It was anchored to the bottom as solidly as if it had been set in concrete. "Must be wedged under a submerged boulder," Marcus said. His teeth gritted as he put his foot against a frozen rock and pulled harder, his shoulders straining against his heavy coat. "Help me pull this damn thing up. If we can't free it, we'll have to cut the cable, splice a new head on, and drop a replacement unit." I stepped down beside him, grasped the wet, freezing rubber line behind his hands, and pulled back with all my weight. The line was rigid, humming slightly under the extreme tension, like a thick steel hawser on a tugboat. As we pulled, I looked down into the clear, ice-cold water near the bank. The river was perhaps 4 feet deep at this spot, the bottom composed of dark volcanic gravel and smooth oval stones coated in a thin layer of brown algae. As I stared into the water, trying to trace the path of the line, I saw something that made me stop pulling. Directly beneath the point where the cable disappeared into the deep water, roughly 6 feet out from the bank, the riverbed was not covered in normal gravel. A smooth, perfect oval patch of dark silt, roughly 6 feet long and 3 feet wide, lay pressed into the bottom, completely bare of rocks, weeds, or algae. The gravel around the edge of this patch had been pushed outward, forming a clean, raised ridge, as if a massive, heavy object had rested on the mud with tremendous force, clearing away all loose material before lifting off again. And in the very center of that cleared silt patch, submerged under 4 feet of ice-cold running water, were 3 parallel curved grooves cut deep into the underlying blue clay. Grooves that looked precisely like the mark left by giant, blunt fingers dragged through soft mud. "Marcus," I whispered, pointing down into the stream. "Look at the bed." Marcus looked down. He stared at the dark oval in the silt for a long moment. The wind picked up, driving a sudden scatter of dry snow pellets across the surface of the river, pitting the dark water and obscuring our view of the bottom. "Current eddy," he said abruptly, letting go of the cable so suddenly that I nearly lost my balance on the slick rocks. The jet boat's intake created a scour pattern when we pulled in. "We're wasting time, Ethan. The tide's going to turn in an hour, and if we get caught in this oxbow with the water dropping and the slush coming down, we'll be stuck hauling this boat over gravel bars in the dark." He turned and walked back up the bank toward the instrument shelter, his movements unusually quick and jerky. He didn't look back at the water. He pulled a pair of wire cutters from his belt, reached into the aluminum cabinet, and severed the lower sensor cable with a sharp metallic snip. The tension on the cable vanished instantly. The loose end snapped back into the water, splashing cold droplets across my face, and slid slowly down into the dark depths of the river, vanishing into the current without a sound. "Pack up the laptop," Marcus said. His back turned to me as he closed and padlocked the aluminum cabinet door. "We're heading back to the trailer. We'll report the station as offline due to river ice damage and order a new sensor head from Anchorage for the spring." I didn't argue with him. I packed the laptop into its padded, waterproof case, disconnected the backup battery, and carried the gear back down to the boat. But as I stepped aboard, I couldn't stop myself from looking back at the spot in the river where the cable had gone down. The water was turning murkier now as the tide began to slacken, but through the dark, swirling current, I could still see the smooth, oval depression in the silt. And as I watched, a single broad bubble of air, or some other gas, rose from the center of those deep grooves in the clay, drifted slowly to the surface, and popped against the hull of our boat with a tiny, dry sound that was lost in the rising wind. We made the run back to Port Hayden in near silence. The wind had shifted around to the northwest, bringing a dense, freezing fog off Bristol Bay that hung low over the river, reducing visibility to less than 50 yards. I kept my eyes fixed on the faint dark line of the riverbank, navigating mostly by memory and the shallow water sonar on the boat's dash, while Marcus sat on a cooler near the bow, his collar turned up around his ears, staring straight ahead into the gray mist. By the time we tied the boat up at the village landing and loaded our tools into the back of our rented four-wheel drive pickup, twilight had settled over the peninsula. The village lights, sparse yellow bulbs glowing weakly through the cold fog, looked distant and lonely, scattered along the flat coast like dying embers. We ate a quiet dinner in the field trailer, canned beef stew heated on a small propane camp stove, washed down with black coffee. Marcus spoke very little, spending most of the evening sitting at his desk, rereading the paper field manuals for the GOES telemetry transmitters, as if he were trying to find an error in the wiring diagrams that he had missed for 25 years. Around 9 o'clock, the radio on the desk, a VHF marine transceiver we used to monitor local boat traffic and weather updates from the National Weather Service, emitted a loud crackle of static, followed by the broken digitized voice of the automated weather station down at the Port Hayden airfield. Port Hayden visibility, 1/4 mile, freezing fog, temperature 16 degrees, wind northwest at 22 knots, gusting to 34, sea surface temperature 32 degrees. Then the voice dropped out, replaced by a low, rhythmic, pulsing static that had the exact same 4.2-second cadence as the recording we had taken off Station 4 that morning. I froze with my coffee cup halfway to my mouth. Marcus stopped typing on his laptop. He didn't look at the radio, but I saw his shoulders tighten under his flannel shirt. The static pulsed 3 times. Thud, 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 and then cut off entirely, leaving only the quiet, high-pitched hum of the radio's internal amplifier. "Interference from the radar site," Marcus said flatly, his voice hard and dry. "The Air Force left a lot of ungrounded copper wire buried under the gravel when they pulled out in the 80s. The salt air rots the insulation, and when the moisture hits it, it creates a feedback loop across the VHF channels. The radar site is 3 miles south of here, Marcus," I said, setting my mug down on the table, "and those frequencies don't cross over onto marine VHF. "It's ground noise, Ethan," he snapped, turning his head to glare at me, his eyes wide and bloodshot in the lamplight. "This whole peninsula is built on volcanic ash, frozen peat, and junk left behind by the military. You spend enough years out here, you hear all kinds of crazy shit on the radios. It's electrical noise, that's all it is." He stood up, kicked off his boots, and pulled his sleeping bag up over his shoulders on the small cot in the corner of the trailer, turning his back to the room. "Turn the radio off. We've got to haul the boat out tomorrow before the harbor freezes solid." I reached over and switched off the VHF radio, but I didn't go to bed right away. I pulled up the system log on my laptop, opening the live telemetry monitor for the remaining 3 stations in our network. Station 1, near the river mouth, was operating normally. Station 3, 7 miles upstream, showed nominal readings. Then I opened the screen for Station 2. Station 2 was located 14 miles upstream from the village, sitting on a high, rocky bluff overlooking a section of the Meshique where the river cuts through a series of steep, gravel terraces created by ancient glacial moraines. It was equipped with an air-gap acoustic radar, a non-contact sensor mounted on an arm extending over the water that used ultrasonic sound waves to measure the river's surface height without touching the liquid. The line graph on the screen for Station 2 was flat until 08:30 p.m. Then the surface level plot began to show a series of rapid, vertical spikes, not smooth, undulating wave motion, but sharp, jagged steps where the measured surface height dropped by 3 feet, held that level for precisely 4.2 seconds, and then rose again. Something was passing directly beneath the sensor arm, displacing the surface of the river in a regular, mechanical rhythm, moving slowly upstream against a 4-knot current and a 20-knot headwind. I calculated the rate of progression based on the timestamp of the spikes. Whatever was creating that displacement was moving upstream at a steady pace of 1.2 miles per hour. At that speed, if it kept moving along the river channel, it would reach the Gold Bend Oxbow and Station 4 by midnight. And if it kept going past Gold Bend, following the shallow tributary that ran back toward the mountains, it would pass within 400 yards of the small, timber frame emergency shelter cabin used by fish and game technicians during the autumn salmon runs. The cabin where Marcus and I were scheduled to spend 2 days next week while servicing the upper watershed sensors. I sat in the cold trailer for an hour, watching the blue dot on the screen step rhythmically across the grid lines, until the display finally froze as the satellite signal faded behind the rising storm clouds off the coast. 2 days later, the storm hit the peninsula in earnest. A powerful Bering Sea low-pressure system parked itself right over Bristol Bay, bringing 50-knot winds, driving snow and temperatures that dropped into the single digits. The sea spray blowing off the ocean froze as it hit the land, coating every building, power pole, and dry willow stem in Port Hayden with an inch-thick layer of clear, heavy ice. Flying was completely grounded. The small twin-engine mail plane that flew in from King Salmon twice a week was turned back at Dillingham, and the local state trooper post issued a winter travel warning advising everyone in the village to remain indoors and secure their fuel tanks. Because our field contract required us to maintain continuous data monitoring throughout the transition period, Marcus and I were stuck in the trailer, surrounded by the smell of kerosene, dry rations, and our own unwashed clothes. The snow drifted up against the windward side of the trailer, covering the low windows and cutting off the pale daylight, so that we lived in a perpetual, yellow-lit, artificial night, powered by the steady, clattering roar of our generator outside. Marcus spent most of those 3 days sitting on his cot, staring at the floor, or reading old paperback westerns he had found in the trailer's storage cabinet. He spoke only when necessary, his answers short and clipped. He had stopped drinking coffee and had taken to checking the latch on the heavy steel trailer door every 20 minutes, turning the handle back and forth to make sure the deadbolt was fully engaged. On the third night of the storm, October 28th, the main generator died. It didn't sputter or run out of fuel. It simply stopped with a loud mechanical clunk that echoed through the thin walls of the trailer. The lights went out instantly, plunging us into absolute pitch-black darkness accompanied by the immediate overwhelming rush of the wind howling outside. "Ethan!" Marcus's voice came out of the dark, sharp and breathless. "Where's the flashlights?" "On the bench," I said, reaching out into the dark, my fingers scraping across the cold aluminum edge of the work table until they closed around the rubber grip of my heavy LED lantern. I clicked it on, casting a harsh, brilliant white beam across the room. Marcus was standing by his cot, clutching his heavy parka to his chest, his face pale and slick with sweat, despite the cold air that was already beginning to seep into the room through the floorboards. "I'll go check the generator," I said, pulling on my heavy gloves and grabbing my parka from the hook by the door. "It's probably just a frozen fuel line or ice in the air intake." "No," Marcus said, taking 2 quick steps across the room and grabbing my forearm with a grip so tight I could feel his fingers through the thick canvas of my sleeve. "Don't open that door." I looked at him in the beam of the lantern. His eyes were wide. The pupils dilated until there was hardly any blue left in them, staring past me toward the heavy steel door. "Marcus, it's 20 below zero outside with the wind chill," I said calmly, trying to keep my voice steady. "If we don't keep that generator running, the heating pipe in the trailer will freeze and burst within an hour, and our laptop batteries will die. We need power." "Listen," he whispered, his head tilted toward the floor. I stood still in the freezing room, holding my breath, listening past the roar of the wind against the metal siding. At first, I heard only the familiar sounds of the storm, the rattle of the metal roof panels, the hiss of dry snow driven against the glass, the deep structural groan of the trailer frame flexing on its wooden skids. Then, beneath those sounds, coming from directly under the floorboards near the front tongue of the trailer, I heard it. It was not the sound of wind or blowing snow. It was a wet, heavy, rhythmic suction noise, the sound of something massive moving through the thick, half-frozen mud beneath the trailer's skirt, accompanied by a low, dull thud that vibrated up through the soles of my rubber boots. Thud. Pause. Thud. The interval was exactly 4.2 seconds. The trailer frame shifted slightly, leaning 2 inches to the left as if an immense weight had been placed on the tow hitch outside, then settled back down onto its wooden blocking with a loud, creaking groan. Marcus let out a low, ragged gasp, dropping his parka to the floor, and backed away until his shoulders struck the rear wall of the trailer. I stood frozen in the middle of the room, the flashlight beam locked on the bottom edge of the steel door. The weather stripping along the threshold was torn and dry, and through the tiny gap between the metal frame and the floorboards, I saw something moving. It was not snow. It was a thick, dark liquid, a dense, oil-like silt that smelled faintly of rotten vegetation, ancient swamp clay, and deep-sea sediment, oozing slowly under the door frame, driven not by the air pressure outside but by a heavy, mechanical displacement that forced the sludge up through the frozen gravel beneath the trailer. I stepped forward, raised the heavy iron latch bar on the door, and shoved it downward into the locked position with a loud metallic clack. The moment the latch engaged, the rhythmic thudding beneath the floor stopped. The silence that followed was terrifying. Even the wind outside seemed to drop for a brief, breathless moment, as if the entire peninsula had held its breath under the weight of the storm. Then, from the side of the trailer, where our 200-gallon propane tank was anchored to the metal chassis with heavy steel bands, came a low sound of metal being bent. Not broken, not struck, but slowly, inexorably crushed under a static load that exceeded the tensile strength of 3/8-inch rolled steel. A high-pitched hiss filled the air as the primary pressure regulator on the gas line ruptured, venting the cold, mercaptan-scented propane gas directly into the blizzard outside. "Ethan!" Marcus choked out from the corner, his hands pressed over his face. "Ethan, make it stop. Tell them we're done. Tell them we're leaving." I didn't answer him. I couldn't. I dropped the heavy LED lantern onto the work table, pointing its beam toward the door, walked over to the small storage locker near the back of the room, and pulled out our emergency satellite phone, an Iridium handheld unit housed in a rugged orange plastic casing. I powered it on, my hands trembling so violently I could barely hit the rubber keys, and waited for the screen to search for a signal. Searching for sky. Searching for sky. The antenna was obscured by the 3 feet of heavy, wet snow that had drifted over the roof of the trailer. There was no line of sight to the satellite constellation. I ran to the small vertical ladder near the rear window that led to the emergency roof hatch, a 2-foot square metal scuttle designed for clearing snow or escaping a winter collapse. "Don't open it!" Marcus screamed, scrambling across the floor toward me, grabbing at my knees. "Don't go up there!" I kicked my leg free, grabbed the latch handle on the hatch, threw my weight upward, and shoved the heavy panel open. A wave of blinding snow and sub-zero air rushed down into the trailer, instantly smothering the smell of propane and kerosene with the crisp metallic scent of frozen ocean water. I poked my head and shoulders out through the opening, shielding my eyes with my arm against the stinging horizontal snow that whipped off Bristol Bay. The world outside was a white, screaming void. The village lights were completely gone, swallowed by the drift. The hangar across the road was invisible. Even the front hood of our pickup truck, parked 10 feet from the trailer door, was buried beneath a smooth, parabolic mound of snow. I raised the satellite phone over my head, extending the thick black antenna toward the gray sky, waiting for the signal bar to illuminate. As I stood there, half out of the hatch, the wind shifted for 3 seconds, clearing a narrow corridor through the swirling snow directly in front of the trailer. And in that brief, terrifying gap in the storm, I saw what was standing beside our vehicle. It was not a beast, it was not a man, it was an absence. A broad, vertical pillar of sheer, absolute silence, roughly 8 feet across and extending upward into the dark storm clouds, where no snow fell. The driving wind and horizontal ice pellets passed around this space as if striking a solid, invisible cylinder, cascading away in swirling eddies of white dust, leaving the interior of that space completely still, dark, and dry. At the base of this pillar, resting on the frozen gravel where the snow had been swept entirely clear in a perfect 8-foot circle, was a deep, smooth impression in the tundra, an oval depression filled with clear, dark water that was not freezing, despite the 8-degree temperature. And from the center of that water, 2 thin, black lines of thick volcanic silt were spreading outward across the white snow, moving steadily toward the foundation pilings of our trailer, leaving deep, narrow tracks that looked as if 3 blunt fingers had been dragged through the ground. The satellite phone in my hand beeped, a sharp, high-pitched electronic chime indicating it had acquired a 3-satellite lock. The invisible column shifted. It did not walk. It did not slide. It simply displaced its position by 4 feet, moving with that same horrible 4.2-second rhythm toward the side of the trailer where I was hanging out of the hatch. As it moved, the sound of the wind was instantly cut off, replaced by a sudden, violent drop in atmospheric pressure that made my ears pop with a sickening click. The air around my face turned impossibly cold, a dead, dry subterranean cold that felt as though it had been drawn from miles beneath the frozen earth, and my lungs seized up, unable to pull in oxygen. I dropped through the hatch, slamming the heavy iron panel shut behind me, and fell onto the wooden floor of the trailer, gasping for air, my heart hammer pounding against my ribs. Marcus was lying on his side on the floor, his knees pulled up to his chest, his hands clutched over his ears, sobbing silently in the dark. I crawled across the floor, grabbed the satellite phone off the table where I had dropped it, and dialed the emergency speed dial code for the Alaska State Trooper dispatch post in Dillingham. The line connected. The ringtone was long, clear, and steady. Once, twice. On the 3rd ring, the line picked up. Dillingham Trooper Dispatch, this is Officer Callahan. Go ahead. This is Ethan Vance, I shouted into the small microphone, my voice cracking with hysteria. I'm a USGS contractor at the Port Hayden field site. We need immediate search and rescue evacuation at the trailer near Fort Morrow Strip. Our power is gone, our fuel line is destroyed, and we have a structural emergency. There was a long pause on the other end of the line, broken by the faint, rhythmic crackle of satellite static. "Station Vance," the trooper's voice came back, sounding calm, distant and thin. "We have your location on GOES tracking. The weather across the peninsula is currently below 00 minimums. All rotary and fixed-wing aircraft are grounded out of King Salmon and Cold Bay until the front clears, which isn't expected for another 36 hours. Do you have secondary shelter or a winter survival kit?" "You don't understand," I screamed, leaning my forehead against the cold metal leg of the work table. "There's something outside the trailer. It smashed the propane lines. It's under the floor." The line fell silent for 4 seconds. When Officer Callahan spoke again, his tone had changed. It was no longer professional and routine. It was flat, heavy, and tired. The voice of a man who had lived on the peninsula long enough to know when words were no longer useful. "Ethan," he said softly, using my first name for the first time. "Lock the deadbolt. Turn off your lanterns. Stay in your sleeping bags together to keep your core temps up, and do not go outside to check the generator until sunrise. We will have an air taxi in from King Salmon the minute the ceiling lifts to 10,000 feet. Do you copy?" "It's touching the floorboards, Callahan," I whispered. "I copy your situation, Ethan," he repeated, his voice fading under a sudden surge of radio static. "Stay inside. Keep the door locked. We'll be there when the storm clears." The connection dropped. We survived that night because human bodies, when wrapped in heavy goose-down sleeping bags and pressed together in the corner of a sealed, insulated box, generate just enough ambient heat to keep blood moving through cold limbs. We did not speak. We did not turn on the flashlights. We lay there in the dark, side by side on the floor behind the workbench, listening as that heavy, rhythmic thud moved slowly, methodically around the perimeter of the trailer every 20 minutes until roughly 4 o'clock in the morning. Each time it passed the front door, the heavy steel latch bar would vibrate in its frame, and a thin, wet layer of dark silt would seep 1/8 of an inch further across the floorboards, bringing with it that sharp, subterranean smell of frozen mud and deep-sea decay. At 04:12 a.m., the thudding stopped. Not gradually and not by moving away into the tundra. It simply ceased between one 4.2-second interval and the next, leaving only the loud, continuous roar of the Bering Sea gale sweeping over the roof. The storm broke late the following afternoon. By 3 o'clock on October 29th, the heavy snow clouds had been driven south by a cold, dry Arctic air mass, leaving a clear, brilliant blue sky over the white, wind-scoured expanses of the Alaska Peninsula. The sun dropped toward the horizon in a blaze of harsh golden light, casting 40-foot shadows from the power poles across the buried gravel roads. A private search and rescue air taxi, a high-wing, ski-equipped de Havilland Beaver, flown by a veteran bush pilot from Dillingham, landed on the Fort Morrow runway at 4 in the afternoon. When the pilot and 2 local troopers dug out the front door of the trailer and shoved it open, they found Marcus and me sitting on the floor in the dark, wrapped in our sleeping bags, our skin pale and blue-lipped from mild hypothermia. We were evaluated at the small village clinic in Port Hayden, then flown out to Anchorage the following morning on a regional cargo flight. The official report filed by the Alaska State Troopers logged the incident as a severe weather distress event resulting in structural damage to field facilities, propane fuel system failure, and cold exposure. The dark silt inside the trailer was noted as meltwater runoff mixed with peat soil caused by wind-driven snow intrusion through degraded door weather stripping. The damage to the propane regulator was attributed to ice loading and metal fatigue caused by extreme wind vibration. Marcus retired from the United States Geological Survey 3 weeks after we returned to Anchorage. He sold his home in Eagle River, packed his belongings into a trailer, and moved to a small town in eastern Oregon, 200 miles from the nearest ocean or navigable river. He refused to fill out the final field debriefing paperwork, and he has never returned my phone calls or emails in the 8 years that have passed since that autumn. I resigned from field operations 6 months later, taking a desk-bound position with a private civil engineering firm in Anchorage, analyzing municipal stormwater runoff data and city sewer maps. I prefer working in an office with concrete floors, fluorescent lights, and 300 miles of asphalt between me and the nearest river delta. I have never been back to the Alaska Peninsula. I have never gone back to Port Hayden, and I never will. The binary data file from Mishik Station 4 sits on that flash drive in my desk drawer. I have never deleted it, though I do not know why I keep it. Last winter, in December of 2025, the USGS completed a comprehensive overhaul of its historical environmental telemetry archives, converting old field logs from retired stations into a unified, cloud-accessible database for public hydrological research. Because my name was listed as the original technician of record on several Lower Peninsula Station files, I was sent an automated system notification email containing a link to the archived raw data streams for the Mishik River network. Out of a morbid curiosity that I instantly regretted, I clicked the link, logged into the secure server, and accessed the historical file for Mishik Station 4, the station we had cut the line on, decommissioned and physically removed from the tundra in the spring of 2017. The station leg was gone. The steel frame had been dismantled and hauled away by barge years ago. The site at Gold Bend was nothing now but a bare gravel point overlooking a changing river channel that had long since shifted its oxbows. According to the official system database, Station 4 had been classified as deactivated, removed for 9 years. I scrolled down to the bottom of the data log. There, tucked below the final entry from October 2016, was a single line of raw telemetry data, a short 4-byte binary ping received by the GeoES West satellite server on November 12, 2025, at 03:14 in the morning. The ping contained no temperature readings, no conductivity measurements, and no turbidity scores. It contained only 2 data fields. Field 1 was an acoustic pressure reading, a static downward force equivalent to 25 pounds, repeating at an interval of 4.2 seconds. Field 2 was a GPS elevation coordinate for the sensor housing, 42 feet above ground level, moving steadily inland across the wet tundra toward the mountains at a speed of 1.2 miles per hour.